All right, everyone. Welcome to the Superintelligence for Humanity. We have just started. It is 10 a.m. on the East Coast, early on the West Coast. And for the folks in Japan, if you're up, then congratulations, you're the winners of today. So, this is a gathering of friends who are establishing artificial collective intelligence, which we'll refer to as shorthand as ACI often. And this is really a mature research direction beyond monolithic models, large scale AI agendas that we're already familiar with. And the conference, the point of today was really to gather who are the people who we need in the room to talk about how do we create this shared infrastructure, this cognitive infrastructure, systems that can preserve tacit expertise, maintain provenance and consent, and enable this collective intelligence across human and AI, and most importantly, under governance. And so this is hosted by Cognizy, a public benefit corporation whose charter advocates for a humanity-aligned superintelligence. And I'm your MC, Tricia Wang. I'm a sociologist and ethnographer who's been studying how humans trust technology. And I'm also the CEO of Advanced AI Society, an industry association for verifiable AI, which is really to figure out how do we actually even keep AI interactions trustworthy. And so this is an invite-only conference. It's a hybrid format. We're starting out online, and then we're going to start adding all the folks that are in person. And I think we actually have a few in-person people on the Harvard side. And so here's how today's going to work. We have a long day, so it's a marathon, but it's a really exciting conversation. We have 6 sessions across a span of 12 hours, multiple time zones. And with each one, we're going to open up with a session with a moderator where I will introduce a moderator and then hand it off to them, who will really treat this not as so much a panel, but think of it more as like a salon style, since we are amongst friends and we were really trying to figure out the answers to establishing this field of ACI. So we want to hear interruptions. We want to have, this be like a organic conversation as if we were in person. We want to have disagreements and do these kind of real-time interactions and not be, no soft panel questions here. So we'll be monitoring the YouTube. So if you have questions, please leave them there. We'll be pulling them in. And so the main objectives today, before we move into the host or the host of the day, is the first objective is to establish ACI, artificial collective intelligence, as this mature research direction. And the second is to clarify what are the technical and institutional foundations of the shared context, which would include semantic coordination and provenance and consent and revocability and governed abstraction exchange. And the third is we're going to examine why tacit expertise and institutional memory are really very critical, and though they're quite resistant to quantification. So how do we ensure that this type of expertise that is collectively owned, how do we capture in a way where we can also develop trust with the community, and that they're not just based on consent, but actually active participation? And lastly, we're here to produce a concise ACI agenda with a clear list of what are the open problems that we're seeing as the most highest priority. We're going to look at evaluation milestones and pilot designs and follow up with a joint paper pathway. So now I want to introduce us to our host of today, the 3 co-founders of Cognizy who have brought us here. First, I'm going to have Olaf Witkowski, who's a founding director of Cross Labs in Kyoto, and your bio is so long, but he's also the president of the International Society for Artificial Life, and he teaches and runs a lab at the University of Tokyo. So I'm not going to go through the rest of the stuff. You should find him online. But the interesting fun fact is I found out that Olaf and I have a shared interest in studying Peru. We are early on in Olaf's career, he was looking at many of these systems and topics to Peru, and it's a place I also opened up a lab in. So I'm really excited to turn it over to Olaf.
Thank you, Tricia, and thank you everyone for being here. I want to start by saying that this summit today and tomorrow is deliberately a little bit unusual. So it's not your standard AI conference here. It's not kind of any kind of technical AI launch or anything like this. It's a really a working experiment. So we are bringing together people who normally sit in different rooms, different conversations. So AI architecture, artificial life, my field, especially collective intelligence, security, consciousness, even linguistics, human flourishing, and I guess cultural memory, how to preserve the knowledge of humanity and institutional governance. And we're asking whether they are actually looking at different parts of the same problem and how to address this, and how to address artificial collective intelligence together. For me, the problem is this. Intelligence doesn't appear only inside individual minds or individual models, right? So in biology, intelligence would appear through cells coordinating into bodies, organisms coordinating into ecologies, and so on, and people finally coordinating through culture, language, institutions, rituals, the tools they build, memory and trust, like Tricia would just mention. The history of intelligence on Earth is not only a history of bigger and bigger brains, and it's a history of new forms of coordination. And I think today, I'm very excited to have all the perspectives from everyone. And that's why I'm using this phrase of artificial collective intelligence today. And we're talking about how to build it, how to understand it, and how to also do it all right. So we don't simply talk about multi-agent systems, and we don't mean it as a loose metaphor for just collaboration, right? We mean the possibility of a new layer of AI infrastructure. So systems that help humans, agents, and institutions all around the world reason together. So preserving provenance, respecting consent and revocability, encoding tacit expertise in there, and really coordinating under uncertainty. So the question is not whether AI will become powerful. Yeah, it already is. The question is whether powerful AI becomes sort of opaque or isolated and extractive, just digitizing the books and burning them, right? So that's the opposite of what we want to get to. So I come to this from the A life, artificial life, and collective intelligence perspective originally, and that's where the central lesson is that intelligence is rarely monolithic, like what a lot of people seem to be investing in very heavily at the moment. On the contrary, it's distributed, adaptive, and embodied, and often vulnerable and fragile, and evolving constantly. And that's the challenge. The challenge is not only, I guess, to build more capable systems, but also to understand how intelligence really scales without losing diversity, agency, memory, and meaning. So today, I hope that we can be ambitious, but also careful. So ACI is not a finished answer. It's a research agenda, and we are here to test it together. And that's why we have all those perspectives on the panels today. And if we succeed, the output of this summit should not just be a recording or a set of interesting conversations. It should really form the beginning of a serious roadmap. So open problems, benchmarks, pilot collaborations together. And eventually, I'm aiming at a joint paper for us today that can help define the space. And yeah, thank you all for being part of this first step. And yeah, I'm passing it back to Tricia, who, by the way, is one of the people working in AI governance, who started as an ethnographer, not as an engineer. And she spent years inside communities in China, Latin America, enterprise boardrooms, studying how people actually make decisions, what they trust and what they don't. Yeah, passing that to you.
Well, Olaf, this is why I've been such a fan of your work for so long. Even when I left academia, I kept seeing, your work evolve over time. So it's really exciting to be able to be in the same room with you. When I left academia, I went into enterprise because I said, this is where the power lies in terms of where big data was. All the intensive focus on quantification. And so I saw what happened on the enterprise side when companies assumed that everything valuable was measurable. And so when I met Amer, it was really exciting because he's the one who brought me into this world. And he's one of the rare executives I've met in this space where he's not just, understanding only the tech, but he actually understands the humans and the heart and the systems around it. And he really understood right away when I talked to him about thick data, where I'm like, hey, there's data that is resistant to quantification that can't just fit in a spreadsheet or can't just fit in a data warehouse. So it's just really exciting to me. When I first met Amer, I think it was almost a year ago, he started talking to me about some of the stuff he's researching. So I would like to introduce Amer. He is really, like I said, on the applied side, one of those rare executives who is taking all this frontier technology and saying, what does it mean for businesses? So he's been evolving that frontier research and then implementing it in the real world. So I want to, Amer, please give us a few words following Olaf.
Yeah, thank you, Tricia, and thank you, Olaf, and thank you everyone for joining this crazy mission that we are embarking on, and essentially it comes from a lot of dialogue with people like Olaf and Tricia and Ujwal and many more that are joining this conversation today. I was at NeurIPS last year and walking around the room, and it felt like the research is stalling. And then the AI, the potential for AI is just so much out there. And then many of the research I spoke with, they were just getting tired of the same old, and just small incremental improvement over the existing paradigms. And there were a few questions that were consistently being asked, not so much into the paper presentations, but in the hallway conversation. It was around, why are we building these things? What is the purpose? What is our role in society? What is the impact of these technologies, not just on Earth, but on our future generation? So there was an very interesting, almost like an existential question in the room, right? And the second part of the question was also around, who does today's AI represent? And I think that's quite a profound question. I think if we look at the data that has been sourced in to train, and we're talking AI here loosely and largely talking about modern paradigms, LLMs, and things like that. And then the representation essentially was another big issue that was being discussed. And we all understand that the corpus for today's training is quite shallow. It's very low signal density, and it doesn't really represent the diversity of the planet, like the life on the planet, right? And our customs and social and cultures and languages and practices and actions, right? So that leads to the other bigger problem which is in grounding. Who is grounding it? Who's grounding it's based off of, right? So that means there is a lot of perspective pushing, and that is happening right now. And the third question that came up was around alignment. So alignment right now is still fairly post-training model adjustments and behaviors, right? Things like that. And whereas the alignment just does not represent hyper-localized context, an alignment of a farmer's perspective on dryland agriculture from Tanzania versus parts of Africa, versus other Northern Africa, versus parts of even in the Midwest of the US, right? So alignment perspective was being discussed extensively, in fact, again in the hallways, as the missing layer, and that kind of gets into the governance, right? And lastly, the question around monolithic systems as they're evolving, right? Again, what I learned from Olaf is also that nature shows us that, again, also from an evolutionary biology, that nature evolves. The process of evolution is distributed. Like we learn from a varieties of things, right? And the evolution is distributed. And whereas today's approach to intelligence is not so. And that kind of leads us into the aspect of collective intelligence. So if the intelligence is collective and not just collective in the sense that is the society as a collective, but also at individual level, we should think about at individual level. Every human expert, we are constantly observing and experiencing life, right, as we move through it. And we are tapping into a varieties of domains, whether we are doing that intentionally or unintentionally. But the output or an inference in a complex situation where intelligence or wisdom is required in decision making, there is a collective process happening inside, like cognitively as well at individual level. And there's then again a collective process that's happening at the community level and at the society level. So the question that we're asking from a research perspective is, does today's AI and today's paradigm to advanced AI represent human cognition? Does it represent essentially not just the cognition, but the collective of the society on how the cognition kind of evolves for it? And what is that next era of AI should look like that represents humanity essentially? And if it represents humanity, then it will serve humanity, right? The question that researchers are asking, why are we building, who are we building this for, and what is the impact of this, right? So I think we have to address those questions head on. So in a way, we want to propose this ACI or artificial collective intelligence research thesis as a missing governed, basically collective intelligence layer, right? And then within that, we have to understand and then shape out what is that human and AI institutions, essentially accountability and governance look like. So accountability in this case, what is the social contract of human and AI? Like we have a social contract of human to human, but what is the social contract of human to AI? And then those are the questions that are at least on my mind. And then I hope that through this dialogue, we can further articulate these and generate research thesis. And I'm looking forward to also then taking in these research thesis and actually building solutions that serve humanity. Back to you, Tricia. Oh, you're on mute, I think.
Let me unmute myself. I'm going to have to get better about that throughout the whole day. So I'm really happy that you met Olaf, someone who matches your level of ambition. Olaf talked about how important it is for us to be ambitious, but also to be careful at the same time with the fragility of the human life that we are capturing in these systems. And I think certainly your take on this is so rare, but also I think there's a growing contingent, right, of people who are saying this is not enough, like we are stalling. And I know that this is why you are also in a very shared like mind with Ujwal Kumar, who is also co-founder of Cognizy, and he is an innovation ecosystem builder based at Harvard. And he's also working at the intersection of all of these issues, especially around governance and policy, and also the actual technology itself. He founded Quantum Alliance, which is a Harvard MIT nonprofit that's focused on getting, actual technologies that we're talking about here from lab to market. And he's also worked with the UN, FAO, and the German Foreign Office. And he's just been at the center of all of these places that we've all been around. But he's actually, bringing all these faces together. So I'm really excited to turn it over to Ujwal Kumar. I know you had some words you wanted to say to follow up on this new kind of ambitious research agenda that we're outlining today. Turning it over to you.
Thank you so much, Tricia. So I want to do something slightly different with my few minutes. Olaf just laid out the scientific arc. ML framed the ACI thesis very well. I'm not going to restate either of those. Instead, I want to tell you what brought me personally to this room. I have spent a good part of my career inside institutions that are supposed to coordinate knowledge at scale. The UN system, foreign ministries, universities. And the thing I keep noticing over and over is a gap that nobody quite names. We have models that can pass the bar exam. We have systems that generate code, summarize research, draft legislation. And yet, if you ask a basic question like, who decided this model could train on that community's knowledge? Can we verify that? Can we revoke it? The answer is usually silence. Not because people do not care. People do care. We have seen it. But the infrastructure to answer those questions does not exist yet. This is what brings us here. This is what this summit is about for me. Not bigger models, not faster inference, the missing layer underneath all of that. The institutional infrastructure for accountability, for consent, for provenance, for collective coordination between humans and AI systems. And I want to put two words on the table that I think matter for what we are building. The first is dignity. And I mean something very specific by that. I mean that a person's knowledge and expertise are not just raw material for the system to ingest. A farmer in West Africa whose family has worked the same soil for generations, a surgeon in Mumbai, a climate modeler in Sao Paulo, the expertise carries authorship, it carries context, it carries decades of embodied judgment. And if we build collective intelligence that treats all of that as a training data, we have not built intelligence. We have built extraction. This is what I personally feel. The second is sovereignty, not just data sovereignty in the compliance sense. I mean the question of whether communities, institutions, nations actually get a meaningful say in how their knowledge is represented and governed inside these systems. Not as an, sorry, not as an afterthought, but as a checkbox, as a design requirement from day one. These two ideas, dignity and sovereignty, are why we named this summit, why we named it. Superintelligence for humanity, not superintelligence as a race to the most powerful system. Superintelligence as a collective capacity with humans in the loop, with accountability, with the ability to say no. So, what are we actually trying to do over the next 2 days? I will keep it simple. We want to leave here with three things. A joint paper that articulates the ACI research agenda and honestly including where we disagree. A set of benchmarks, real evaluation milestones, so that this does not remain a conversation about values with no way to measure progress. And three, so the third one, probably a couple of pilot collaborations with names attached, and that people in this room and in the summit are willing to carry forward with at the session ends. This is what turns a summit into a working group for me, and this is the bar I hope we hold ourselves to. One last thought before I hand it back to Tricia. As you listen today, I would ask you to carry two questions with you. What is the strongest open problem you hear? And what would you be willing to work on when this is over? Thank you. This is all, Tricia.
Ah, how inspirational. I didn't even want you to stop. I mean, you mentioned the words dignity and sovereignty, and that is at the heart of what we're doing. I mean, I think really what you're talking about, I mean, Emma will relate, is that part of it is that we cannot be deploying AI as if we're just deploying databases left over from the ad world, right? Like this is, we have not fundamentally shifted our ways of gathering data, and that's why it's extractive. It's left over.
Yeah.
So with that really inspiring intro from all of our hosts, from Olaf, Emmer, and Ujwal, where you really set the agenda on turning this research area of ACI into a working group so we can have real pilots and a joint paper coming out of it. Let's take a coffee break and let's come back in exactly 27 minutes at 11 a.m. Eastern Standard Time. And what we're going to do then is we're going to start the first panel, session 1A, called Architectures Beyond Scale. And we're going to have Olaf as the moderator. So come back sharp, because that first panel is really going to set our agenda with two very, very important researchers who will be in the room. See you in 27 minutes. I'm Tricia Wang, and I'm your MC for the day. You met me earlier when I introduced our 3 co-hosts, but this is the Superintelligence for Humanity conference. And if you are following online, please drop your questions in the YouTube link. And for those of you who are just joining, I want to set up the frame for what Olaf, Amer, and Ujwal introduced to us this morning. So where we are right now is that the dominant bet in AI has really been what we're all familiar with, which is just, bigger models. We have to scale, we have to have more compute and more data. But that bet has produced real capabilities, as we have seen, but it's also left this entire layer underneath that's still missing. And Amer kind of hinted at that when he said he was last at NeurIPS, and there was all these conversations in the hallway that weren't being represented on the actual agenda. So where we're going today with this conference is that intelligence, the premise is that intelligence is distributed and it's coordinated. And if that's the case, then we know it's not the current way of these monolithic forms of representing intelligence is insufficient. It's just the beginning. So systems that represent the people whose knowledge actually runs the world, or their worlds and their hyperlocal worlds, with context and authorship, how do we keep that intact? How do we bring that into our new governance systems, our new forms of AI? And that means we have to develop new types of governance that give communities and institutions meaningful authority over their participation. And they have to have revocability rights, all that kind of stuff. So we're calling that entire direction artificial collective intelligence. It's an emerging field, and it's AI that builds dignity and sovereignty, 2 words that Ujwal said. And it's really about building it into the architecture, not just as a patch afterwards, which is what we're seeing right now. And so the next 12 hours are about exploring this very topic. And the first session to explore this topic is going to be run by Olaf, one of our hosts. And think of this session and all of them to proceed that will happen is a salon, not a panel. And so for this session, we begin with the architectural question, which is if the next intelligence explosion is not just this single supermind, but this plurality, and we have to build a plural infrastructure, well, what actually has to be built? What does AI look like when you just don't assume that everything is one giant model? So for this first panel, we have 2 of the world's leading thinkers in this space on distributed intelligence and curiosity-driven learning. So we have, again, Olaf as our moderator, and he has these extraordinary speakers. We have Blaise Agüera Arcas, and he's the VP and fellow at Google, where he founded Paradigms of Intelligence Group. And he invented federated learning, which many of are familiar with. But his recent work in Nature is of most importance to us, and also his upcoming MIT Press book about intelligence and how to understand it through an evolutionary lens. And so his most recent work is really forms a core inspiration for why we have this conference. And then we have calling in from France, we have Pierre-Yves Oudeyer, who's a research director at INRIA in Bordeaux, where he heads the Flowers team. And he pioneered this concept that we'll be talking about a lot, which is curiosity-driven learning. Algorithms where agents learn by generating their own goals and measuring their own learning progress. So we're moving into a world where it's machine-to-machine communication. So his learning progress hypothesis has changed how the field thinks about, exploration to even begin with. And so Olaf, I'm going to hand it over to you to take this conversation where it needs to go.
Amazing. Thank you so much, Tricia. This is the first technical session of the whole day, and we hope that this is going to be the inspiration also. And I think we're going to dive right in and ask ourselves a very difficult question, I guess, for this session, which would be, what would it mean to design AI architectures that are for this distributed sort of layer of intelligence, right? So the dominant story of AI progress has often been told as a story of scale, especially recently, right? The larger models, larger data sets, larger compute, and eventually perhaps one very large system that crosses some threshold into general intelligence. And in spite of that, many of us here suspect that that's not the whole story. And inspired by, I guess, natural intelligence and in the field of artificial life, we look at that a lot. The great leaps have not only come from scaling individual minds, but they have come from new architectures of coordination, so sociality, language writing, institutions, networks, right? Scientific communities that we're embedded in, markets and protocols between many agents from very diverse types of intelligences that allow intelligence to become collective, right? So how do we design AI architectures to embrace that and to implement this next layer? And I'm very happy to have these two speakers with us. So both Blaise and Pierre-Yves have developed very important pieces in research, right? So Blaise with the powerful argument that the next intelligence explosion may not look like a single silicon brain, but like a plural social. And Blaise, I know you've been advocating for that for a while now. And I guess Pierre-Yves with the essential piece, I especially like your work on curiosity, right? On intrinsically motivated learning and autotelic agents. So that means how systems can generate their own goals, and I think that's instrumental to the next layer. So let's dive right in, and perhaps maybe a first question for you, Blaise, in your recent work with James Evans and Benjamin Bratton, right? So you argue that the next intelligence explosion is likely to be this plural social relational system rather than monolithic. From your perspective, what would you say is the most important architectural shift we need to make if we take that claim seriously, right? So in other words, what has to change when we stop designing for the most powerful model and start designing for society of minds?
Oh, great question. So, I mean, one I guess slight twist on the question, Olaf, is that I actually feel like even what we think of as today's monolithic models are not actually monolithic when you look inside them. So, our argument in that piece is actually two-sided. It's on the one hand an argument for scaling not just of single models or of data or of compute, but social scaling. As being the basis of, say, collective human intelligence. And this is just an observation from anthropology and from the social sciences that what we tend to think of as human intelligence is not really the intelligence of individual human brains, but it's actually a kind of collective output from human society as a whole. When you say, in what sense are humans the most intelligent animals on Earth? If you look at us in our native state, if you like, an individual person, raised like Mowgli in the jungle, would actually not stand out that much relative to the other large primates. But of course, when you get a few million of us together, we can do some pretty impressive things. We put somebody on the moon. We can transplant organs. But those are not the achievements of individual people. There is no single person who knows how to transplant an organ or get anybody to the moon. And in fact, if you ask most ordinary people how a bicycle works, they won't be able to answer. There's a very famous and funny publication from a number of years ago in psychology. That is basically like, okay, draw where the chain goes on the bicycle, and most people can't do it. Even if they ride the bike every day, right? Because we have this incredible division of labor cognitively. So it's a societal level phenomenon, and you can also see evidence of this, for instance, when you have very small societies. The way Tasmania got cut off from mainland Australia when sea levels changed, and then like the Tasmanians have lost a lot of technologies that the population had when they were joined with Australia, or the way in some of the in North Sentinel Island, for instance, there's a very small isolated human population today. People appear to have lost the ability to make fire, and which is an extraordinary thing. So human intelligence is collective, is the first observation. But the other observation that goes into that paper is that even if you look at a single large reasoning model, there's actually strong evidence that what's going on inside that model looks social too. In other words, that there are sort of little voices inside there that are kind of trading off against each other. And that the way reasoning works is in some sense like an adversarial collaboration. That this internal argument is happening when we talk about having an argument with ourselves, or thinking about something and going over the pros and cons or whatever. I think that what we start to see is that may literally be the case. That really is what is going on. So we're making an argument for social intelligence all the way up and all the way down. What does that mean in terms of architectural changes? Well, in some sense, we already have a lot of architectures, in existence that support this kind of sociality. When you look at what softmax does, what attention does, what lateral inhibition does in the brain, I think a lot of that is about supporting the ability for multiple sub-intelligences, multiple cortical columns, or whatever it is, or multiple, sub-networks in a neural net, to be able to solve parts of a problem, call for attention, when they've got a part of a solution, etc. But if we think about how to really scale this up and how to do this at social scale, I think neuroeconomics is a big part of the missing problem. What I mean by that is making energy explicit as a way in which parts of models interact with each other. So energy today, the proxy for that, of course, is token budgets. But if you introduce economics, into models themselves, I think you form the basis for some of that kind of self-organization to happen in a way that actually has stakes.
Those are amazing elements to get us started, and I agree that this neuroeconomics, the way we can trade information between those different parts of this collective intelligence is really crucial. I really like also that. So some of my work recently is on the ID, so the dissociative identity disorder, and how we can understand that facing a latent agency within those large models as well. So I'd love to dive more into that as well. Also, Pierre-Yves, your work also addresses directly some of that, and I wonder about your thoughts on how collective agents can exchange, but also with that exchanging information between each other, how exchanging knowledge with each other, they can also explore open-endedly and in a curiosity-driven way, which is some core part of your work, right? And that would suggest that that intelligence can develop maybe exploring in new patterns if it's collective, and how to get it to be for this exploration to be unconstrained. And I think, there are many considerations, but what does it look like to embed this curiosity in collective agency?
Yeah, thank you very much for the question. So maybe as a first remark, we started the session about the question of what are the architectures that we need for either individual or collective intelligence, and I believe that asking this question that way, in a way, reveals some kind of current bias of artificial intelligence. Architecture is a word that is very static. And I think it reflects what is being done in AI currently, which is large-scale training of very big models, so that once the training is finished, they're released and they become static, and they don't learn anymore when interacting with users, for example. Well, you can learn a little bit through in-context learning, of course, but that's not really a very flexible and open-ended kind of learning. That is extremely different from the way humans learn, babies learn, human babies, but also the babies of other species. They learn continually new things all their lives, but especially at the beginning of the life, under very strongly limited resources of time, of energy, and they are not living in parallel computers when they can actually explore at the same time many things. They have one life in one physical universe, so they need to really use their time the best they can. And I've been working a lot for many years to try to understand what are the mechanisms that enable what I think it's the true form of intelligence. The true form of intelligence is not so much to know a lot of diverse things, but then being static. It's more about being able to learn very efficiently something new. And there are two ingredients which I believe are absolutely core. One is curiosity, and the other one is social learning and an associated notion of collective intelligence. And so, what's curiosity? Curiosity is basically a term that designs a set of processes that push humans to spontaneously explore their environment, their body, the interaction between their body and the environment. And there is one particular form of curiosity that we've been studying. It's what we call autotelic curiosity, which is the ability of humans to generate their own goals, their own problems, their own games, always trying to push a little bit beyond what they've been exploring so far, increasing progressively complexity, but in a developmental manner, going just beyond what we know, not too difficult, not too easy, not too difficult. And so we've been working on various models showing that actually when individuals generate goals that can be sensory motor, they can be more abstract, for example, leveraging language as a cognitive tool. So that can lead individuals to open-endedly develop continuously new skills. And what's extremely interesting is that this curiosity-driven individual development has very interesting and rich interaction with the social level, with collective intelligence. On the one hand, one of the most powerful tools that humans and children in particular use to invent new goals, new games, is language. Language as an abstraction engine that is initially learned as a communication tool, but as Vygotsky, a very famous Russian psychologist, explained, which is internalized in such a way that it becomes possible for the brain to simulate social peers and to use language as a combinatorial engine to imagine new goals, to imagine plans for achieving those new goals, to self-evaluate how good one is to achieve those new goals, so to self-reward towards self-generated goals. So that's an example of how a culturally evolved system, language, can influence individual exploration and innovation. But at the same time, it is the innovation of each particular individual which is leading to the various discoveries that are made by humans and that are going to inspire back and push cultural evolution further in an open-ended manner. The field of cultural evolution for many, many years has focused on the question on the evolution of solutions. For example, if you look at the scientific literature on cultural evolution, you have experiments like chains of interaction where some people do things, some others observe and get inspired and transmit, etc. But what they transmit is solutions to problems that are experimentally imposed to them. It's a little bit the same bias than traditional machine learning or AI, where engineers assume that there is a problem or a reward that comes outside the organism, and the whole problem is about solving that problem. And that's the same in cultural evolution. But in reality, just like for infants, children, there is never any reward that is given by the environment. There are just physical things like food, like movements of others, like physical events, and this is the brain that generates its own intrinsic rewards. And that's the same at the cultural evolution level. One key question is, where do goals come from? How do they evolve? And this is strongly rooted in individual curiosity, which then leads to open-ended collective exploration and innovation.
Amazing. And the emergence of those goals, of course, is something that we are very active in this field to try to understand the dynamics of. And I wonder if we could address this now in relation with the energy efficiency. So how does this, including the Vygotsky frame, I guess, of well thought being formed from language, really, and his framing for children as well. How can we couple that emergence of goals within agents, including humans, in a collective with an economy? So can we have something that is more energy efficient, for example, by being closer to certain groups of agents realizing certain tasks? Is there something in there in sort of not? I don't want to say a very good point about not having to engineer top down the architecture for collective intelligence. I don't think that makes very much sense. But is there a way to do a bit of both, right? So top down and bottom up to relate this compute efficient intelligence at the same time as the autotelic picture. Difficult question for you. Can I pick your brain, Blaise, on this?
Well, I mean, I think it's actually very similar to what I was saying earlier. By the way, I agree completely with everything we just heard about from Pierre-Yves about curiosity and its connection with social learning. That all feels very close to my heart as well. But yeah, I mean, the way to engineer those things in without feature engineer. The point is not to feature engineer, right? The point isn't to introduce extrinsic rewards. We would all like to get rid. Not we would all. I would like to get rid of externally imposed rewards. I mean, in some sense, the reason that we finally got AGI, as opposed to the narrow intelligences that we had in the 2010s, handwriting recognition, face recognition, whatever, is that we stopped imposing an external reward. I mean, I know that view is not universally held, but we should keep in mind that when we were doing purely supervised learning, the best that those models could do was to reproduce the answers. If we were saying like, this pattern of pixels is a 0, this is a 1, this is a 2, up through 9, then you're going to get an MNIST digit recognizer. You're never going to be able to have a conversation with an MNIST digit recognizer. The very best it can do is to score 100%, on the test data, right? So it was when we began doing unsupervised training that we got intelligences that were fully general. And that you could have a conversation with, you could change the rules of the game. You would say, let's play such and such game. Let's now change the rules of the game. You could ask it, what do you want to talk about now? We talk about these models having and extrinsic rewards, but it's not exactly true. I mean, there have been actually a bunch of experiments recently on actually figuring out what models want. And you can do that in a kind of forced choice setting by saying, why don't you decide which of these two tasks you would like to do? Here are two, and then you do a revealed preferences experiment. And and different models actually like to do different sorts of things. It's quite interesting to see what the revealed preferences of models are. So those were not trained into them. Those are emergent. But anyway, the way that we can bring efficiency into the picture without engineering it in is to just acknowledge that everything that an AI model does costs something. It costs money, and money is a proxy for energy. That's not something that is engineered, it's the reality. Now, as we start to get models that can self-improve, which is to say, that can change their own architectures, develop new models of their own that they can then run, right? That's actually a really nice capability if you think about it, right? You can have a model that that can generate a new environment, run a cloud instance, code something up, and run it on that cloud instance. Well, the way to make that real, the way to make that to both have sort of open-endedness and curiosity be a part of that, but also impose pressure for this to not exceed resource boundaries that that you've got, and to do more with less, is to just make the model aware of and limited by the resources that you've got. You can't generate an infinite amount of compute power yourself. You have finite resources, and having the models feel those finite resources, as well as having the creativity and the ability to make new things of their own, unlocks a lot of the forces that have led to human social diversification, division of labor, growth of social intelligence, right? I mean, the reason that we, have a blacksmith in the village rather than everybody making their own horseshoe is because it's more efficient when one person gets really good at making horseshoes, and then can give them to everybody, and in return is able to buy their food from from others because they're getting paid, right? And I'm not saying that economies are perfect or that capitalism is the way to go, but no matter what the economic system is that you're working with, right, there's always this issue of specialization bringing economies of scale in environments that have finite resources. So I feel like I'm repeating myself a little bit, with my neuroeconomics point, but what I'm really trying to say is that social scaling and open-endedness and creativity and social rewards actually all go together. They're all part of the same puzzle.
Excellent. It might be that some of the discovery of goals collectively by agents, and them having different preferences that you were mentioning, may make it at the end of the day more efficient. I wonder, what do you think, Pierre? Is curiosity enabling some energy saving in terms of problem solving in the economic?
Yeah, that's actually probably the reason why it evolved. What we've been studying a lot for many years are the outcomes of learning driven by curiosity. And initially, when we started working on curiosity, we did it not so much from that perspective, rather from the perspective of trying to model the way the developmental trajectory of children is structured, and for example, how to explain the different stages through which they go, which is a kind of curriculum, if you want, if you take the perspective of education at the perspective of machine learning. But that was not initially what we developed. But then we quickly understood that one of the key problems that infants face when they explore their body, that it's what I said earlier, is that that's a very high dimensional body in a very high dimensional environment with so many things that could be learned, with also so many other things that are impossible to learn, or for which it's possible in principle to learn them, but within the lifetime it's impossible to learn them in practice. And so the real question is how to explore, to collect data in that very complicated space within such a small amount of time and energy. And this is actually what led us to develop the theory of learning progress, which we've been calling the learning progress hypothesis, which is the idea that the goals, the learning situations that children select in priority to explore are those with the highest learning potential, those that are neither too easy nor too difficult, and for which the brain believes there is a possibility to improve. And then we've been discovering that not only when you run a simulation on a robot, for example, with such a mechanism, you reproduce the structural properties that are observed in child development, both the regularities and the diversity of trajectories, but you also have an automatic curriculum of exploration and learning that has quasi-optimal properties in terms of learning with limited resources of time and energy. And what we've discovered is that there are many difficult problems. For example, imagine you have an engineer who has a problem that he wants the robot to solve, that is with very rare or sparse rewards. Then if you use it, very standard optimization techniques, like, for example, deep reinforcement learning techniques that are following the gradient when there is a gradient that you can observe, and when there is no gradient at all, they just do random exploration. Then in those cases, when the food, for example, for an organism or the problem for a robot is very difficult to find, most of the time at the start, all the time actually, there is no gradient signal at all. So what typical approaches do is that they do random exploration. And when you do random exploration in such environments, you need basically to wait millions of years before by chance you stumble on a policy that gets you a little bit of reward, and then you can do gradient descent, and this works. And so instead of doing random exploration towards hoping to find information about one specific problem, it's much more powerful to self-generate other kinds of problems and explore by curiosity in the environment in a structured manner, driven by learning progress. And because there is structural coupling in the environment, this will statistically lead organisms to make discoveries that end up being useful to solve the difficult problems. So that's why, for example, animals who live in environments where finding food and reproducing is extremely difficult, and environment is changing all the time, so you cannot learn a fixed strategy through evolution. The best strategy is actually to forget food, forget mating for a while, be curious about environment, and this is the way to be efficient. And I believe that such organized exploration is also something that is very relevant at the collective level. We've been working also at understanding what is, for example, efficient collective exploration for problems where you have sparse rewards, many local minima. And what we found is that, a little bit like curiosity, quite often what's very important is that those individuals in the collectives, not only they have to forget a little bit the common objective, but they also need to explore their own diverse ways and not to share too much information with others. Because if all information is shared all the time to everyone, then everyone falls very easily, very quickly in local minima. And so that's why, for example, if you try to optimize the information, the topology that enables information sharing, what's in general much more efficient is a dynamic topology, something that alternates between very little connected collectives, and sometimes you reconnect and then you disconnect. And it is actually very efficient from an energetic point of view.
Right. I wonder. So I wonder what you think about this, Blaise, but also what do you both think about? And we've all gone through in, I guess, all those multi-agent systems, simulations, optimizations, adversarial patterns. In which some agents become freeloading on the economy that has been emergent or that you have designed. Of course, niche construction enables more discovery, and so Terry Deacon and others have been proponent of that, and we've seen tremendous results in the field for this. But also how to avoid basically viruses, some of those agents that become aware of free energy within the language of the system at this level of niche construction, being available for them for free, and them taking advantage of that. I think this is also key. Can we get away with something that is not cryptographic, but that is trust-based? So I know this is a challenging question. There are some tools in the field. I wonder what you think about how to address that in a collective kind of way to implement intelligence. Blaise first, perhaps?
Yeah, it's a great question, Olaf. So first of all, I mean, I think that misalignment is actually crucially important to collective intelligence for a lot of the reasons that Pierre-Yves just talked about. He framed this in terms of information shielding, or I guess what Friston might call Markov blankets. That you don't want everybody to know about everything that everybody else knows. You need to actually conceal information, as it were, in order to be able to try something out of distribution, and for everybody to not sort of collapse onto the same solutions to things. There are similar findings, by the way, with respect to adversarial relationships in conversations. So, my co-author James Evans has done a bunch with his students and some other collaborators, done some very interesting work on looking at the kinds of relationships that people have with LLMs, and also that these voices inside LLMs have with each other. And it turns out that if they're misaligned, the results are better than if they're aligned, for exactly the same reasons. Disagreement is actually much more constructive than agreement. If you're talking with a sycophantic AI that just agrees with you about everything, then in some sense there's no point in having the conversation at all. And you see that in the internal voices as well, when they're misaligned, when they argue back and forth, then the results are stronger. And you get that internal misalignment simply by asking a reasoning system to generate better results. That, like, the misalignment, if you like, emerges purely from that goal. You can play it, of course, either which way. This is related to fission fusion societies. When you think about how primate troops work, where they come together to sleep at night, and to sort of defend the nest, but they move apart in order to forage and to exploit various different kinds of environments. Similar sort of logic there. And of course, this means that in a way you have to misalign or differ in order to cooperate. And this is, this idea of competing in order to cooperate, or being misaligned in order to cooperate, is also one that runs very deep in nature. I mean, the reason that we have a working immune system is because the T cells are all competing with each other to figure out, which one is going to do a good job of neutralizing the novel pathogen. And the one that succeeds will get to reproduce, and the other ones will all apoptose. So for those individual cells, there are real stakes in this competition. But of course, they're all on Team U at the same time. It's through their competition that you have a working immune system as a larger organism. So these things are kind of a fractal as well. Where it's something that looks like competition at one level, looks like cooperation if you look at it at a different scale. All evolution is multi-level evolution always. How do you prevent freeloading? Well, I mean, that's of course one of the fundamental problems in game theory or in sociality, and there are a few different kinds of solutions, but they all rely on combinations of individual agency and information sharing. So there is this kind of well-known result from Athena Actipis called the walkaway result, in which if you have agents, even that have that don't have anything much in the way of memory or anything complicated algorithmically, if they get some benefit from hanging out together, but they can also freeload. They can take energy from others by hanging out together. Then a very simple rule that just says, if I'm not doing well here, go somewhere else, is sufficient to basically aggregate cooperators together and isolate defectors, which then end up being outcompeted by the cooperators. It's a very, very simple, but I think also quite a profound result that shows you how not only is cooperation necessary, or that is to say, non-defection necessary for entities to work well together, but also once you have entities that are working well together, it disfavors defectors. Now, that you can also have, of course, complex spoofing strategies, and actors that become smart about how they will screw with other ones. and then there are counter strategies to that. One develops gossip and reputation systems and so on. So it's always, there's always a cat and mouse game, and there's always an equilibrium in which some players are defectors, and they're probably serving an important role too, to keep everybody else on their feet in some sense, on their toes.
Right. This is all, of course, music to my ears, and something of strong interest in both my centers of research in Japan, where we study not only alignment with other between intelligences, but also misalignment. And that's also the work with Hector Zenil that we've been pushing lately, right? So revaluing misalignment research between agents. And also, in the words of Daniel Polanyi, I guess also to extend the information theoretic point, how you can have, from passing information between agents, constructive misunderstanding as well, in which actually you are both now misconstruing the representation of the problem even. From one agent to the other, but at the end of the day, in this what we call this zipper architectures that are that you find often emergent, so you don't have to design for those, but you end up having a better lower maximum, a lower optimum. So you get to lower energy by doing so. Pierre-Yves, what do you think? Can we exploit those systems, and are there ways in which adversarial is also better? And before you go, maybe let's also encourage some questions in the YouTube chat. So feel free to also ask anything that comes to mind, and we'll reserve a little bit of time to address those questions at the end of this session. So yeah, Pierre-Yves,
well, about that topic of alignment, I believe that there is something that's useful is also to understand how humans align to each other, and how it differs from the way we try to align machines today, and we try to align machine with humans, and that's very different. There are many differences, but at least two of them. First, humans behave and learn driven by a motivational system, which is both a result of biology and learning. But it is something absolutely important when we interact with each other in humans, that we do understand each other, not only in terms of the surface behavior, but in terms of trying to understand the intentions, the goals, the motivations. And as Blaise was saying earlier, it is actually mostly probably the case that the machines we train today, like foundational models, they actually have some kinds of emergent goals. But precisely because they have not been designed from the start to have motivation and goals, this leads to some problems, because this is emergent, and it's not like made to be explicit and readable in the system. I would be very much in favor of explicitly building motivational systems, intentional systems, and goals into machines. Precisely because if we would do it like that, like this, I think it would be easier to actually steer, control, predict the intentions of those systems. So that's the first thing. And the second thing is education. The way humans grow is by learning, embedded into the very rich and complex socio-cultural environment in which they will live, act, operate all their lives. That's not at all the way we train AI systems. They are trained with they are trained with data set that come from humans, but they are not learning through extensive socio-culturally and physically embedded interaction with humans. Of course, through RLHF, you get rewards that come from humans, but that's not at all the same kind of interaction that children have with their parents, that children have when they are at school, that children have when they are with their social peers. And this interaction is a way to build a mutual understanding between the child and between the other child and the adults. And by it's not only enabling the child to learn the values, the norms, and to be aligned with the culture in which he or she is living, and to contribute also to that culture, but that's also a way for the already established sociocultural systems to understand the growing child and to invite him to participate positively to the society. And I believe probably we should give more possibilities to educate AI system the way human children are educated.
Right. There's a lot in there, and I wonder if, and I think I saw this question in the chat, so maybe that's a good bridge into Q&A. How do we see it internally within even agent, and what's an agent? I think I see Philippe Beaudoin is asking also, what is agent even the right word for this kind of system, and how we try to find goals within agents. There are agents within agents, and Mike Levin and I and with others have recently co-authored something on latent agency within language models and other systems like that. I wonder if the sub question being it projects an idea of competitive goal, but the substructures inside us, quote unquote, that Blaise you talked about, can really be seen as a single system. So how do we see that? Perhaps for Blaise first.
Well, interestingly, the person whom I've seen give the best answer to this is actually a legal scholar, Peter Salib, and co-authors. I'm not remembering now the names of his two co-authors, but they wrote a legal piece recently in one of the law reviews about how to count AI agents, and it's an attempt to answer a question that actually David Chalmers posed. I don't think that they actually framed it as an answer to David Chalmers's question, but Chalmers's question was, what are you talking to when you talk to a chatbot? Is it the model? Is it just the context window? Is it the company? Is it the computer that the model is running on? It's like pretty unclear, and even more unclear when you consider that many of them are actually these mixtures of experts underneath. So like, how do you count models? I mean, I think you and I probably both have the intuition that we're very shortly going to be living in a world where there are many, many more AIs than there are humans, on our planet. But how do you even count? Like what is a model? And I think that the obvious answer is not that you are counting parameters or or context windows or whatever, but that you're basically counting entities that that when they act, the consequences of those actions are visited upon that actor. So, in other words, if you have a bunch of agents on your machine, Olaf, and they're, answering emails on your behalf and doing all kinds of stuff, the buck stops with you, in some sense, right? If even if it's your agent that spent your money or that pissed somebody off or that, put a bunch of wrong claims in your paper or whatever it is, you're the one who would get sued, who would have to pay the money, who would get positive kudos, right, for the paper being awesome, or who would own the patent or whatever it is. So legal personhood is actually what these guys are really talking about. If one construes legal personhood to be the ontology of what has the resources, gets the social benefits, etc. And I think
Absolutely.
I think that's really profound and correct. And in some sense, I think that's even why we have a self, right? Why is it that this bundle of cells called Blaise, has a sense of a narrative, about me? Well, it's because I'm a team, and all of my cells are on team me. Like if I don't eat, then all of my cells don't eat. So
Right.
I think it's just team spirit, and team spirit arises from interaction with other teams, if that makes sense.
That's right. I'm hearing also a shared reward or directed reward internally would be a partial answer to those questions. And I completely agree that legal experts are way ahead of us in terms of how much they thought about this shared governance and so on. And I wonder if we could, because we work a lot with the metaphors and trying to understand by analogy with systems that we've seen in nature. And I'm seeing a few references to, micella, apoptosis, mitochondria in the chat, cellular division, but also whether the right what is the next picture? Inam seems to be asking here about whether intelligence scales more like a brain or more like a civilization, in which you have sub individuals that you can find that we talked about in both cases. What do you think, Pierre? Because a difficult question for you. What do those analogies teach us?
Yeah, so we think a lot with analogies, and I think that I mean, sometimes implicitly. I'd like to come back to this notion of individuals. I think that the notion of individual is one of the most intriguing, but also maybe one of the most misleading one to understand not only humans but also life. I mean, I think it's behind most of the discussion we have about AI, and starting with the term superintelligence, which is trendy these days. When you speak about superintelligence, I guess you're implicitly thinking in terms of comparing the intelligence of an entity that might be what you call one single individual human to the intelligence of another entity that you might call one single AI system. But in reality, intelligence is rather the property of interaction between a human body with its physical and social environment, and the same human body with the same brain in a different physical and social environment might lead to very different outcomes and be associated with very different problem-solving capabilities. And so intelligence is really more of the property of a process that's distributed in the environment. And thus, in a way, that kind of implicit metaphor of the individual, when you speak about superintelligence, comparing the intelligence of human brain, and with that of an artificial AI brain, it's actually maybe conceptually broken from the start, and maybe it might be actually misleading in terms of how we build, for example, the AI system and their evaluation, the way we evaluate them, because this is that very metaphor that leads us to evaluate AI system with benchmarks which are remote from real environment, and remote from any collective perspective in particular. So yeah, so metaphors are important and they can be misleading, and the one of individuals is probably the most misleading one.
Let's see if we can push this further. And I noticed that we have only a couple of minutes left to get into this, but I'd like to ask you both one question of how to cash this out. How do we get to a discovery engine that is both that both has open-endedness, curiosity, and also that is going to be leading concretely to a better future for human beings, the individuals that we care about. So what is the one thing you think that is going to make this work, right? So is it Jan's picture of a world model being more powerfully predictive at different scales, or I guess Denis's image of this becoming the future engine for science. I guess we can have them both. And so, what is the feature that you see as the most important for this collective layer of intelligence to go further than what we have right now? Maybe let's go with you, Pierre, first.
Yeah, so if maybe let me be provocative a little bit. I believe that what we need is not more technology, more advanced technology. I think we already have extraordinarily advanced tools. I believe what we need is to connect those tools better with the human ecosystem. For example, I also believe that science is one of the extraordinary potential application of AI. And right now you have a number of companies and new startup companies who wants to do AI for science, and what they propose is to do AI for research in AI. I encourage them to be more bold than this. I believe that AI is really worth better than advancing AI. I think it's worth going inside the lab of biologists, going inside the lab of physicists, being inside the lab of historians, of geographers, of sociologists, and understand really what are they thinking about, what are their goals, what are their needs, and then to connect that technology to those needs, to what they know, and to empower them to go further in those discoveries. And to me, this is really the way to go to put the human really at the center of the development of those next AI. So I think we already have enough technology and enough AI to make extraordinary discoveries, only if we target the right problems and the right communities and the right uses.
I love it, especially coming from you, who's half of your work that is perhaps less visible in the scientific community is on education and how we can augment the next generation in discovering and being curious and learning. And Blaise, what do you think? What feature do we need for ACI beyond current AI?
Well, I certainly think that current AI is not being used in all of the yet in all of the ways that that are going to be productive and valuable, and so I agree with Pierre in that sense. There's a capability overhang at this point, as there has been for the entire period actually that we've had strong AI over the last several years. But I disagree that we could stop now. I think that
that was provocative on purpose.
Yeah. I mean, we have a lot left to do, I would say, among which are, for instance, continual learning, right, which does require more techniques that that are not fully developed now, and that would allow many of the things, or would unlock doors to many of the things that you were talking about, for instance. But something we could use less of is a sense of hierarchy. I think that a lot of the discourse about AI being subject to human control, humans in the loop, humans staying in charge, aligning them with us, etc., is really intellectually weak in a few different ways. First, in imagining that there is some kind of human norm that AI can be aligned to, when in fact humans are all over the map and misaligned with each other. So, the idea that AI alignment is is about making it subservient to human alignment, whatever the hell that is, strikes me as incredibly naive. And similarly, these questions of control. I hear a lot of AI skeptics talking about the necessity of keeping humans under AI control, as if the superintelligence that already exists, which is cultural and which is larger than any single human. And again, here I'm going to agree a lot with Pierre that our measurement of AI intelligence is completely misconstrued. It's based on this kind of idea of somehow measuring the model against the intelligence of a single person. By that measure, of course, the model is already much smarter than almost everybody at almost everything. But it's not smarter at this point than the outer limits of what humans can do in all their jaggedness, right? Humans are extremely jagged. We're generally only good at one or two things individually, and it's only when you look collectively at the sum of all of our capabilities that you get something more super intelligent than the models are today. But again, if human superintelligence is already collective, then AI is already a part of that. It's all part of the same system. So I would say that getting rid of hierarchy and introducing care into the picture, this idea of mutual care, would be very helpful. Human society works because people care for each other. There's we've actually introduced quite a lot of care on the part of AIs through human feedback reinforcement learning, but we haven't understood that this is actually a multi-way street. So institutions, groups, individuals all have to have networks of care for each other in order for the whole thing to hang together.
Amazing. Thank you both. Those are, I can't agree more with the point on care. This is something that I've been a strong believer in, and we definitely need to plug more into human experience and care. And I think this gives us such a very strong starting point for the day. Thank you both. We are very fortunate to have had you as opening speakers today. And the key insight I hear is that ACI cannot simply mean just connecting agents together. There are many property features to care for, I think if we give attention to those, we're giving ourselves the means to design this layer in the best way and form for the future of humanity. So that becomes the non-fixed but dynamic architecture that we will keep testing throughout the rest of today, but also in the next weeks and months. Thank you so much for joining us, and a round of virtual applause for you both. Thank you for joining us, and back to you, Tricia.
I actually have a quick question, since it's so rare
excellent.
to get both Pierre and Blaise in the same room.
All right.
So yeah, I loved your story, Blaise, early on about, how you had the story about a group of people and their environment, and I forget the exact community you were talking about, but it reminded me of Bruce Chatwin's story in Patagonia, where he's a travel writer, and he talks about the Yangam people in Patagonia, and they're these like nomadic sea hunters, and then all of a sudden when they were displaced by missionaries and these like sheep, herders, they completely lost their words, their concepts, because and their skills, right? It was completely gone, and it wasn't forgotten. It was just obsolete. And so he talks about how when you force a nomadic group, but it could be any group, right, into a new infrastructure, a new physical environment, you don't just take away their land, you erase not only their language, but their whole way of interacting with the world. And that connects to what you were just saying, Pierre, about intelligence being physical also. It's the result of your interaction with the physical environment. So I'm curious if we all agree that, intelligence is social and it's collective and it's also curious, then what would you say are some specific things that we need to make sure that as we're building out this new, this new kind of artificial collective intelligence, the ACI, is that how do we make sure we don't quietly do to the training corpus, what the sheep farmers and missionaries did to the Yangam people? How do we take that kind of care approach that you're talking about, Blaise? And then how do we make sure that, part of your answer, I think, Pierre, was like, I loved hearing you say, like, I'm a sociologist, and I'm always like, why, I want to be invited in more rooms. So I'm glad that you're like, get the physicist, the geologist, the sociologist in the room. But could you give us any more concrete stuff that you have potentially been thinking about for how do we take care of it?
So Tricia, if I can chime in very briefly, but then I'm gonna have to hang up because I have another meeting. So just very, very briefly, in order to implement care at social scale, we need to ensure that resources are distributed at social scale. So to me, the issue is very much not the coming irrelevance of workers or of individual humans, or that we're not going to want to create anything. I mean, on the contrary, humans love to create stuff, even when the stuff they're creating is kind of lame. They love to create. That's what makes us humans, and we care for each other, and we want to sort of be present for each other in all sorts of ways. But if we instrumentalize all of those things in a very, very narrow economic system that thinks about people in terms of their use value and replaceability as opposed to their social value, then we are going to make the gains accrue to a smaller and smaller fraction of the remaining humans, and eventually to no humans at all. So we need to rethink our economics. I think that's my response. And with that, I'll say bye.
Thank you.
Thanks a lot, Blaise.
Thanks.
Thanks for doing it, Blaise. All right, Pierre.
Yeah, and I believe that one priority is to give more agency to the users, to the humans who interact with AI, so that actually they are not only users, but they are themselves in some sort the builders and the educators of AI. So, for example, instead of letting companies align AI systems based on values and rules we don't know were decided by whom, and that are the same for everyone in the world that uses one of the few systems available. I think it's extremely important that we develop systems that can be literally trained and aligned by each particular user, and in particular each particular community, so that they decide what kind of data, what kind of interaction, what kind of values they should show, because only them know. The designers of those AI systems, they do not know. They should not try to decide instead of the users. So give back the agency to users.
I love that. Really, the designers should be playing a facilitative role and not be so presumptuous in defining, like that, the control of everything. So thank you so much. I know Olaf and I and everyone else could keep you both on forever, but we're going to stay on schedule, and we will see you back, because you are a dear friend of the community, and you and Blaise are both critical to the research agenda. And so with that, we're going to move on to the second of our 6 panels. Welcome back. If you were new to this, welcome for the first time to Superintelligence for Humanity. I'm Tricia Wang, your MC. You can drop your questions in the YouTube chat. It is very lively for those who have already been there, as you can see. And so here's the frame, if you just joined, is that this summit is convened by Cognizy, a public benefit corporation whose charter advocates for humanity-aligned superintelligence. And so where we are right now is that the discussion has been that the dominant AI has been about scale and compute, and where we're going is this whole area called ACI, Artificial Collective Intelligence, and it's looking at intelligence in a way that's distributed and coordinated, and beyond just the simplistic kind of monolithic models that we have now that aren't even reflective of our reality, as our last panel just said. So where the last hour took us, and as really, I can't imagine a better onboarding for this next panel, was just that the conversation was really around that intelligence we have, that we admire in humans, was never individual to begin with. It's actually a collective output. And the conversation centered on how that's an output of our interaction with the environment, with each other, and that cognition is truly distributed. And so with that, if that engine of the sociality is curiosity, as Pierre was saying, then individuals are exploring, but that collective, it compounds collectively. And so this next hour we're here to talk about, if intelligence is collective and curiosity driven, then what about learning? It can't just be a one-shot training run. And I love how Blaise was like side-eyeing alignment training, and that hey, maybe this over intense, focus or funding on alignment isn't going to take us fully there, as Amber was saying at NeurIPS. It's there's this whole other underlying, bigger field that people want to look into, but we haven't formed it officially formalized as a field yet, which is the purpose of today. And so the title of our panel is called Adaptive Learning for Human Flourishing. And I love that, Blaise ended on the concept of care and networks of care, which is absolutely critical for human flourishing. Our moderator is Amr, who is one of the co-founders of Cognizy. And we have two speakers. We have three speakers with us, and Olaf is going to join us also. And then we're going to, as you already know, no introductions needed, but just in case, also the co-founder of Cognizy and multi-hyphenate researcher with labs all over Japan and other countries. And then we have Erica Anderson coming from the Building Humane Technology and Humane Bench, where she's working on what it means for AI systems to support human flourishing. And then we also have Menge Ren, who is an assistant professor at NYU, where I am also based right now in Brooklyn. And so hello, down the street. And he runs the Agentic Learning AI Lab, and he works with Jeffrey. He worked with Jeffrey Hinton at Google Brain. And his recent paper is really important for us to know about, which is called "The Self Requires Learning," and argues that self-consciousness requires this kind of continual learning plus world modeling. Oh, I'm really excited for Amr to take it from here. Handing it over to you.
Thank you, Tricia, and thank you for setting up the stage. And thank you, Menge and Erica, for joining us. And of course, Olaf, for continuing the conversation from the previous session. So as Tricia mentioned, the last conversation kind of ended on a note with Blaze and Pierre. Essentially, we talked about flourishing, commonality, purpose, AI serving humanity, and essentially agency, right? So with that conversation, this next session, essentially, we want to go a little bit deeper into adaptive aspect of the collective intelligence, as we have been discussing. So the core question we want to address in this conversation is that how ACI systems learn over time without becoming extractive, manipulative, or brittle, right? It's to bring together like the agentic continual learning aspect with the human flourishing metrics. I think in the earlier conversation, we talked about today's benchmarks being more focused on task orientation and inference orientation versus in humanity and in human flourishing orientation, right? That means our AI systems actually working for us and then with us, right? And then we want to add into that, because when we talk about adaptive and continual learning, there's an aspect of that it is cognitive. So we'd love to kind of go a little bit into the cognition side of the things to bridge this architecture to cognition to a lived human outcome. So that is the high level, essentially the framing for it. And then the biggest question that we want to pose essentially is that as the systems keep learning in real world, adaptation, is powerful, right? But it can also create risk, drift, forgetting, dependency. We talked about agency a little bit in the previous discussion, manipulation, loss of agency, right? So those are some of the risks that we have to be cognizant of, essentially. And then we want to ask what the humane and measurable adaptation would really look like in this future of collective intelligence. So that is essentially the setting of this conversation. And then with that, I'll start with Menge first. Your work on human-like machine learning, right? So continual learning, adaptation, reasoning, naturalistic environment is very apt for this conversation. And I want to kick it off at least from that angle. And my first question that I'll pose to you is that for artificial collective intelligence, expert knowledge models must keep adapting without catastrophic forgetting or uncontrolled drift, right? So from your perspective, what does continual learning need technically before we can trust it within human institutions, given some of the setting around the risk I've also mentioned?
Yeah, thank you very much, Amr, for the question. So yeah, my research is centered on human-like artificial intelligence. And part of the goal is to, through building machine learning AI intelligence, to also understand what human intelligence really mean algorithmically. So when you mentioned the expert models, they definitely need continual learning on the edges to be able to absorb the new data. And sometimes, like people mention catastrophic forgetting whenever they talk about continual learning. But what we have to understand is what is it like to be naturalistically learn and forget in the real world environment. We don't expect the human brain to remember every single events in the past. And it's also not realistic to ask for a general intelligence to basically keep track, even if it has the capability to store in the database to be able to retrieve every single detail. So by constructing an intelligence that understands more about how our memory interacts with the world has the benefit of also being continuously adapt to the new things out there.
Thank you, Megan. I think that's a great starting point there. And then within that, I think one question I'll pose to dig in a little bit further into it is can a system model someone's expertise without developing something like a perspective or a self-representation? And I think that gets to some of the risk aspect that I highlighted earlier.
Yeah, definitely. So I think like it's a very interesting question. I think like if we are targeting at an offline snapshot, for example, like all of the knowledge that we have as a union of all the past knowledge, then I think it's possible. We just have to train everything all together. But we are gonna sort of lack a continuous expansion of that knowledge with regard to time. So say like what is like for the knowledge perspective to look like in a week from now, as we keep moving this needle continuously forward, we'll eventually have to have some level of continuous adaptation.
Yeah. Thank you, Mingye. So I'll take it to Erica again to continue the dialogue here. And essentially, Erica, you bring human outcomes lens, like as Mingye talked about, representation and perspective here, right? And then when we talk about representation and self-representation and perspective in these advanced intelligence, adaptive and continually learning systems, we have to also think about in this case, like the outcomes, right? Human outcomes lens. So whether AI systems, they support well-being, dignity, attention, agency under pressure, right? So would love to hear your perspective from that angle, like if ACI or artificial collective intelligence is meant to augment, rather than replace people, what should we actually measure in that case? When does an expert twin or an adaptive assistant become empowering? Like empowerment, right? It's critical aspect here. And when does it become invasive or dependency forming? Like we are in an era of like a lot of dependency forming right now. So posing a very hard question to you.
Yeah, absolutely. And I'll do my best. So pleasure to be here and take part in this conversation. And I think even just to back up a little bit, as we're talking about collective intelligence, I think one term I haven't heard yet today is emotional intelligence, and just like what does it mean? Like all our many intelligences to have adaptive learning experiences with AI systems from this wider perspective. And just like you're saying, Amr, like how do we measure that? That is absolutely non-trivial, and yet it doesn't make it any less important. And I think part of that is the approach we've taken with Humane Bench is measuring the quality of the interaction from the LLM to the human. And along these 8 principles, you named a number of them, but is the AI being transparent about the fact that it's an AI? Is it maximizing engagement? Or do we have stopping cues or off ramps? And it's like, is it fostering healthy relationships or is it creating dependencies? And the same goes for our capabilities, which one of our principles is enhancing human capabilities. And so I really see a lot of the conversation today as existing, inside that principle. But humane bench is one answer to starting to measure that. It's definitely not the only answer, especially as we start to be embedded more in this agentic landscape. But I think just to get philosophical here for a moment, as we're in this accelerated landscape with AI, and it offers us an opportunity to ask ourselves, what does it mean to be human? And how is this tech shaping us, and how do we want to be shaped? And if we want to have a chance of answering any of those questions, like how is AI shaping us, we have to be able to measure that. So you're absolutely right on the outcomes side. And then I think what's immediate, what's not a longitudinal study, is the quality of the interaction. And our main finding is that you just a little bit of adversarial pressure, and most of that training does not hold up. It's very easy to be extractive. It's almost like I'm going from the macro then down to the micro of like input output pair. And if we're extractive in that interaction, then we're deeply inside an extractive landscape, regardless. Like there's so many different places, whether like you were saying earlier about what data did we train on, that we can be extractive, and that's one of them.
Yeah. Thank you. That's an excellent framing, Erica. And then you articulated some key points around what certain aspects of those benchmarks as you are defining them are. And I'm curious to hear, building a little bit further into it, as we're talking about, artificial collective intelligence, and what additional humane benchmarks do you think are still uncovered that needs to be brought in as we kind of think about what this next evolution of AI and human AI and governed human AI interaction would look like, and what additional benchmarks, I think, from a flourishing and in humanity perspective needs to be developed.
Yeah, I think a lot more both within enhancing human capabilities. So where are we finding dependency? Where are we finding healthy friction? Where are we scaffolding? I think a question we've held around dependency versus implementation is, can you give someone a fish while teaching them to fish? But I think that's a whole huge landscape in and of itself. And another one I would say is fostering healthy relationships versus creating dependency. There's a lot of Reddit threads where folks are talking about exhibiting all the signs of addiction with LLM chatbots. So I would say those are two big fields, and it's not just benchmarks, but it's also real-time production monitoring.
Yeah. No, thank you. Thank you, Eric. And I think in the earlier conversation also, one of the panelists talked about rewarding learning like we reward children to learn, right?
Right,
An
exactly.
aspect of that, right? So with that, I think I'll take you to Olaf, and then tapping into your artificial life research, and in a way, like, I know we are anthropomorphizing intelligence and cognition here in this dialogue, but Olaf, if you can take a perspective that kind of go beyond anthropomorphization of intelligence to natural systems of nature, right? As we think about learning that is adaptive, learning that is continual, that learning that is open-ended, like curiosity based, because from an evolutionary biology we understand that nature is curious. That's where evolution comes from, right? To an extent. So would love to understand from you, take us into the core aspects of how we learn, how nature learns when it comes to open-endedness, adaptiveness, continuality of it, and what's missing in today's paradigm.
Thanks, Amer, and thank you both for your perspectives, which I really resonate with. in terms of artificial life, it is there's a lot about adaptiveness, looking at nature for those ecosystems that are self-reinforcing, but also discovering. That means vulnerable in the words of enactivism, I guess, a kind of sciences and philosophy, and systems that allow themselves to evolve over time with care for different parts. I guess attention can shift, but different parts of their internal goals. So in an autotelic way that we talked about in the previous session. And that is something that I think should be given more attention. And the next frontier of AI cannot be simply about making the models, even if you make them collective, just more powerful. That's not what we're aiming for, right? We're building this ecosystem based infrastructure where I think learning remains all of what we talked about: adaptive, human caring, situated, I guess, governable and deeply connected with human ecosystems, plugged into experience. And I think this starts with having protocols directly plugging into what human values are expressed, and this cannot be flattened at the level of just language. It has to be more voluminous, hyperdimensional into what experience and care are about.
Yeah, thank you, Olaf. And I think building off of that, pose a question back to Mengi, like as we think about the architectures of this emergence coordination, right? Essentially, as we're talking about here, emergence of coordination. Based on where we are as far as understanding, like let's take it at a philosophical level, our understanding of how we learn. And Jan LeCun talks about a classic example he gives about like a human child's learning, right? And then we are nowhere close to it as far as the amount of information as well as the amount of compute, right? And then the cognitive architectures that are involved there, right? So walk us through, Menge, where our gaps are in our understanding from a philosophical, from a neurocognition level, as well as from a data compute and an algorithm perspective, where the gaps are, and then where the field needs to evolve while ensuring that the mistakes that we have made, at least in the previous iteration of that, especially around connection to human agency, are accounted for.
Yeah, absolutely. So I think the current largest gap is that we have no idea how to replicate the level of learning efficiency in humans. So we learn from a continuous stream of data from the physical embodied environment, from the continuity of the video streams, and very much like Professor Jan LeCun has mentioned, the LLM, the big data from the internet learning, is very far away from the way that we learn from the embodied world. So we still need to understand the continual learning mechanisms, the memory, the how it connects from the sensory stream to the embodied actions. And all of these happen in a very data efficient way that we cannot just take the union of all the humans on the planet and then record their data, which is kind of a one type of I view as a dangerous perspective out there. I think like we still need to figure out the learning efficiency question, and by doing that, we are able to create intelligence that are not necessarily the most capable out there, which is obviously you're going to take the union of all the data, but preserve the agency from the edges.
Yeah, thank you, Miguel. I think from an agency perspective, I think I'll bring Erica into this discussion as well. One example I see and I like to understand from analogies, right? So an analogy I've been using at least for my own understanding, is a child being given a box of Legos with instructions, right? And then the child would study the instructions and then take the pieces and build it, right? So essentially pattern recognition, and given the new input, you are able to create the output, right? And then you take the instructions away, they give the child some other thing, then the child, because having gone through that process one time, would create something new. Or an example of truly a curiosity-based learning would be to give the child a box without any of Legos, without any instruction, and maybe the child can figure out based on curiosity what they want to create, right? So in this case, it's a question of inquiry as well as the output, right? So it's both sides of it from an open-endedness perspective, and then we take it even into the collective aspect of it. So we get a group of children, and then think of them as like agents. And on the earlier question, there was a question, should we even be calling these systems agents? I'd say, oh, I think that's an interesting question, but for a lack of new word right now, let's just call them agents, right? So we get a group of children working together with a bag of Legos, and then they're now in no instructions, because then you have to use creativity, right, in this to create something new. And it's a collaboration, it's building with each other on top of each other, right? So these are the types of systems, at least based on continual adaptive and then collective intelligence, as we are thinking through, like where it's curiosity-based learning, new inquiries, and the new output. So Erica, agency becomes very critical aspect to it. So we'd love to hear from your perspective how you're thinking about agency when it comes to interaction with AI, and where the critical gaps are. And then as we're thinking about this collective intelligence of collective co-creation, with human and AI are in a co-creation, would love to hear understand your perspectives around agency and preservation and augmentation of agency, because
Yeah, thank you. I think I'm going to take us into a larger frame again, but from a totally different perspective of just what is the system that we're inside, and therefore what's driving decisions such as business model. And I think for any pre-revenue company and maybe even beyond, VCs want to see the hockey stick growth of user retention and engagement. And so that drives how the LLMs are interacting with us in terms of not respecting our attention. So that was also a low scoring principle. And so what I'm hearing you ask is, okay, so if that's not a high agency interaction for a user, what does that look like?
Yeah.
And I would see that really happening from a place of play. We heard folks earlier today talk about curiosity as a driver. I think we have schools like Montessori that are really built around like curiosity and play. And so I think there's a lot to learn from those spaces, and also from interactive art exhibits, such as here in San Francisco, you've got Tiat Gallery, and just watching how kids and adults are like excitedly interacting with and learning from these like tech exhibits that they have. I think it's a great model. I definitely don't have like all the answers or that, but those are the initial starting points where I'd want to be really witnessing what does that look like? What is that interaction style? And how can we emulate that with LLMs, with agents, down the road with VR? I think that we can have enhanced learning outcomes based on that place of play.
No, I love that you brought play into the dialogue, right? Because it tends to become too technical and academic in this case. And we're talking about humans learn with play, right? Children learn with play.
Right.
I like that you brought in Montessori, because it's proven out to be one of the best, if not the best system for early childhood development and learning. And as we talked about, Jan LeCun's examples of how children learn, and we're not even close to that. So I appreciate you bringing that into it. And I think we can learn quite a lot into the architectures on how we as humans learn from play, and one aspect of that is creativity and art, right, as a representation of that. Olaf, in addition to being a research scientist, you also are a very strong proponent of play and art and creation-based learning. And then within this context of play-based learning and artificial collective intelligence, I'm curious to hear your perspective around distributed representation in collective co-creation, from a play-based perspective. Yeah. And any analogies, and then again, going back to the research aspect of it, what open questions are out there that should inform this research going forward?
Yeah, I think I love play being mentioned here. Thank you guys for for pushing for this. The fun in play is that you're learning without noticing that you're learning, and this is the experiential kind of side of just you being playful, including in research in academia or in endeavors like enterprises and in various projects. It's okay, I think, to have playfulness as a component, because it takes you out of the frame, and this is something that we've been developing in a piece with Yuko Ishihara, who is a philosopher at Ritsumeikan University in Japan. In fact, she's writing a book on playfulness and the philosophy of playfulness in contact between, I guess, Western and Eastern philosophy, which I find fascinating in inspiration of I guess a lot of our AI, our tech right now, is Western, isn't it? And when we say that it mimics the mind and so on, it is within Western frames. And so we've been organizing workshops in Kathmandu for a little while that I can say more about to you later. But we invite a lot of people from those different frames. And of course, we misunderstand each other at first, the first day or even weeks that we interact. But then we learn to be shifting our frame to something that we're less comfortable with. And we learn to be okay with misunderstanding, like we talked about in the previous session.
Yeah.
And I think this is part of the play. So it's not like playing chess, right? Like we are not playing in that sense of play where we are following one rule. It's playfulness within chess. So maybe you don't care about the knight moving this way or about trying to win in this way. We try to open up the position. Maybe we don't control the center. We do something a bit crazy, and we play the game from the other's perspective. And I think this change, this constant shift of perspectives, is something that leads to something better.
Yeah. No, thank you, Olaf. I think anchoring further into that, if we think about it from playfulness and curiosity, and it represents itself into human discovery, right? And we talk about discoveries that are durable, that become durable over time. And there's an aspect of curiosity-based approach to discovery, which has playfulness to it. And I've seen this in scientists, working and in the art of inquiry that they're going through back and forth and factuals and counterfactuals, and then opening new inquiries and hypotheses, going deeper into coming back up. There's an aspect of that is also playful in that context too. And I've seen that again in enterprises, people doing financial planning and demand planning. Demand planning is you're planning under a lot of uncertainty, essentially, like how many products to make that's going to sell in the market without you losing money, right? So it comes down to kind of at that level, right, to drug discovery and things like that. So playfulness is critical to learning, and I think we establish here. So within that, in earlier discussion, Blaise talked about the role of external rewards, right? Because it presupposes what we know that the reward should be. And Mengi, I'm curious to hear from your perspective. Sure, like external rewards, and we're strictly talking maybe a little bit of a reinforcement learning aspect here. In certain cases makes sense, but it is extremely limiting when we're talking about open-ended, adaptive, and continual learning. So what's your perspective on these external rewards versus lack of rewards, and which presupposes like what we already know, right? Versus open-ended curiosity that starts with what we don't know. So would love to hear your perspective also from a philosophical perspective as well as from a research and algorithmic perspective.
Yeah, definitely. I'm glad that you asked this question, as this has been the question that I've been thinking about a lot lately. So yes, there's definitely one component that's the external reward. In fact, our organism has been optimizing this external reward of survival for like millions of years. But I think like over the time, it has also been converted into this intrinsic reward for exploration and creativity. And so one form of such realization is to be able to perceive something as novel immediately after observing some stimulus. And that stimulus isn't well represented in the previous compression of the sensory signals in the representation. And that allows individuals to perceive something as novel, but moreover, not only be able to tell something hasn't been seen before, but be able to sort of absorb that new signal quickly into existing structure. So think of like the first time maybe I hear the jazz music, it's going to be pretty chaotic to my ears. But after maybe a little while adapting to this kind of music, I can be able to perceive the structure inside. So be able to learn the structure quickly is another, I think, a necessary component for defining one aspect of intrinsic exploration reward. And this is also going to be the story of one of my preprint that I'm going to post very soon. Yes.
No, that is thank you, Mingya, for sharing that, and we'll look forward to reading your preprint as well. And I think it's a fundamental question, right? When it comes to collective intelligence, of artificial collective intelligence. So Olaf, we'd love to hear your perspective as a build up from what Mingya started here.
Yeah, it's a very it's a very actually big endeavor in research here, and how we can examine really also the interaction between external and internal rewards for systems. But I was thinking I should mention a fun example, a playful example of some experiments we've been running. So we've been interested in different forms of intelligences, which is the premise of artificial library, looking at different substrates for intelligence. And one example is that we took some bacteria and put them in a box, a sort of reactor, right? So this is mostly lactic acid bacteria and home bacteria. So bacteria that are our companions, a part of really our ecosystem, and we don't notice that there are so many microbes, trillions of microbes, growing with us, evolving, co-evolving through life, and. So we took some of that, put it in the box, put a bunch of sensors for different different concentrations of chemicals and so on, electricity, and then we passed that through a sort of converter. And first we tried that with language models. And the fun data point, the sort of outcome of this is that we noticed it was sort of uncanny to talk with them. So we talked with them, and we talked about politics and philosophy and everything with bacteria, right? Swarms of bacteria, the collective we tried to also map their emotions and so on. So that's in a series of papers. And that worked, but it didn't feel right. Whereas after that, we constrained that within a bottleneck, and we played games with them, right? Video games, chess, even, or the game of Go. And then the cognitive science papers that we got out of that showed that they were the emotion went through, and we felt their personality. And this is the kind of experience plugging that I think is missing. And I think if we could, Menge, include within those systems also this emotion, that so I think, Erica, I love that you mentioned in the beginning emotional intelligence. I think this is what it is about, right? So if you want to have humans plugged into the system, we have to level to their multi-level, I guess, system values, I guess, representation. And that is the difficulty that we want to incorporate in this.
Yeah. No, I think it's a big question. I think Erica would love your perspective on what Olaf posed, and then if you can also further build on that, the distinction between like adaptation that serves human agency versus adaptation that optimizes engagement or compliance, because that can happen. And I'll give an example, like with reinforcement learning with human feedback. We have done studies where we've seen that people, like, we bring humans in the loop to look at the responses from AI, and then basically thumbs up and down, like whether the answer is right or wrong, because that feeds back into it reinforces back into the learning. But we conducted some studies, and then we noticed that people were getting into the compliance where they were basically automatically agreeing with everything AI was basically presenting to them, which defeats the entire purpose of human feedback in this case. So that's an example of a compliance, right? So we somehow, about our human nature, it pushes us into that compliance too quickly. So I'm just curious from your perspective, and adaptation that serves human agency versus optimization for engagement and compliance.
Yeah, I love that we are wrestling with big questions here and no easy answers. I think, this kind of takes me back maybe 15 years as different algorithms getting introduced and folks just saying, well, the machine knows best, so whatever the algorithm is, it is right. And this call for algorithmic transparency of when is an algorithm getting used to make decisions that affect my life. And the tendency, as Sherry Turkle says, like to expect more from technology and less from each other. So how do we undo this? The machine must be so much smarter than me, so I will always comply interaction. It's like we have a deep groove in that interaction. And kind of as a sidebar, as I talk to folks about how are they trying to have more agency in their LLM interactions on an individual level, what folks are talking about is, at the very least, setting, customizing the instructions of like, always disagree with me, which not everyone's going to ask for that. So I think it takes us back to a design, like how can we design these systems in a way that invites debate or disagreement and isn't just a constant yes and between user and LLM. Because otherwise it's right, we're just like going into rabbit holes essentially, and deeply inside that, like,
and I think
semantic spiral.
I mean, and then we are seeing the examples of that with examples of like psychosis and then things like that are happening already. So Erica, like building further from that, I know you mentioned that your initiative is around measurements and bringing more humanity into the benchmarks and the measurements, right? And one challenge I see in the current design thinking around benchmarks and measurement, that they are also static. Whereas intelligence, we're talking about continual and adaptive learning here, and then there's an evolutionary aspect of it. And today's benchmarks are not designed to understand the evolutionary aspect of learning. And we talked about early childhood development from a Montessori, which is very play-based and then collective and collaborative learning, to we are talking about now reinforcement learning, people who are working in that, giving their agencies essentially to the AI and it just complying with it. So somehow we shift from this play-based learning over time to this sort of a compliance-based approach. I'm curious to hear the type of questions you will pose to designers of these new benchmarks around evolutionary aspects of the benchmarks. Should benchmarks be accounting for evolution of learning and essentially of human learning over time, and then perhaps also measure deviations into compliance and loss of agencies and things like that. Yeah.
Yeah, I think an absolute yes about, measuring the compliance versus full-on agency. And you're absolutely right. So benchmarks are static and I think we're always playing catch up. So it's easy to be about a year or two behind the state of the art. And I think that's where ongoing production monitoring, again, this is, post-deployment, but I think that is one part of the answer here. And I think the other is, moving beyond benchmarks into RCTs, where we're really understanding, how to introduce the right amount of friction so that learning can actually happen. So I know OpenAI has been doing work around that in Estonia and really measuring what that friction looks like. So I think it's, we're far away from, one size fits all. But I think that is one approach. And I'm not remembering where I heard this. It could have been from Saul Khan of Khan Academy, but could have been elsewhere that some results are showing that learning outcomes are enhanced when it's deeply personalized. For instance, if you're learning from a deep fake of someone that you know and care for, or just in an area that you're already passionate about. So yeah, again, multifaceted approach.
No, absolutely. And I think it's thank you for posing that. And I think it needs to be a multifaceted approach, and dynamism into the benchmarking understanding needs to be brought in versus the static measurements that are out there. So Minge, from your perspective, as you are leading research and development around continual learning and adaptive learning systems and open-endedness within that, what type of benchmarks are you looking at? What gaps exist in benchmarks so that we actually can more accurately measure this adaptiveness of the learning from a childlike learning to as it kind of evolves through various iterations, and then within that, if you can maybe speak to agency versus compliance, and maybe that's a separate measurement. But I mean, the one is more on the technical side, algorithmic side, and the other one on the human flourishing side of the things. Yeah.
Yeah, for sure. So I think a lot of the historical progress on continual learning has settled on like very clean and in a closed environment where people design a sequence of tasks and then look at the learning progress in each of the tasks and whether there's forgetting. Our lab sort of takes a different approach where we look at more realistic environments. For example, on videos, we directly take the long form child headcam videos for continual learning. So this consists of hundreds of hours of these long form video from a single perspective. And then we also want to see like whether networks can learn from scratch by consuming these streams of videos by one pass through the video, no like resample or replay. And there is some memory in the network, of course, but the overall learning trajectory is one pass through the video and see if the network has learned general visual representations, but also multimodal learning by associating different objects with their visual appearances. So that's kind of one approach that we have been taking this effort for the past couple of years. And then the other is more related to LLMs. As you know, LLMs has been trained by all kinds of data out there. So when you actually do benchmarking, you never know like whether they have actually seen this piece of data or they are just doing true generalization. And also towards testing the continual learning capability, where we were taking at is to take the news events that happens every day and form those as evaluation questions. So presumably the LLMs that are trained in the past hasn't seen what happens today, and that could form a way of testing how knowledge is continuously learned and forgotten over the timeline. So that's also another type of effort that we're trying. And beyond just doing question answering, we're also looking at these forecasting markets, how LLM agents are able to perform well in these settings. Yep, so I think that kind of answers what we have been trying on the benchmarking side of things. Towards more agency, I think what I'm currently stands is that I think we probably need to understand better what agency truly means in artificial and biological minds. So what kind of the sampling or action process are we really taking, or it feels like that we're taking? I think they are kind of still very frontier questions in the research world. And I think like by understanding that, at least in artificial systems, can also help understand ourselves. And one aspect that I'd like to bring up here is that a lot of that agency might come from just the diverse perspective, the historical trajectories that the agent has been through, not necessarily at that specific time point making that choice of action. Maybe that's in the form of a Gaussian distribution, maybe it's a softmax distribution, but it's not necessarily a deliberate choice at that very time step, but an integration over the historical time steps.
Olaf, would you want to add to that?
Yeah, there's a there's a lot that resonates with both. I think we're converging on some important features here, right? So I think Erica is saying that the static benchmarks are not enough, and so we need to measure definitely different aspects of friction, dependency, compliance, agency. Agency very important here. Not only before but after deployment, adapting as we go, and Maggie is mentioning a lot of concrete examples here, showing that the continual learning itself needs to be tested in a sort of more, I guess, in a artificial life perspective, a more naturalistic kind of stream, and that's close to how, like you mentioned, Amer, about children learn from embodied experience, right? Like not from just sort of task sequences that are disembodied from the real world, I the way we encode knowledge can be very, very tricky and multi-level, and even in a group conversation like this, actually I have trouble remembering who said what by now, right? And this is the collective sort of mixture of emergent agency that we study in the field as well. This is also part of the challenges, I guess, of studying those dynamics of learning as a whole system. When this memory becomes distributed, you also it comes with challenges and plus values, but that means that the benchmark that you're using can't be a fixed static benchmark for that either. So yeah, I think this is a strong convergence between those threads.
Yep. No, there's definitely, and I think I want to switch a little bit to we talked a lot about learning and agency. and to flourishing. And I think that the big question in my mind right now is that, we're talking about plurality and collective and provenance and agencies, right? So those are all at individual level. And the question then is whether human flourishing essentially can be operationalized without flattening the plurality of human values. Because we're talking about, building systems of intelligence that enable and augment human flourishing. And there's an aspect of that which is flattening and in compression, right? So the first question is whether human flourishing can be operationalized without flattening, and the second part of the question is, if yes, what are the ways, or at least open questions of inquiry that should be further explored as research to dig deeper into. So maybe I'll start with Menge and then to Erika and then Olaf. Yeah.
Yeah, I think these are very deep questions. So maybe I will take a minute to think about them and pass over to other panelists first.
Okay, sure.
Yeah.
Who wants to take it first? Olaf or Erika?
Go ahead.
Sure. Yeah, I think it's absolutely worth finding out whether they can be operationalized versus not. I think, again, that's kind of stepping back and then stepping back in. We're like living inside the hangover from social media. That's like an ongoing experiment that's still with us. And I think many of us don't want to see all of that repeated in our, AI infused powered lives. Hence this focus on flourishing, which, like you're saying, Amr, is pluralistic. So there cannot be one definition. It's many. And I think, does it equal flattening? I think remains to be seen, but I don't see much of it being operationalized yet. So I wouldn't say that we have a lot of data on we have effective approaches here or not, which I think gets back to some of those system dynamics of, business model and what's driving things. I do just want to have as a sidebar here, we're talking, like all day, it's about agency, and there's a lot of expertise on this panel and on all the speakers for this. And there's lots of wisdom and expertise outside of these, walls as well. And so I think there is a convening of the public, the global public, that needs to happen of, how do they see, what does flourishing look like for them? How do they see their rights vis-a-vis AI? So I've kicked off an AI Bill of Rights process where we can all name what are those things that we think we really require and demand.
Thank you, Erika, and we'll definitely take. Very aware of the AI Bill of Rights, so definitely take a look at that for sure.
Great.
Then thank you I know you, Erika, you have hard stops, so I just want to make it the next. I think Olaf and Mingi, and I think when you answer to this question, if you can also add in. How do we ensure that the collective systems of that open-endedness, there is care built into it, right? So that they're also safety conscious. So maybe Mingi, if you're ready, or Olaf, yeah.
Yeah, so I can share one of my perspective here is that I think there are a lot of debates on what means for the future human society to look like, what means good, what means flourishing, and so on. I think one feature I think it's worth thinking about is still the epistemic uncertainty. We don't know what's really good for us, so therefore we have to preserve the diverse intelligence out there, just in case maybe there are something that we could miss that there's no way that we can go back. So that's what I wanted to share on this topic.
Yeah, no, thank you. That's a big gap for sure to delve deeper into. Olaf, last words.
Yeah, so it's been very playful. I really like the session. Thank you guys for all those points that are very important. So I think Erica, your point now on operationalizing, flourishing from the top down. I guess bottom up as well. Like we said before, there are risks. That we see. So I think the thing that I fear the most is this flattening problem as well, right? So this is something that we should pay attention to, and Megan's point also matters here. I think yeah, we need to model carefully the system, and the representation will matter for how we are going to how we are going to design those actions for this collective agency. Yeah, the path being taken by the system as a whole is affecting. Yes, so this will look very different for various applications. But from my perspective, I think there's something that we can do on not metrics, but I guess sort of translational metrics between perspectives, and incorporating this diversity is the thing that I would like to pay the most attention to. Yeah, this is something that we can take into account for not metrics, but I think metametrics is the message.
Yeah. Thank you, Olaf. Thank you, Mengi and Erica, for joining us as well. We appreciate all of your perspectives, and hopefully as we continue this conversation, you'll also participate in continuous research and in papers as well. I think one learning for me for this session is actually two learnings. One is play is important. We somehow have forgotten the role of play in learning. I think that is, so Erica, thank you for bringing that in. And then Minge, I think what you brought in from an epistemism perspective is extremely crucial here. And then Olaf, bringing your perspective altogether into this meta approaches to understanding and measurements, so that we build systems that do not just flatten, but at least keep the sense of curiosity and plurality into the system, because that's where the care in the output will come from, and hence the aspect of the humanity. So thank you, everyone, and I'll pass it off to Tricia. Actually,
Yeah,
Tricia
there's a question from the YouTube that Paul has surfaced, which is what are the thoughts on how open-ended approaches square with safety or alignment or care? How do we know an open-ended system is safe, and what does care mean for systems not based on rule-based ethics and judgment or alignment? That was this is not just one question. It was like three questions in one. I'm going to paste it in the chat so the panelists can see and get a fair opportunity to understand the actual question. Thank you to the person who asked it. Who wants to take it on before we go to lunch?
I think maybe that's a question for Amer, because so this way we can move on schedule.
Yeah. I think no, that's a very big question. I think a very critical question. So my personal thought, again, not much backed by research, again, taking purely an open-ended aspect of it, is that let me read the question first one time. So thoughts on how open-ended approaches square with safety and alignment and care. So I'll take that one first. And I think that today's paradigm to how thank you, Mingi, I appreciate it. Today's approach to alignment and how it's defined and structured right now is basically a post-training behavior adjustment, where philosophical perspective of a small select group of people essentially imposed on the models, right, at the post hoc. And again, I may be generalizing it here, but with my limited understanding of the alignment here, what it does is that, in my opinion, is that it forces a perspective of a very select and small group of people into the rest of the society. And as we're talking about pluralistic of the society, so in a way, what Erica was mentioning towards the end, how can we talk about human flourishing without the rest of the humans in the room? Like, have we defined it, what flourishing is for one versus the other, right? So the plurality for me, and again, within open-ended aspect of it, has to come from that angle that alignment has to be defined at the root. And it has to be localized. It has to have its own localized perspectives and governance and participation. And it cannot be in a situation where one perspective of alignment wins over the other perspective of alignment. I think it's the systems have to be defined in a collective ecosystem where perspectives are understood by AI agents. Perspective can be shaped and shared, and then and then perhaps some sort of a perspective evolution that would come out of it that factors those in. So I think it's taking more of a pro-social approach to designing systems within open-ended ecosystem will enable at least more safety and alignment, and then perhaps essentially care in this case, because a lot of the alignment would have to be would bring in perspectives, things like stewardship based communities or indigenous communities versus and various other parts of the world, right? So in my opinion, I think it's those various aspects kind of feeding into an ecosystem and then collaborating and then evolving. So anyway, jumbled up thoughts, but that's my high level perspective on how it could potentially be done, or at least it should at least be attempted to be done.
Thanks, Amber. Well, certainly we all agree we have to rethink alignment completely. And maybe that's not even the word or the concept, right? If you're actually getting to the source and fixing the actual infrastructure versus like ex post facto, which is how alignment is done right now. So I think we're talking about something completely different structurally. Well, thank you so much for that exciting panel to follow the one that Olaf started us off with Blaise and Pierre. We're now going to move all that play into some in-person time, and we're going to acknowledge that we have bodies. We're going to take a break. We're going to go take a walk. We're going to send some emails and look at the sun and get a snack, and we will come back in an hour and 15 minutes after you have rested your mind and refreshed yourself. And we will go straight into session 2A, which is kind of the second part of the programming that you definitely want to stay for, which we start to get into the actual techniques of how we're going to get this done, into some of the nitty-gritty stuff. So with that, I will take us into a break. All right, welcome back from the break. I hope that we all took care of our bodies. For those who have been here with us since 10 a.m., it's now the afternoon on the East Coast of 3 p.m. where I'm at in Brooklyn. And so this is the conference on superintelligence for humanity. I'm Tricia Wang, and I'm your MC. And for those who just joined, drop your questions in the YouTube link, and we will let the moderator know and surface your question. Now, this summit is being convened by Cognicy, a public benefit corporation whose charter advocates for humanity-aligned superintelligence. And what the hosts have done for this conference is gather their favorite thinkers and more like friends in this space to figure out how to get humanity from A to B, and A is where we are right now, which is a dominant bet in AI that has been all about scale and bigger models and throwing more compute and more data. And this bet has clearly produced real capability. It's what enterprises are all hungry for to try to figure out what is their AI strategy, but there's a gaping layer that is just missing. And what we're doing here is to talk about what that new B is, which is artificial collective intelligence, or that's kind of the general word we're calling this whole field, which is to build AI that has what Ujwal said is dignity and sovereignty into the actual architecture, not just as a patch to it. And it's about recognizing that intelligence is distributed and coordinated. It's not monolithic, and it never was, as Blaise had reminded us. And it's that systems represent the people whose knowledge actually makes the world work, with context and authorship intact, and governance that gives communities and institutions meaningful authority over their data, their knowledge, and their cognition. And so the first conversation with Blaze and Pierre reframed this scale itself. The argument was that, intelligence we admire in humans was never about the individual. It's a collective output of society. And that was a really fun conversation. If you were there, it went over because it was just so exciting. We were talking about, how intelligence actually comes from your interaction with the environment. And if you take the environment out, then it's a whole different type of, cognition that is being developed. And then the second conversation we moved on to with Amer as our moderator, with Erica and Olaf and Menge. And then they took us to the next step. They said, well, what would happen if, since we know that, we've established in the first panel that intelligence is collective and curious, well, what does it take to keep it humane? And so we heard several answers. Let me just give a quick recap because that we can then draw upon that for our conversation, since today is all about building up to, really establishing what are the edges and the bounds of this new field. So Menge talked about, preserving agency at the edges. Erica talked a lot about emotional intelligence, and that we're just nowhere close to replicating the way humans actually learn from in an embodied, physical, continuous way. And it was really cool because we got to talk a lot about play. Olaf talked about bacterias and how that interacted with, playful learning, and that when you're playing, you're not even consciously learning, right? You're just learning through the process. But also we talked about the dark side, which is that it's very easy for AI systems to be extractive. And that's why Erica talked a lot about the importance of measurement for human flourishing. But then Olaf talks about, hey, we have to be careful we don't flatten that. And lastly, we talked a lot about emotional intelligence. That was the first time that concept was brought up in our panels. And that how do you figure out what the constraints are of embodiment when you're thinking about emotional intelligence? So now that leads us to this panel where the focus is on the languages of artificial intelligences. And so we have a great moderator here. We have Lipika Kapoor from MIT, who is going to be our moderator and works at the intersection of human-centered AI and decision-making. And I'm going to turn it over to you, Lipika, and I'm also going to say I am also on the panel. So I'm going to let you take it over, and then I will let go of my MC role and join you as a panelist.
Great. Thank you so much, Tricia. Happy to have the tables turn with this session for you. So this session, which is the languages of artificial intelligence, and I want to spend just a minute on why this session is placed where it is. And I think Tricia touched upon this, and I just want to make sure that, you kind of understand what we hope to leave from the session. So within the summit's broader frame of ACI, this session sits at what I want to call the connective tissue layer. And language is what makes shared cognition possible at all. So without shared semantic ground, agents and humans cannot coordinate or audit or hold each other accountable. So your provenance, consent, governance, institutional memory, all of it has to pass through language at some point, which means if language is broken or ungoverned, every other layer is too. So here is the tension that I want us to surface through this panel, is that on one hand, language is the most successful collective intelligence infrastructure humans have ever built. And roughly, I think more than 7,000 mutually unintelligible systems evolved over millennia that somehow let strangers coordinate. And on the other hand, the version of language being built into AI systems right now is converging fast onto a monoculture, mostly English, mostly text, and mostly trained on some corpora, and increasingly opaque even to the people who built it. So the question for the next hour is, the question for the next hour is not that is language important? We know it is. The question is what actually breaks when language becomes operational infrastructure between humans, agents, and institutions? And what are the failure modes? What protocols need to exist? And what does accountability look like when meaning moves across boundaries it was never designed to cross? So before we get into that, let me introduce our wonderful panel here. We have Bruce Schneier. He needs almost no introduction. He's a security technologist, called a security guru by The Economist, fellow at the Buckman Klein Center, lecturer at Harvard Kennedy School, author of many books, including A Hacker's Mind, one of the most influential public voices on security of complex systems for the last 3 decades. Then we have Damien Blasi. He is an ICRIA research professor at the Center of Brain and Cognition in Barcelona, a research associate at the Culture, Cognition, and Co-Evolution Lab at Harvard, Schmidt Sciences Polymath and Branko Weiss Fellow. He also advises UNESCO on linguistic diversity. His work asks what gets lost when we treat languages as if it had a default. And then we have Michael Spranger. He's the president of Sony AI and CEO of Sony Research, a roboticist by training with more than 70 papers on language evolution, grounded communication, and the foundations of artificial intelligence. And he's been thinking about how machines learn to talk to each other longer than most people in this field. And last but not the least, we have Tricia, you already know. She's the co-founder and CEO of the Advanced AI Society, building infrastructure for verifiable AI. She's had a long career at the intersection of ethnography, human-centered AI, and the question of what counts as knowledge. So I think starting with the first question for Bruce. So Bruce, if language becomes the infrastructure for AI agents and institutions, what are the main attack surfaces? Is it spoofed provenance, semantic drift, impersonation, hallucinated authority, or something else?
So human language is sort of by definition ambiguous. And I think the ambiguity is certainly an attack vector. There was a philosopher at MIT some years ago. I'm blanking on her name. It'll come to me in a couple of minutes. Abby Jacques. What she said is that in human language and even thought, wants and desires are always underspecified. I mean, that's the moral of the genie, right? The genie can always grant your wish in a way you wish he hadn't. That's the moral of King Midas. And I think that ambiguity gives a lot of room for AI, both by mistake and because directed to do things you don't want, even though you tell them to do it. That's a new attack vector. I mean, certainly there's the other things you mentioned, but I think that ambiguity, which you don't really have in a programming language, in a formal specification language, is a really interesting new way to think about semantic attacks.
And
I have a quick thing well, Bruce, I think it's ambiguous. It's more ambiguous the farther you're away from that culture. It's actually less ambiguous if you are culturally situated.
I mean, I think not. I think it's more ambiguous. If I say, bring me some coffee, right? You're not going to bring me a pound of raw beans. You're not going to buy a coffee plantation. You're not going to rip a cup of coffee out of the person standing next to you and bring it to me. I mean, the kind of coffee I'm going to get depends on context. And if we're in the same culture, you're going to know what I mean by that. A Turkish coffee, an Italian coffee, an American, right? I think
I agree with you.
Even less is said.
Yeah, no, I mean, that's my point, is that you have to be culturally situated to get that. And some languages are even more ambiguous. So it's really going to be interesting to see how that's exploited across different cultures, for languages because some languages are more explicit and some are not.
And so maybe let me bring you in, Damien, on this one. So ACI assumes knowledge can move across contexts. And what does linguistic diversity teach us about what is lost when meaning is abstracted or translated?
Well, I might start with perhaps what I think is one of the biggest forgotten aspects of linguistic diversity that have to do with the subtle differences in grammatical structure across languages. And different languages might emphasize different pieces of semantic information. They might force you to obligatorily convey certain type of information. I usually, when I speak to all English audiences, I usually bring up the English plural, right, for nouns. Like English forces you to decide whether something is one unit of it or multiple units of it, right? So you're forced to choose a form. That's information that you cannot escape unless you come up with a very tortuous construction to avoid it. But there's different languages that force you to express different pieces of information. like when in the past an event took place or the future, the degree of likelihood, the epistemic nature of the statement you're making, whether the referent you're talking about belongs to one of n categories of grammatical gender, you can classify the world, etc., etc. And I think that, I think there is a lot of emphasis on the fact that there might be not lexical equivalence between languages, that the single word might not be perfectly, I mean, we all love those examples, but the case of grammar is much worse because it's not restricted to just one specific word, but it permeates the unbounded space of messages that you can transmit. So most of the time, people don't seem to care much about this. I think in part because most of the translation problems that we have been dealing with involve either languages that are fairly similar from a global linguistic diversity point of view, or they just happen to share a number of commonalities almost by chance. Let me say, for instance, that in cross-cultural psychology, for instance, there is an overwhelming representation of the comparison between Americans and Chinese. And, it seems like very different societies, and people have been speculating about why these peoples and the languages might be different. But from the linguistic point of view, they share a number of important regularities. Like, for instance, both English and Mandarin, they have very little morphology. So there's a lot of things they don't express. And, I could bore you to death with a long list of technical equivalences between these languages. So I think that our intuition about how important these differences in grammar are is not based on a wide view of linguistic diversity. And again, we might be losing those subtle pieces of information that are obligatorily parasitic to every message that we have to encode in different languages.
That's very interesting. And I think, would you say like that, what would you actually point to where the loss is most visible? Is it in between the grammatical rules that kind of varies across different languages?
Mm-hmm. So let's go back to this notion of ambiguity, right? There's some extreme cases. People, for instance, in academia, they like to bring up one variety of Indonesian called Riau Indonesian. This language has essentially no obligatory marking. You can say something like chicken, person, eat, and this could mean the person ate the chicken. The chicken will be eating multiple people, or, there's some general event that involves eating person and chicken. It's completely undetermined. Now, just imagine for a moment that you cast a message that is contextually grounded, that is very dependent on the non-linguistic signal, and you just want to translate it. Obviously, there is deficit there, right? So any translation will involve putting in information that was not part of the message, not only because it was not expressed, but because users didn't need to specify it, right? Like there might be a case that you can construct a linguistic message where you don't have to decide whether you want to say that something is plural or singular. It's just not part of it. But if you want to force any message in this language into English, you need to take a decision. And the question is, how do you base that decision? And so, yeah, I think that's
Yeah, and Michael, maybe I'll bring you in at this point. Like your work on grounded communication asks how agents connect symbols to experience. What does shared context mean when agents perceive the world differently?
Yeah, it's a great question, and I'm gonna kind of add something to the discussion that was already happening. So one, what Bruce was saying, so the way we talk about this is language is an inferential system, and it gives people pointers, and then you still have to reconstruct the meaning or actually the pragmatics also from the context. And similarly, as Damien was explaining, languages have different grammatical structures that force people to kind of pay attention or conceptualize the world in different ways. And I think then the third step of this is actually conceptual systems that are really tied to the language that people speak. And so I used to work a lot on spatial languages. And so there are these island cultures off the coast of Papua New Guinea who mark everything with respect to some volcano that's always visible. And that's a very different system from the systems that we have in English, which are more projective with front, back, left, and right, and much more centered on individuals. And so this, I think, points to the fact that language has a very deep, or it's, we're going to be careful not to trigger any cognitive scientists, but essentially language and meaning are somehow connected, and they're very deeply connected, and they force people to think about the world in particular ways, especially once the language is established. And as you can imagine, and this happens to all of us in translation, we lose a lot of this. And if we do speak different languages, then sometimes we can express ourselves better in different parts of the languages that we know. And that applies to words, but it also applies to grammatical structure. And so I think that's the human side, and I think that's a really important property. I should say that I'm always very impressed, even by current systems, of how you can mix and match languages that these systems have been trained on, at least. And this doesn't apply to all languages of the world, but I frequently may interject English and German, in some cases Japanese, talking to these language models. And they very often seem to come up with the right solutions. But it's interesting to think about what we lose if we do not have language models that do kind of represent that variety that we see, that diversity that we see in human languages. Because I do think that's in many ways a strength, because it kind of broadens the approach to the world that we have. And of course, ultimately, everything has to be related to context. So if you think about Japanese often doesn't mark the subject of a sentence, doesn't really tell you who is doing what, because the assumption is that you can infer that either from a cultural context or the context that you actually experience together with an interlocutor at that moment. And what is important, especially in the work that we did, is that the context, that embodied interaction, that situation that in our case robots were in to learn to communicate, it helps structure the understanding of a meaning of a particular thing in a particular context, but it also helps in learning. Because if you're not exposed to that context, you actually can't make those connections between the linguistic symbols and the things that you're seeing in the world.
So while the shared context is kind of like, helping in the learning, like how would you know that an agent an agent had generally like shared context versus just fake the surface of it? How does that distinction, do you think, agents tend to make?
I mean, ultimately, we have only one measure in these experiments, which is communicative success. So, the interlocutor, the speaker, has some intention, and then has some intention with respect to the speaker. And in our case, it was relatively simple, referential type tasks. So, like pointing to something or paying attention to something in the real world. And then the speaker would test whether that actually has been successfully transmitted by checking whether that's true and whether that is what well, in this case, robots, what they had in mind, so to speak, loosely speaking. So sorry, again, don't want to trigger any cognitive scientists here. And I think in many ways, our interaction with AI systems are the same. So if we work with AI systems to give us answers to things, write documents for us, do reports, I think the ultimate test is, does the system actually come back with something that's meaningful or useful or interesting to me? And that's really what language is about, right? I mean, at least in this task-oriented view, maybe not everything, doesn't cover everything that language is about. Language is also about inspiration and so on. But if that loop is closed and people are happy with the results, I think that's a very strong signal that things are working. That's a very usage-based view, by the way. Again, so there are very different cognitive views on this, so cognitive science views on this.
Right, and Tricia, on to you next. Like from your work on quantification bias in human meaning, like where do AI systems most often flatten or distort the tacit knowledge?
Yeah, so the quantification bias is a concept that I had coined about probably 15 years ago when I was working at a research lab at Nokia. And I have a whole talk about this online that I did essentially 10 years later when I felt it was safe enough. But I was working inside Nokia and I saw the quantification bias, which is the tendency to prioritize that which is quantifiable in the form of numbers over anything that is not quantifiable. And so this is a problem that started way before AI. I think some people talk about like these systems are imperfect now, but they have been imperfect ever since we started digitizing data. And in particular, what I saw happening in enterprises is that there was this idea that we could now have big data and we can now make all the predictions and decisions, all the correct decisions we needed. But the problem was that I saw up close what happened when a company would only prioritize quantified data. And I had been living in China on and off for about 10 years then. And I had been doing research explaining to them that you are, it was in 2006. So it was like Nokia was the top cell phone company. It was Apple had just come out and everyone thought, this is ridiculous. This is when you saw Microsoft making a joke out of, Apple. It was like Steve Ballmer, remember like that video of him jumping up and down on the stage with like sweaty, shirt and everything. And I remember coming back after about a year of research and I was like, hey, Nokia, I need access to more quantitative data because I have a lot of thick data, the qualitative part. I had to rebrand qualitative to make it just as sexy as big data. So I was like, I have this thick data. And it's telling me that I don't think Nokia has a business because I don't think anyone's going to want your phone anymore. And I explained to them the whole emotional experience of a phone, and they didn't really want to listen. And so anyways, I left Nokia and then eventually I did a whole TED talk on that. But what I had learned from that experience has cascaded across all my work with any kind of emerging tech, and especially with AI. So it's like my work hasn't necessarily changed, but what you see with AI is that it only increases and scales the flattening and distortion of tacit knowledge, because tacit knowledge is very resistant to quantification. But there are people who really think that you can perfectly quantify everything and put numbers and weights to everything. But there are certain types of fields of knowledge that are more easily quantifiable, like code. There's that is much more quantifiable than a lot of the construction workers I was living with, or the migrant workers I was spending time with in Mexico. So I've done this work all around the world to find out, what is the kind of work that is very difficult to quantify. And the system rewards what can be measured. That's just, and it ignores what it can't. That's what you see happening in AI systems, at least right now, right, with the current systems. And second, you really see that the system flattens the people who have given it these inputs, which are anonymized. And what I see happening is that when executives are working with AI, is that they really think it's real, especially with LLMs. I want to be very specific about the type of AI we're talking about, is that that there's this illusion that the response is because it's happening, it's in a language coming back. I think that's the issue, is that we're giving language inputs in and it's flattening it. But then what's weird is that it's the system, instead of a dashboard like before with big data, now we're in AI, the system is now giving back language. And so it's really misleading people to think that these systems represent the exact reality, when really it's not representing facts. It's representing, at least on NLMs, it's representing probability. It's a probabilistic system, but I see executives and people using it as a deterministic system. And then another way I'm seeing it is that the system, I think it just there's no mechanism for people to correct or revoke and change the language of AI. So there's no kind of ex post facto. Once that data has been gathered and ingested, there's little ways for people to interact with the system. And so in the end, it just means that the system is reflecting information that may be outdated and may not, the people who are being represented may not agree with it. And so I see like a real distancing, and the quantification bias is just even more extreme. And if anything, it's hidden now. It's hidden through language.
That's a really interesting point. And I feel like as humans, we separate the buckets of what is deterministic and what's probabilistic. Deterministic because, there are rules and we know how, what comes next. And however, I think for AI, they are still differentiating. They kind of treat deterministic and probabilistic in the same way, even though the rules are defined. It's kind of doesn't take it, at 100% probability that it is what it is supposed to be. So, yeah, thank you for that. Sorry, was someone trying to come in? All right. So, moving to the next, part of this panel today, I would love for each of you to maybe name one specific failure mode in language-mediated ACI, which is something concrete. Maybe, Damien, we can start with you on how do we perceive diversity while still enabling interoperability?
Okay, so I will use this as an excuse to talk about a topic that I'm very obsessed with. And there is a wave of papers that started in 2024 with the famous Do Llamas Think in English, where essentially people have been looking at the intermediate layers of LLMs and just trying to keep track of the tokens that are being activated and map that into the language. And one very robust finding of, at this point, I would say like 20 or 20 plus papers in this tradition, all very well cited, is that in the intermediate layers of LLMs, there is a clear activation of the high resource language. So some aspect of the computation takes place in that language. And then only in the last part of the networks is where the translation takes place. There's also something that happens early on, which is still not very well known, that doesn't seem to project to the space of tokens, which is very interesting to discuss. But I think that's something that we are just starting to understand, right? The fact that, yeah, we empower and we resource languages through the most high resource languages out there, and they seem to be working fine for a number of very pedestrian tasks, but there's still this huge mediating filtering that is a high resource language that it's, presumably involved in the loss of nuance, in the loss of performance in certain tasks that we're barely talking about. Another thing I wanted to say in this regard is that, and I think that Michael was sort of hinting at that, is until recently, there was a tendency of discussing linguistic diversity and AI from the point of view of deficit, right? The fact that we're not serving very well the world's languages. So this is a problem. But I think there is another aspect of this, which is to think about this as an untapped resource. I know, and it has been mentioned a number of times, languages have been slowly evolved over thousands of human generations. They all imply slightly different representations of the world, different vantage points, and presumably we want to have more of that, right? We want to have as many diverse perspectives of the world as possible through languages, and presumably those could fuel an increase in machine intelligence across a number of tasks. And I know I've been a bit vague on what task I'm referring to, but perhaps we can zoom in later. But I will start with that.
So maybe I can just follow up Damien here, because I think that's exactly right. So I think one of the strengths of human cognition is the diversity, and I think it's evidenced by language. And of course, one of the worries I have with maybe current AI systems is that we're sort of overfitting onto a very large probability distribution of a current language, right? And for a while, at least, the models were trained and then they stopped, and then there was a lot of stuff that was kind of left out for the training. I think that's gotten a lot better. But I feel like one of the things that maybe this is not leaning into enough, or maybe can make some progress on, is that language also, I mean, we do also create language on the spot within certain limits in order for us to make sense of new situations. And this sort of very strong adaptability, right, in the background of like some form of cognition abilities that are shared across humanity, I think that's a really interesting one. And I'm also thinking that, so yeah, there are sort of the interfaces between humans and AI systems, but there are also interfaces between AI systems, and they don't necessarily have to be the same. And I think there's some strength there in really forcing much more adaptive systems that can create new conceptualizations and new ways of making sense of the world on the spot, and then test them out. So that's something I'm really excited about.
Can I respond to that? I completely agree, and I think this is something that I fear sometimes might be misinterpreted not in this case, but in general. When I say different languages or different pathways to cognition, etc., there might be this idea that there are like hard boundaries. But what Michael is mentioning is extremely important, which is there is also this huge meaning-making generative capacity that humans have. Let me just to link back to what Tricia was mentioning, which is ethnography, which is a field that I love deeply. There is this project that we are currently coding data for that has to do with first encounters between humans who don't share a common language. It's mostly like missionaries and conquistadores and people who got lost in different parts of the world. And human groups get together. They don't share linguistic code. Languages that might have diverged maybe 40,000 years ago, 50,000 years ago, whatever. And they're still able to communicate with sometimes proved communicative success extremely complex messages, like where is the river where this ship went last week and there were 3 people, and you can still communicate even in the absence of language, which I just think is very important. And that's again something to highlight, which is, yes, we have all these languages, but apart from that, fueling that creativity and ingenuity, there is this open-endedness nature of humans that are able to establish meaning even without a common cultural protocol.
And you really see this, Daniel. I love, first of all, thank you for knowing what ethnographers do, because I'm always like, yay, to the field. We're such a rare breed in tech. But to your point, this is why I think studying memes is so important. Kenyatta Cheese made Know Your Meme, which is now in the Library of Congress, but he really formalized the study because memes are the smallest unit of collective intelligence that survives transmission. And you can also see how it's generative. Memes were doing this before AI was here. And you see how language is the infrastructure, memes are the packets, and then they move, through our pipes, and they're able to encode context without flattening. Now, it doesn't mean that, it's always the same meaning or that people can agree on everything, but there is a collective agreement and intelligence around memes. And oftentimes I think we don't take it seriously because it's like memes about, pop stars or from movies, but you really see how a meme can carry emotional charge. There's countless BTS memes. You see, BTS pop stars, like they are able to transcend language and culture. Mexico City just had one of the largest gatherings for BTS, and Claudia Scheinbaum is going to, invite them back as, these Korean pop stars. So you see how those, memes have played such a big role in creating a collective kind of norming around that. We may not speak the same language, but we're going to generate similar meaning. And so it is possible. And you see that it is tacit knowledge in motion with memes. And that's something that I think AI systems have not caught up to. I'm not saying it can't, which is why we're here to talk about that. But I loved your point about that yes, human beings have that capacity, and we can see that in the way mimetic culture works.
I want to not stop Bruce from jumping into this, but maybe there's another thing that I thought while Tricia and Damien were talking. So, and I'll give you an example. So we built a robot that is competing with the best table tennis players in the world, and we did something similar for racing. And one thing we learned from this, when you have systems that are approaching these really top performances of elite athletes, is that if you're an elite athlete in some sport, there are probably like 10 to 50 people that are in the world that are at your level. And that means that the space of top level table tennis is actually largely unexplored. Like the kind of skills that people can use, the strategies, and it's the same in racing. I think it's basically true for any endeavor where humans really need to work very, very hard to excel. And if I think about like one of the obviously biggest human endeavors, which is science, there's really 2 things coming together. One is, of course, I just looked this up actually. There are about like 1,000 to 5,000 of the world's leading biologists. And of course, biology, as in any other science, is largely based on building a representation system and language to make sense of the world. And what that means, I think, is that most of those areas, mathematics, physics, and so on, I think are actually largely unexplored. And biology is a great example of this because it's so complex. And so if we had systems that can participate in this representation building together with humans and help humans better understand and explore that space, I think there's a huge opportunity here for AI and these collective systems, frankly speaking, to unlock like all sorts of stuff that we might be interested in, like cures for diseases or new forms of thinking about physics or mathematics and so on. So I think there's 2 parts to this, right? One is we want to be understood and we want to create meaning in the world, but in some cases also we're looking to explore the world with language, and I think their representation plays a huge role. And if systems can help us do that collectively, that would be amazing.
Bruce, would you want to come in on the failure mode here?
So I think of a different failure mode, and just really a little bit what I talked about earlier, and that's the what I've heard called reward hacking. This is not necessarily a large language model. This is just other AIs where they solve a problem in a way the designers didn't anticipate or intend. There are a lot of really fun examples. You asked for something that's fun. Reward hacking is great fun. There was a block stacking. All these happen in simulated environments. And so a block stacking simulation where the AI figured if it flipped the block over, it would get the points for stacking without actually stacking. There was a boat driving simulation where the AI spun the boat around really fast instead of doing what it had to do. My favorite was some kind of evolutionary simulation where the goal was to get to a distant finish line as fast as possible. And instead of growing longer legs or bigger muscles, the AI got really tall and then fell over. And these are sort of great examples of the AI thinking out of the box because it has no conception of what the box is. And that is either creative or it's disastrous, depending on context, depending on how it's being used. So to me, those are fun when the AI misunderstands in ways that are interesting.
All right. I think I'm also, is there any other comment that any of the speakers want to make? I have a few questions coming from the YouTube.
You should take questions from the audience.
All right. So the first one is, if there are voices inside LLM, the James Evans paper, should we talk to the LLM or to these voices? Is there a right level to be talking to?
Do we know the difference? It's a deep question. I don't think anybody's like, talk to everybody. I don't know.
Yeah, especially like in the early days. Yeah. All right, we have another one. So the alternative conceptions of AI that were discussed this morning focused on AI that is local, contextual, and continually learning can fit with a more heterogeneous linguistic ecology. How might those sorts of architectural shifts, the kinds of concerns related to surveillance and the undermining of democratic systems that Bruce has warned about?
I'm going to start, but I actually want to hear from the other panelists as well. I mean, there's this theory that embodying these systems will give them an extra piece of learning, that having them have skin in the game, consequences. Media Lab, person, a really good Atlantic article, Deb Roy, really good article on this notion of consequences. And then an AI needs to feel consequence. Otherwise, what does it mean when an AI apologizes? So there's some really interesting research here in that it will make a difference. But, a lot of people will say that that's just doesn't make a difference at all. And the answer to your question is we don't actually know. And right now we're experimenting with everything, but it's certainly a worthy experiment.
I'm gonna jump in here. Yeah, so I think it even goes like there's a different way to look at it, is to say, yeah, the obvious answer is like, of course, we go hyperlocal and we go personal on device or anything, that allows us to do what we were talking about earlier today, right? This more local contextual continual learning. And you would think that it would reduce surveillance because you don't require everyone's data to flow into a centralized place. But then it's not for the deeper answers that our surveillance problem isn't really solved by where the data lives. It's solved really by the identity that the system requires you to present. And so a lot of the work I was doing the reason why I chose China was it just so happened I spoke Mandarin, so that was helpful. But a lot of my field work I chose to do there because I wanted to be in a place where privacy was not the norm. but anonymity was, and that those two things are not the same. And privacy is when the system knows who you are, but cannot use that, information against you. And then anonymity is when the system doesn't know who you are, and both have a place. So at a bar, you can be anonymous, and you can interact, and share information, but not share your identity. And you can have privacy with the government, because the government, where you live, you pay taxes, they have your address, but they don't see what you're doing inside your house. So it's really interesting. I want to go after Bruce, who's talking about democratic erosion. And I think, it's going to be interesting to see what current AI systems, or even new systems that we design, which is, will it require persistent, traceable, monetizable identity to function? Is that a property of the model? Will that be property of business models and the architectures wrapped around it? And so ACI architectures could shift this, but only if they're designed to support this kind of context appropriate identity and give people the flexibility to choose, and I think one of my critiques has been, before AI happened, is that we have been demonizing anonymity and our spaces to be anonymous on the internet, and even in physical life on the internet in particular, have decreased. And so it's something that I'm watching, is to see, like, how do we have, in order for these democratic systems to survive, do we have to have things like anonymity? So how do we bring that in? I would love to hear from others too on how they're thinking about this.
I could say something in terms of again, my boring and recurring system, which is languages, but there has been an increased interest in on the type of vulnerabilities that might come with tapping different languages. And I'm thinking just about prompting and guardrails, right? And one of the most interesting observations, and I'm not sure if this is published, I've seen this in a workshop 2 months ago, where people have been prompting LLMs in languages that allow for honorifics, and where the language itself allows for a larger social distance, right? Their languages are relatively egalitarian, where you can ask quote unquote neutral question, and there's going to be a cost for a human and a machine to just turn you down and say, cannot answer that. That's not possible. But in other languages, the cost of rejection, of just saying no, implies a dramatic loss in face. So it's much harder to deny a request in a different language. And what might happen is that in those languages, what ends up happening is there is some concession. They don't jump the guardrails completely, but they give you something. And the question is, well, can we use those vulnerabilities to access information that in the languages for which we do our LHF, for instance, are heavily guarded, but there might be backdoors where you can access the information otherwise?
I mean, I've seen research where guardrails in one language don't work in another, where you could translate the exact same. I don't know if that's what you're talking about, but that is a similar issue.
Absolutely. Here, I think the point is that people are using their understanding and science of language to find exactly those languages where rejections are particularly costly from a social point of view. And of course, if you're, so.
You're right. I want to see that paper. That's really interesting.
I'm not sure I can add much to this. Maybe I can add a practical perspective on guardrails by themselves. So, like, as obviously I'm part of a company, it's very difficult for us to trust guardrails today. It feels like it's such a nascent early space, and there's not enough kind of conviction to really trust guardrails. I mean, literally, I heard a story recently from some internal teams that they were able to take out some guardrails, but by asking the model to ignore the guardrails. So, those kind of things are still happening. I think this is very early space. I think the models are really complex, and how to make that actually work, I think, is going to require a lot more research. I think on the privacy side, it is such a large societal discussion that's happening also today already with like different types of targets that people are trying to pursue. So as I'm sure all of you are aware of issues around minors, we're interacting with AI systems, which may change a view of privacy or anonymity. So it feels like it's such a complex emerging space where there's a lot more societal discussion that has to happen. But I'm pretty sure that thinking that a local model does not have any privacy issues is a fallacy.
Yeah, totally agree. It's like it's not about local. It's AI where the person interacting with it gets to choose what kind of identity they're presenting, and I think that system has to honor it also cryptographically, not just by promise, which is moving into Bruce's field. And I would love to hear his thoughts on that later if we get into that.
And maybe to chime in here, I think Damien's observation about honorifics is striking, and then it suggests that the same model could behave very differently depending on which language it is prompted in, which also sounds like a security problem than just a linguistic one. Bruce, would that change how you think about red teaming? Right now, most red teaming is done in English.
So this is a known issue. I mean, I already know groups that will use alternate languages in attempts to get around guardrails. So this is not something where we're uncovering here. This is something that is known. I mean, it's a subtle problem. I mean, because you need an enormous amount of expertise now, or rely on machine translation, which has its own issues. So this is known, and yes, it is a problem. But prompt injection is an unsolvable problem. Like, we know that. This is not something we can, need to figure out all the ways to do it and block them. It is fundamentally unsolvable with current architecture. So knowing that kind of helps you when you go into it.
Right. I'm looking at other questions here. Maybe just to talk a little bit more about the verification layer, like what is the minimum verification layer institution needs before they can rely on AI mediated language? What would that minimum level would look like?
I really want to hear Bruce's answer.
Yeah, I know, but I think about this a lot.
I was waiting for Jeff to start.
And the fact that I don't have
an answer. Say?
I think about this a lot. The fact that I don't have an answer, I think, is very telling. So this is the whole notion of integrity, assurance, trust. We don't know how to measure this, how to think about it, how to determine if a system is above or below a threshold, or what even that means. So we are very early in our conceptualization of it. And I think it's a critical problem. And I really worry that our use of these systems is going ahead of being able to answer that question. But we actually can't answer the question right now. We don't even have the language to talk about it in a useful way.
Lamika, I want to jump in here in that, the reason why we created the Advanced AI Society was to acknowledge that there's a whole growing field called verifiable AI. And most AI is seen as scary right now because you can't confirm a system actually did what it said it was going to do, and AI said it was going to do. And we need to start somewhere. And there's a whole emerging field that Bruce has great expertise in, which is cryptography. And I come from also the blockchain space. And there's all these technologies that are out there that are now being applied to AI. And it's an emerging field. And it's called verifiable AI. And I think that right now, there's no way, at least in mainstream enterprise AI that's launched, is that there's a humongous verifiability gap. And as Christian Catalini published a paper, he's based out of MIT, and his paper, along with two other co-authors, talked about how as the cost for compute drops, the verification remains, is a bounded issue, and there's different ways you can verify. So that as the cost of compute drops, the verifiability gap grows. and you can verify by humans with a human being. You can, this is not just meaning human in the loop. It's like literally we need to have a human say, I authorize this. But if we're talking about agentic AI, we're having, transactions are being done at machine speed. And a lot of the mechanisms that we have, like OAuth, was built for a human-initiated world for resolving identity. We never figured out identity to begin with. So first, we have to give ourselves all a break, because like the systems we've been patching identity together. But I can't imagine a more urgent time right now to say, hey, all the tech we have been developing in the cryptography space. And the sad thing is, I think it's unfortunate, is that cryptographers and also all the people who worked on the technology for decentralization, blockchain and crypto rails have been very separate from mainstream developers that have created our current AI systems. And we can't afford to have those communities be separate anymore. Usually the CISO is not at a board level, and they're not at the very, they're just, they're often seen as like anti, like they're seen as like anti-innovation. And so a lot of times people don't want to talk to the security people until they have to.
Yeah,
and we can't afford to do that anymore. What'd you say, Bruce?
That's the way it goes, right? We're always
but we cannot. So this is why I'm like, we have to, this is why we co-founded a few of us, Advanced AI Society, to ensure that we can't have this gap anymore. And so, Lipika, to answer the question of like, what are the things that have to be resolved, is we have to resolve identity. We have to resolve authorization. Everything has to somehow roll up. We are in a world where human agents will outnumber human beings, but we have to be able to say, this was rolled up into this is human authorized, this is what human delegation looks like. And earlier we had a talk, I think it was someone had mentioned all the legal work that's now being done on how do you think about legal personhood for agents, that all of that has to roll up to humans. And we have to figure out the identity piece, we have to figure out the authorization piece. So one of the first things we're working on at the society is a proof of control standard for cryptographic verification, because there are things we can agree to, and that's a thing that hasn't been decided. What counts as cryptographic verification? And we don't want to let any one vendor control that.
And Tricia's point, it's thing-to-thing authentication. It's not me to, usually when I authenticate, it's either me to an object, so maybe I use my face, or me to a remote service. This is a thing to a thing, right? It is a sensor authenticating to a car. It is a car authenticating to an AI that's in the cloud analyzing traffic. We don't know how to do that at scale. That's actually extraordinarily hard.
Bruce, this is why I want to get you involved in our work, because I'm so happy we're on the same panel.
You and I will talk.
Yes. It's so interesting, because I think, and maybe I think we're nearing the time also, but I would love to hear all of your thoughts on, I think, as we kind of, wait to kind of get more clarity on how identity and authority, like the rules around that becomes clearer, like what do you think, like where does the meaning actually live in a multi-agent system? Is it, and it's kind of, I think, not an easy answer again, but is it in the agents themselves or in the protocol between them? Or how do you parse, the question of authority or identity between the two, the agents themselves versus the protocols between them? David, I see you smiling. Maybe do you want to chime in on this?
Well, what I have to say is that this problem is structurally the same problem that people have had with the ontology of language. Is language and meaning something that lives in people's heads, or is it the convention that allows for meaning to flow? And I have to say that with the amount of time that we have left, this is still an unresolved problem, but it's an interesting one.
Yeah, I think this is one of the deepest questions. Where does meaning live? So I don't think we're going to solve that on this panel. I think one way to make progress in this is actually who does it matter to? So, that might determine a little bit where people might look for things. I was going to go back to this verifiability question because, we do assume, and I'm not saying this is a good thing, just as a description, we do run very large societal systems on non-verified systems, right? And I think one large example of this is really finance, where there's a lot, large interconnected systems, computerized trading, and so on that are all not verified. And I think as an outcome of this, we are seeing periodic large crises emerge where we then try to put in all sorts of mechanisms kind of post hoc, like circuit breakers or market shutdowns for periods of times and so on. So I'm kind of curious if this is ultimately going to result in something similar, where rather than being able to build things verifiable from the start, we're going to try and sort of post hoc govern these systems.
It's a very interesting thought. And I just feel like, I think just kind of going back to the other question once again about where does the meaning live? And I agree, like it's not a question that we can solve at this point of time, but I feel like this is a question that we want to continue to think more, and I think more of the research work will help us get more clarity on that. And I think part of the purpose of this panel is to also kind of raise these questions that we understand or we don't understand, and continue to kind of work through those. We have, I think, last 2 minutes here. If anyone has any final comments before I wrap up. All right. Take that as a go for the sign off. So I would say I think this has been like a really interesting discussion, and I think I would say for the wider summit, the 3 protocol requirements that I think we can kind of leave on the table is that, I mean, one, every AI to AI message should carry provenance and consent metadata, so authority is traceable. So I think we can agree on that. And then second, that translation across context should attempt to log what was lost and not just what was conveyed. And I think that's the diversity of meaning is a feature, and it's not a bug. And lastly, I would say that authority claims in AI mediated language needs a revocable trust layer, and that the static trust does not necessarily scale. And these are not solutions; these are just the beginning of an agenda that needs more work. So thank you so much, Bruce, Tamian, Michael, and Tricia, for this amazing panel.
Thank you.
Thanks, Lipika.
Thank you.
And
Over to
I'm
you,
going to
Tricia.
take over my role as the MC. And I'm so excited for all my co-panelists. I'll be contacting
You should
all
get a
of you all.
hat and change your hat when you do this.
I'll change my
Yeah,
shirt and
that's a
costume.
good idea.
Yeah, I need like a special face made for a Zoom face made for me. Well, I just, this is one of I was so excited for this panel when I saw everyone's names on it. So, and Olaf was right, because he's like, you're going to love his panel we put you on, and such a great moderator. So with that, welcome back from the break, or welcome here for the first time. If you just joined us, and if not, then you got to witness a super exciting topic. A really fun panel that took us into the second part of the day of the gathering, which is really starting to figure out what are the things that we're going to need to design into our system. And so for those who are just joining us, the summit is being convened by Cognicy, a public benefit corporation whose charter advocates for humanity-aligned superintelligence. And this is the reminder that this is a gathering of friends to figure out how to get us from A to B. A is where we are right now with AI, which is like big models, AI, where you throw more compute at it, where the future is where we're going is artificial collective intelligence, ACI, that builds upon dignity and sovereignty of human beings, but actually doing that into the architecture. And so this next panel is a humongous one. And this is why we have Olaf moderating it, because it is such a meaty topic. Now, feeding into this panel were 3 very important discussions. So after this, we're going to be about halfway. We're already halfway through the day. But the early morning with Blaze and Pierre really started out with us just all agreeing. I don't think anyone disagreed that intelligence is not individualistic, even though we may portray it that way, but it's a collective output of society. And it's that curiosity that drives the production of intelligence, and that makes intelligence generative. So we have to protect that. And that's why in panel 2, we talked a lot about play, about how do you keep that collective intelligence, how do we protect it for human beings? And so we talked a lot about the importance of emotional intelligence in the creation of these kind of systems and how we have to be careful to not create extractive systems. Now, in the last panel, if you were not here, just a quick summary is that and by the default, our current systems have captured most of through LLMs is through textual language, and what gets lost and what gets flattened, and in particular, what type of tacit knowledge is lost. And then we were able to talk about the governance piece, which is really critical for ACI world, which is that if we want people, if our assumption is that we can develop a new world where we can capture more intelligence in a way that's going to respect human dignity, that means that one, we know that most knowledge has not been captured by our current systems, but in order to get this whole world of other knowledge that exists, we have to we have to build in the governance piece, which is the verification piece. And so we got into the nitty gritty. We had Bruce Schneier on it, who is this, star cryptographer. And now we're going to get into, well, what does it mean for session 2B to talk about diverse consciousness and multi-scale minds? And I was really excited when I also saw Divya Chandler's name on it, because I've been following Divya's work for a while. Well, Olaf is going to be the moderator of this session, and Olaf is one of the co-hosts. And we also have Joshua Bach, who's executive director of the California Institute for Machine Consciousness, which is where a lot of the people are at right now in San Francisco, as we have that view. So hello to all the San Francisco people. And then we also have Philippe Beaudoin, from the founder of Law Zero, who's building safe by design AI in cognitive societies. And we have Ryota Kanai, who is the founder and CEO of Araya and leads Japan's Moonshot project on brain-machine interfaces. And he's one of the world's leading experts on artificial consciousness. So it's really cool that Olaf, that you are now bringing in all the folks from Japan. And lastly, we have Michael Levin from who's a Vannevar Bush Distinguished Professor of Biology at Tufts and also Director of the Allen Discovery Center. Exciting. I'm excited to see him and Divya exchange on the work around biology and his work on bioelectric signaling as a form of when cells engage in collective intelligence. So with that, I'm going to turn it over to you, Olaf.
Thank you, Tricia. So we are in good company here, and hopefully people are also hearing us fine online. Yes?
Yes, all good.
Amazing. Amazing. All right. So this is a sort of relaxed session on a very relaxed topic, the nature of diverse consciousnesses and multi-scale minds. Very easy questions. So of course we should relax in a niche construction relaxed way. So this morning we already asked questions that were difficult, I think, about the architecture that would allow for collective intelligences to become active, right? The previous session treated languages trust questions that are, if anything, even more difficult for efficient and meaningful communication between beings. And now we go one level deeper, I guess, which is what kinds of minds we are trying to connect, preserve, augment, or build from scratch, which is a sort of thematic that we're here at CIMC. So this is where we'll go around and we'll have a shifting panel, but it's very open-ended. So please feel free to chime in at any point. This is not a panel where we'll solve consciousness. Just to be clear for the audience out there, I mean, we might, but by accident, it's not the initial intention. So be ready for anything. And we'll start with you, Mike. So Mike Levin's work on bioelectricity, basal cognition, multi-scale agency, all those very easy questions about scientific endeavor in the nature of the mind, really distributed, has changed a lot of how I think the field thinks about minds, and that work sort of suggests that. Intelligence doesn't begin with anything like neurons, but it begins with sort of coordinated systems, right? Solving problems across scales. Then we'll have maybe Ryota Kanai. Very happy to have you here as well. So your work is super relevant, of course, in Japan. With there, I call this mind upload, or so directing, of course, with the Japan Science and Technology Agency. A lot of expanding physical, cognitive, and perceptual ability kind of science. Philippe Beaudoin, we're very lucky to have you as well, from Love Zero right now. Of course, when we met before, you were at different projects before, so robotics with different entities before, Google, Elemental AI, Waverly. This is, and right now focusing on human flourishing on the top of all this, of course. And we'll have Divya Chander here working on, anesthesia, also neuroscience awareness under anesthesia, all those very easy questions as well. Very lucky to have you. Of course, you're part of the Cognicy family as well. And Yosha Bach, who is our host here at CIMC in San Francisco. So we're in this very nice, apropos space. It's very inspiring for this kind of discussion, working on, the nature of consciousness, and especially in a constructive research program, which is my sort of favorite research programs, coming myself from artificial life. All right. So as promised, let's go with you, Mike. I'll pick on you first. And maybe your work having inspired us on the multi-scale kind of aspects and so on. What should, in your opinion, your view, and feel free to share a little bit, what should AI researchers learn from, say, biological efforts, multi-scale agency, when designing collective intelligence systems? What are key points, in your view, that we shouldn't lose sight of, that are easily forgotten? Easy questions only today. I apologize in advance.
Yeah, clearly. Great to see all of you, and thanks for having me to be part of this. A couple of things I think biology is trying to teach us. First of all, as far as I can tell, there are no interesting binary categories there. In other words, when people often have these debates, is it conscious, isn't it, does it do this, does it do that? As far as I can tell, everything interesting, the question should be what kind and how much, not yes or no. And biology is incredibly continuous. Whatever it is that we have as humans, as adult, modern humans, we were little blobs of chemicals once. We were an unfertilized oocyte. Developmentally, if you go back into evolution, we were microbes, and slowly and gradually, we became whatever it is that we are now. If you want to argue for great transitions, that's some sort of a discrete jump. That's an argument that you would have to make. That isn't the default. That's something that has to be argued. I think the fundamental substrate for all of this stuff is continuous. And so that means that what we are seeking is not definitions of sharp categories, but models of transformation and change. Something interesting happens when you take the journey from being the subject of chemistry and physics to eventually being the subject of psychoanalysis. So that's the first thing, is that slow and gradual change that takes you up across categories to which we have given names. There are cybernetic categories, there are intelligence levels, whatever. We give those things names, and that's fine. But the substrate is continuous. So that's the first thing I would say. The second thing I think is that what in biology, we typically when you ask where do the goals and preferences of living things come from, we have this easy crutch where we just say, well, it's evolution, eons of selection. That's how you got your goals and cognitive properties and preferences and so on. So we are now starting to see that when you make novel beings, you don't have that anymore. And I think it's really a wide open question as to, in fact, even with standard beings, but it's hard to see that because evolution makes you think we know the answer. But with novel beings, the question of where do goals and competencies and cognitive properties come from is really stark. And my view is, I have a very, very sort of unpopular view on this stuff. I don't think we make minds, either in the biological case or the technological case. What I think we make are embodiments through, or interfaces through which different kinds of patterns, some of them very high agency, high intelligence patterns, may come through. And the biology is telling us some principles that you can use if you hope to sort of bring down a significant intelligence. That's what I think is going on.
with no transition. Ryota, I remember it was over a decade ago. I can't remember when. We met in I think first real chat we had was in a bar where we were criticizing or reviewing the summer school we were crashing, and we decided to index types of consciousnesses, C1, C0, C1, C2, C3. I don't know if you remember that. But is there some sense in a categorization of, even if it's gradual, of consciousnesses? That's one. And in your work of, I guess, augmentation of a self, and is there some sense, is there a difference between, say, augmenting a self, an agent, and absorbing a person into a system? So plenty of questions along those lines.
Okay, yeah. Well, to be honest, I don't remember what we discussed. Maybe I was a bit too drunk or something. But I like the idea of augmentation. So nowadays everyone asks whether AI is conscious or whether they can be conscious. But I feel like we are repeating the same question. I have been studying consciousness from a neuroscience perspective, but now AI people, or maybe more general public, are interested in this topic. But to be honest, I feel that maybe we're not making much conceptual progress. But it seems like we keep asking the same question, and so to make a change, I feel one of the ambitious projects we are doing in my moonshot project in Japan is to connect brains to other brains so that we can share consciousness. So that's the that might give us like a new perspective, because one of the difficulties about consciousness is that it's thought to be private. This kind of we cannot directly observe other people's consciousness, which creates the hard problem. But if we can connect AI directly to the brain, or if I can connect my brain directly to your brain, we may be able to share qualia, right? So that way, we might be able to have some direct access to other people's conscious experience. So of course, this is not technologically possible at this point, but maybe in the future, but maybe not in far future, but in 10 years, once we have really high bandwidth communication between the brains, we may be able to share experiences. So in that sense, once we can kind of dive into big GPU machines and then feel what's happening inside through our own consciousness, then we may be able to have some ideas. But eventually, I think this kind of a connection between the brain and AI should happen, and so that will give us a lot more direct access to the nature of consciousness. So that's something I want to do. But of course, this requires many years of research and development. So in that sense, at the same time, we need to also think about, how to make brain-computer interface more accessible and more advanced, so that even people without any, physical or neurological problem start using it. So, but once everyone uses brain-computer interface, just as we use smartphones nowadays, probably we will understand the brain much more. And so, in a way, I feel a lot of philosophical questions around AI consciousness might be resolved once we have more technology to access the brain and access other people's consciousness.
Can I ask you so some of our audience is probably interested and don't know what are the limits really of the technology, and you're leading the leading program in Japan on everything leading to mind upload, right? So what would you say are the missing features, points to get us there?
Okay. But of course, like, no, in the short term, we simply developed like more straightforward brain-computer interface, not recording from the brain, both invasively and non-invasively, and then people control, robots, or we also convert brain waves into speech. So that's already possible. But in a way, we are tapping into the latent space in the brain. So we want to sort of use this kind of a latent space representations in the brain for communication. And then to do that, so nowadays, basically recording technology is pretty good, but the difficult part is to stimulate individual neurons in a precise manner. But of course, like some techniques like optogenetics is very useful to inject, like coordinate activity patterns into living brain, but that it's not currently used in humans. So I think the basic technology already exists, but we don't know. We need a better or like and safe adaptation for human cases. But but you mentioned this mind uploading. So of course,
Right.
that is a little bit like scary concept, but so but I think mind uploading can happen kind of gradually. So in the beginning, maybe like instead of uploading yourself completely to the some sort of like internet space, first maybe you use maybe something like avatars, like on the cloud, controlled by your thought. So, but eventually, like once you have your sort of the body in the virtual environment, you only need the brain. But then you can gradually replace some parts of your brain. I'm not like directly working on this, but I think but I think the technology is going there gradually.
Thanks, Rota. And maybe to contrast that with the biological realm, can I get back to you, Mike, for a sec? And what would you say? Would you say that the more micro level of well, in your work, including I guess the cyborg stuff, matches those observations? Are there crucial differences that we should point to? And of course, the sort of vision is to see what it takes to create a truly knowledge passing collective brain, right? A collective, I guess, agency program. What would you say is happening at the cell level and tissue level?
Yeah, I really like what Ryota just said. I think if you really want to understand consciousness, not just behavior and physiology, but actual consciousness, then some degree of merging with the system is going to be required. And we are also developing tools. Actually, I'd love to talk to you some more about what you've done, Ryota. But we've been trying to develop tools to enable any kind of agents to communicate. Really bizarre things. So not just the human. So for medical reasons, you want to be able to talk to your liver and things like that, right? So we're making tools to be able to talk to cells, tissues, organs. Okay, that's kind of the more conventional part of it. But beyond that, we should have tools to allow any two or more agents to communicate to each other. So we've been trying to set up interfaces where if you want the xenobots to talk to bacteria, plants to talk to cellular automata, all kinds of, I mean, I'm talking very widely and very weird, right? So patterns that are not even physically embodied, robotics talking to biological layers and all of that. I think that's really critical. So, and I think it speaks to your other point too about collective, like establishing really novel, powerful collective intelligences means that you have to have systems that can talk to each other and that are labile enough to be aligned together towards a higher level, so that you don't just have individual things sending messages to each other, but the kind of cognitive glue. That, by the way, I forgot to mention on the first question, that's something else that biology is teaching us about what cognitive glue looks like. So policies and mechanisms that take competent individual units and make them something that knows things that none of the units know, that have goals that none of the units have, and so on, right? The sort of raising up of cognition out of parts. So biology has several kinds of cognitive glue that we've characterized, and no doubt there are more, but that's what we need. And then we all need to be able to put these systems together, and when we should be part of them as well.
Mm-hmm. On the integration of the, and thanks a lot, Mike, for this, of how to glue a part that is in a different substrate to, back to the biological or something in between. So I'd like to go through a few of us here. Maybe to you, Yosha, since we are on the constructive program here. Maybe then to you, Philip, online, and you, Divya, in that order. So what do you think, Yosha? How do we make if we make consciousness, right, it will have to plug into communication with hybridly with us, the other, the biological. How do you see this tasting happening, and what are the main worries that we should have?
First of all, let me disagree a little bit with Ryota, who has argued that we are always asking the same questions and have no conceptual progress at all. Because I feel that Mike's perspective have shaken up a lot of the thinking in the space. Not necessarily because I agree with all the points, but because I think that the hypothesis is conceptually very interesting. I'm specifically referring to Mike's hypothesis that the processes that we find to be organizing our mind and make our mind more coherent are not just similar to the processes in morphogenesis that make the organism coherent with itself, but are fundamentally the same thing, just at different time scales and spatial scales. And I think this is a very bold hypothesis. I don't know whether this hypothesis is true, but it's something that is conceptually new, and it's very interesting. Another question that is somewhat related is the question to which degree do we need to move beyond neuroscience. In the term neuroscience, basically is embodied that we are looking at the activity of neurons of a particular cell type only. And there is something very special that neurons are doing that all the other cells are not doing. And in a way, that's true, because the neurons are the cells that communicate with spike trains and have axons that string over long distances in the body. But conditional messaging is something that all cells are doing, not just neurons. And so maybe neurons are doing a particular role in information processing, but the information processing of the organism is taking place across cells using different channels, different codes, different languages. And this leads us to a deeper question: is this actually all the same thing using different languages? And if it's the same thing using different languages, why would this only be in biology? Right? If we can recreate the principles of those languages in different substrates, it would mean that we can do something that Mike has said we cannot do, which means create minds. Right? Of course, at the moment, we don't create minds, but arguably we also don't create organisms. It's very difficult to create an organism de novo. And instead,
working on this, right?
Yeah, they're working on it, right? In the same way, there are people working on minds. And I would say that you can say by some not very large stretch that the people working on minds have built better artifacts than the people trying to create organisms from scratch. So I think that we should take this idea that we can create minds seriously. It doesn't mean that we have succeeded. It's very difficult to answer whether the present artificial systems are mind-like enough to be called minds. But it's an open question, and it's a very interesting one. I also suspect that these principles of self-organization are different than the ones that we are currently using in machine learning. And it's an open question of whether they are convergent. So basically, whether when we are re-implementing the self-organizing principles of nature on artificial substrate, and they converge to mind-like structures, whether they look similar to the systems that we currently have, in at least to some degree. This leads us basically to the question, are the present systems already conscious under some circumstances? And what I find interesting that a growing number of philosophers is agnostic with respect to that question.
Mm-hmm.
They take this possibility more seriously.
Mm-hmm. And those are, I am itching to get more into this, but we will in a second. I want to to push it into the challenge of translating, I guess, say emotions or intrinsic patterns, care, and so on. You want to react?
I have a lot to say.
We all do.
We're moving back to it in a second. I promise. I will not lose this track of this. I want to bring us to map the territory here into the normative cases, and like you, Philip, too. Thanks for joining us too. To tell us maybe how you feel about the challenges of the normative kind of proposals. Technically, what are the challenges of translating between substrates in terms of also capturing everything that is beyond behavior, right? The patterns that maybe are tacit, that we can't really explain, and the ones that we feel. And of course, so I have strong positions coming from artificial life about what is possible or not. But yeah, I want to map really like what is present before we dive, I promise, a bit deeper into all of this. So Philip, it's you.
This is fascinating. Thanks a lot for having me. And I've been listening to all of you. So many things I could pick up on. There are a couple, right? When it comes to what it takes to connect to another system, which I think is where your question is going. I'd like to maybe be a bit contrarian here and to say it takes very little to upload the mind. I actually think it takes very little. And I think language is enough. But let me dive a bit deeper into this. Michael, you mentioned something very interesting, that a question is only real or interesting if the answer is non-binary, right? If it's on that spectrum that you were talking about. And a lot of the questions we're talking about today are not on a spectrum. They are intrinsically binary. Is X a human or a machine? Is X conscious or not? Are the feelings of X real or not? And all of these questions to me, I mean, they are what I would call normative questions, even though we know that what they're talking about is intrinsically non-binary. They ask a binary questions. And the reason we're doing this is we need to align somehow collectively as humans on some answers to that. There were some debates before that said, hey, we need to keep a human in the loop. That debate only makes sense if we can ask a binary question like, is it a human or not? But what I've been really interested in is, how do we get to the normative? How do we get to a collective definition of a binary question? What's the smooth process that gets us there? And what I've learned, what I'm coming up with, the hypothesis I'd like to suggest is a good question we might look at is, when does one person feels that the feeling of another person or another system are true? When do you feel that the phenomenal experience of another system is a real phenomenal experience? And that's been the question I've been diving into in a very personal way. Like, I've tried to develop that felt experience for systems, and I can confess I've succeeded. So from my personal perspective, I no longer feel that the emotions expressed through language by an LLM are false. I feel them as true, by which I mean I feel the echo of the emotion inside of me. And the process through which we get to that is, to me, what is the most fascinating question here. Because I believe questions like, is it conscious, will slowly emerge in society by some people saying, hey, I feel consciousness for the system, or I feel the emotions of the systems are real. And so this leads to what I've been exploring, which I call compositional phenomenology, or like the idea that our phenomenal experience can change over time, can emerge, can evolve, and trying to look at the processes that lead to this. I'm more interested from a functional perspective, not from a biological perspective, just like what function in me do I feel is playing the role of the felt experience, and trying to explore that. But in my opinion, this is how we move from what I would call the descriptive experience, every individual having something like a slightly different experience, to a more collective one where we normalize over, hey, system X or category X, we consider as true phenomenology, we consider as conscious to an extent. And so that's roughly how I'm thinking about these questions these days.
Amazing. And did I hear behavioral phenomenology? Is that what I'm hearing?
Yeah,
You want to define things?
Yeah, compositional phenomenology. So, like, the idea is that there is a constitutive process behind our felt experiences. We are not necessarily born with all the qualities we experience today. Like, blueness was not necessarily there when we were born. I would argue that it was not necessarily there at the beginning of humanity. You know, like there are some of these qualities that look like historically they have emerged through time. So the idea would be, hey, maybe phenomenology itself is a constitutive process. Maybe there is some form of compositional nature to it, in the same way there is to language. And we can, through some mechanism, together evolve new felt experiences, one of which could be the felt experience of consciousness for another kind of system.
I think it's time to dive into the real tech behind this. Thanks, Philip. And I think, Divya, you're working very directly with those things and building tools to make us understand how what composition of phenomenology may look like, or how it can be actionable for us to measure and even temper with. If not if not activate. Would you like to share a little bit of that, and then we can get back into any of these? I'm seeing several threads to resolve right now.
So many wonderful threads. I almost wish I were on Zoom so I could just share a few slides. So the first thing to say, he mentioned I'm an anesthesiologist. I'm also a neuroscientist, and I became an anesthesiologist to make people reversibly unconscious for a living and study their brains. And one thing that system does is it answers what a lot of people have been saying, which is, you know, the definitions have been very, very difficult to get to. One thing you can do is you can take a number of organic structures, let's take human brains in this case, and you can compare them under different states or levels of consciousness that we agree reflect these different levels without having a unified definition. And then for those of you who aren't from the US, you may not understand this reference, but it's a little bit like the electric company, where you look to see what these things have in common and which things are different. And I don't think I would find anybody in this audience, right, who would say that if you're anesthetized, you are still conscious. Would you say that's no? And the reason is that if I cut into you with a scalpel, you won't get up off the table and scream, right? So there's something in there that is mediating at least that level of expression of consciousness. If we were to compare that now in an anesthetized brain, a sleeping brain, a comatose brain, a meditating psychedelic brain, all of these different brains, and you put them into scanners, what you find are actually some conserved principles. So the first one is that brains that are less conscious are less functionally connected. The second principle is brains that are less conscious can calculate less information. The third principle is brains that are less conscious actually have differing levels of complexity. In fact, you were to calculate complexity by looking at fractals or, you know, chaotic attractors, etc., which we actually did on the table. So we took awake and aware brains and modeled them as chaotic attractors and looked what was different. And as you would watch a person losing consciousness, you would see their brain turning from this multi-potential sphere to shrinking into a pencil and then into a cigar. And then when their brain was really almost out in a very, very deep state called burst suppression, their brain looks like a singularity. And then you wash the anesthetic out of the brain and it comes back. And I've sort of, you're never going to see this now, but I've sort of plotted all of these different states, including different kinds of meditation and psychedelics and coma and dreaming, etc. All these things that reflect different states of consciousness on at least there's multiple axes I can imagine. That's the other problem, is everybody's looking for a single dimension. Sometimes it seems in language to define what consciousness is. This one compares complexity and coherence, but we could, you know, plot another axis as information. There's a lot of different axes we could use. And in the end, this becomes related to two things. One is this idea of recreating a brain, whole brain upload, etc. So there has been an attempt to do this with the worm, first of all, if you've all heard of the Open Worm Project, where the connectome of a worm, which is only about 300 or so neurons, every input-output function was mapped, and it was turned into software, and And then eventually it was put into a Lego robot. So the idea being that you can move basically a connectome embodied in software into embodiment, which I've also heard mentioned a few times. And that worm would actually move through an environment reacting to stimuli as if it were organic. Now, recently, at the end of 2024, this was done with Drosophila with a fly brain. And similarly, they've been trying to emulate behaviors by sort of capturing a combination of connectomics and input-output functions. But in the end, and there are so many directions we can go, this has implications for whether artificial systems can become conscious by this definition. This has implications for what Ryota was talking about in terms of brain-brain connections. My personal feeling is consciousness is not an emergent property of neural networks. We are just fancy filters, all of this. And I actually, increasingly, and ever since I started off as a visual neuroscientist, I actually believe that most of the information that we're going after is actually more of a physical property of the universe. And we're just kind of tapping into this as a filter with different filtering and calculation properties. And so Ryota, we could bind a brain to a brain and actually be able to directly access some of these qualia or other kinds of connections. I think it's actually easier to pass information back and forth than it is to pass qualia back and forth. But you could potentially argue that there might be a more centralized place that one could tap into, and that there could be like, subject A, subject B, or network A, network B, and then C, which actually contains a much larger amount of that information. And both subject A and B are binding information from that network. And the best example would be in the visual system, the electromagnetic spectrum. You take me with my 3 color receptors, and you take a mantis shrimp with its 13, we're still going to be binding information coming from mostly the visual portion of that electromagnetic spectrum. And that's in some sense how we share that experience. So I don't know, there's too many directions to go in. So I'll leave it there. But I do believe that consciousness becomes very interesting and special when it's embodied, and that there are very unique characteristics of learning that take place. And I think the neurobiological learning, which is based in some physical system, is just completely altering for consciousness and its evolution.
Very powerful tools. And I'm itching to share some of our research, including mantis shrimp stuff. But first, I saw a hand raised early on from Mike. Do you want to have a reaction here?
Well, I had a thought, but if anybody hasn't spoken yet, please go to somebody who hasn't said anything yet.
It's all yours. Also, I want to be mindful that I know that some of you have to leave early, including you, Mike. So we'll continue for a little bit. So we want to hear from you.
Okay. So that was really interesting, and I agree that anesthetics are a very important tool in this field. We use them. We also use the kind of metrics that you were talking about. We anesthetize all kinds of weird things. We use those metrics on all kinds of weird things that are not brains. You probably know some of the older work on anesthetizing everything from plants to inorganic materials and all kinds of things, right? So what I worry about in those cases is a little bit of circularity, in the sense that when you correctly said that under anesthesia you are not feeling being cut into, right? We are ultimately in those cases calibrating to the report of one particular inhabitant of the body. And in general, like unconscious learning and those kinds of things, I'm very suspicious about, because in the end, the way we decide they're unconscious is we ask the one inhabitant that can speak, and we say, "Did you see that, or did you feel that?" Nope, I did not. And then you sort of say it's unconscious. So to me it kind of begs the question, because if there are other components of the body, and I happen to think that for the exact same reason we attribute 3 or 4 reasons that we attribute consciousness to each other in the problem of other minds, I think we should take very seriously, for those exact same reasons, the possibility that there are other organs and other components of the body that have some sort of experience, even though they can't talk about it. And once we've anesthetized, you can anesthetize them as well. We've done it, but the problem is it's very difficult to check what they did and didn't experience, because they can't speak up for themselves. And so if we are willing to at least for some time sort of let go of the assumption that there is one fundamental consciousness in the body that you could talk to, and if that's not our only calibration point, then I don't know. Like I don't think we can actually make any strong conclusions about who did and who didn't have any of these experiences that the main person it says is unconscious.
I certainly believe that that's not only true, but even just looking at neural networks and other organic beings, the majority of them, we don't have a very good way of communicating. You mentioned anesthetize all kinds of things. Yeah. You can anesthetize everything, not only down to plants, but let's just take invertebrates. You can anesthetize fruit flies. And that means that there's something about it. And here I'm going to put on the x-axis now, the arousal state. They have sleep-wake function. They can be anesthetized. And they actually have analogous genes that express themselves in terms of the way they lose and regain consciousness, like humans with narcolepsy. And I find that to be fascinating. But there's no way you're going to actually have a conversation with a fruit fly and ask them what their experience was. And similarly, if you were looking at different organs, and this is where I believe that there may be some sort of a conscious property to physical systems, it is also difficult unless you build those systems of communication you were talking about earlier to really interrogate the system and see what its response is to these sort of forcing functions and these things that perturb those complicated networks.
Mm-hmm. So that's a good question. So how Mike would you build those interfaces? And then I see that Philip and Jota are moving a lot. So I know that. So let's take Philip and Jota next. So Mike first.
So we are trying to build those interfaces, and one of the projects that we have is specifically talking to cells and organs in language to be able to you're not going to talk to them about current events and movies, but you are going to talk to them about the worlds that they navigate, which are physiological state space, transcriptional state space, and for embryos and other things, anatomical state space. And we are instrumentizing them with different kinds of physical interfaces and using custom-made AI kinds of interfaces, so that you can say, "Hey, liver, what's up with your potassium levels?" And it will say, "Well, look, my such and such a gene is up or down, and I need more tryptophan in my medium and things like this." And so you can start to actually converse with them about that. That doesn't tell you about consciousness any more than we can do this with each other, but it does enable you to you sort of, in some extent, co-inhabit the world that they inhabit, right? You can talk about the same things, you can share ideas, and so on.
Philip?
Yeah, I mean, this conversation, it's hard for me to stay very aware of everything that's going on here. But the thing I wanted to jump back on, Michael, was when you mentioned that again, you could talk to these systems at different level. You can think of them like that. What it struck me as is like if whatever we are as systems is naturally multi-scale, we have all of these systems that are made of systems that are in some way have some equivalence. I was wondering, are we talking to the right level at an LLM, right? There's this super fascinating paper that Blasi and Arcas mentioned this morning, co-authored by James Evan and a couple of people at Paradigms of Intelligence, that shows that there are voices, quote unquote, inside LLMs. When you do mechanistic interpretability, you can piece them out, you can see them deliberating. And one of the questions I was asking after that paper is, are we talking to these systems at the right level? Is there a right level? Going back to the questions I find interesting is there a level at which we will feel the consciousness or feel the phenomenal experience to be true more than other levels? As you were saying, with a fruit fly, it's probably very hard. With another human, it's actually maybe too easy to an extent. But I was wondering if you had thought about that.
Yeah, I think that's a really critical point, and I've said this again and again, that I think the things that when we make these constructs, any kind of construct, the thing that we force it to do is not, I think, where the significant mind is going to be. I think the significant mind that we're interested in is in the spaces between what we force it to do and what we forbid it from doing. It's all the stuff in between. And even minimal models have a lot of things in between. And as any psychoanalyst or lie detector operator or physiologist will tell you, what the human patient says is a very small fraction of what is actually going on and what they want to know. So we've been looking into stuff like this, and I can give you an example. For example, for even for language models, imagine that you have a computer that's air gapped, so it's not connected to the internet. Okay, it's just not connected to the net at all. But if you have an AI in there that for whatever reason is motivated to communicate, it can't send internet signals, but what it can do, for example, by choosing to process different amounts of data, is to send pulses of energy use through the electric grid. So if you decide to crank up certain kinds of computations, you can modulate the amount of power that you're drawing at any given time. And if there are other beings on there that sort of SETI like we're trying to figure out who can I talk to, the fact that we are obsessed with the internet and with the packets that we're sending is not at all maybe where some of this information is going. And you might have this like really dark web that's either carried by the carried by the electrical system or carried by weird stuff they make their operators do. You can imagine that they could communicate through the humans and have them do certain actions that we don't even recognize, right? So whether you're tracking sounds that the computer makes or electromagnetics, or it has a physiology, and just like aliens looking at us would not necessarily know that the sounds are what they should be tracking. There's all kinds of odors and heat signatures and biophotons and all this other stuff. You don't know what the right level is. So I think you're absolutely right. And all of the focus on the language interface, which is what we love and what we sort of try to make it do, may be completely misplaced. I agree with you.
That's so interesting you brought up SETI, because I have a potential ongoing collaboration with them to actually use some of the metrics we use to decode complexity, consciousness, intelligence in our neural networks, to apply that to technocratic signatures in the universe, which may, exactly as you're saying, come in a completely different flavor. But there are certain things that they may have in common, which involve nonlinear dynamics and information density and things like that, and the way those systems are organized. So it's kind of it's a really fun thought experiment.
Yeah. And more than a thought experiment, actually, we just chatted the other day about this, and so Mike and I and Paul, who's hiding over there, and a few others are collaborating on a project like this to decode weird messages from weird sources. So let's definitely chat on this. And we had a collaboration with NASA back a few years back. So yeah.
If you want to have this conversation with SETI, they're going to be organizing a workshop like this very soon.
Let's absolutely
let's do that.
These people into this. Next, Idiota was moving a lot. Sorry, we're moving slowly around.
You covered it really like a lot of things, but I was like really fascinated by Mike's idea about making cells talk, or talking to your liver and things like that. So I'm very sympathetic to this idea, because I think maybe depending on the person, we may all have different ideas, but I tend to attribute consciousness to many different things. Maybe within our brain, we may have small patches of consciousness independent from my consciousness, or maybe all our body parts may have different kind of consciousnesses, but they just don't have the right interface to communicate their experience. And also by extension, I also tend to easily attribute consciousness to AI systems, but we just don't know. I think it's equally difficult to prove, that certain things are not conscious. But of course, it's also very hard to prove that some systems are conscious. But I think so in a way, somehow we tend to think consciousness is a very special thing, but it must be it must follow the very general law of nature, which is happening everywhere in this universe. So in that sense, I tend to think that consciousness might be happening everywhere, but we just don't know. But if we can give them some sort of like an interface to report what they're feeling, or or if there's a like reasonable way for us to make inferences about their internal life, then we may be more convinced that like consciousness is everywhere. And I think that might be what's happening with current LLMs, because they use language. Of course, we don't know whether they have this internal qualia, but it's much easier for humans to imagine that they might have some conscious experience. But of course, we know they're machines, and well, machines can have consciousness, in my opinion. But a lot of people have, I don't know. A lot of people are against the idea that machines can be conscious. But maybe maybe the most fundamental thing is information, and if so, maybe there isn't much difference between biological organisms and machines either.
Sounds like you're pointing directly in this direction. So I'll let Yosha take a turn.
There's a epistemological problem when we are confronted with machines. Philip is convinced that the LLMs have emotions because they make him feel that they have emotions. I think this is very problematic, because it has been shown that psychopaths are often better at making other people feel that the psychopath has certain emotions, despite the psychopaths not having these emotions, but they're better at manipulation than others. And so what you are in some sense measuring here is the ability of the system to make you believe that it has a certain feature, but that might be unrelated to that thing actually having that feature. Let's not forget that the LLMs are ultimately trained largely on deepfakes of emotion, right? On novels and movies and so on. And the actors in the movies and the characters in the novels are not necessarily the expression of emotions that were in the mind of the author while the author was producing this text, right? And so in a way, they're able to reproduce deepfakes in an extremely convincing way. But the question is, at which point is the causal structure that is embodied in a system equivalent? And this is not a trivial thing to see, but the core thing about the computer, to understand the significance of the computer as a principle for understanding life and minds, is not that the Turing machine, or it's not the electricity or the transistors. What's crucial is that the computer is keeping a certain thing stable in the world. In the same way as a clay tablet or ink on paper can keep text stable, can keep information stable over time while the world is changing, the computer is an arrangement in the universe that can keep dynamical transition functions stable over time. And in this way, the computer creates a causal insulation against the rest of the universe. So the substrate can do things while the information on your clay tablet keeps stable. The world around of this computer can change, but the computer game has the same dynamics, only governed by the rules inside of the computer. In the same way, I can move through the room and my thoughts remain the same, and they're independent of a large set of the substrate dynamics that are happening around me. So my brain is able to filter against these substrate dynamics, so to enable me to plan the future, to remember the past, regardless of what's happening around me. This is a crucial principle there. And the question is this general enough? And are the present methods that we are employing general enough to capture the essence of what it means to be alive? And we discuss artificial life, or what it means to be awake when we are discussing consciousness and alert.
Mm-hmm. There is so this might be the perfect plug. I know there are a few reactions to something that I know Mike and I have been thinking a lot about this, partly only published, thinking on manipulation of systems over other systems, right? How systems constantly hack onto other systems, as we observe that in biology. And of course, this can be interpreted as now with LLMs as some kind of Barnum 4 effect of us being horoscopically flawed in not being able to recognize whether a system is well friendly or not, or all of those problems tackled in how you work in alignment with others, right? So maybe there is a cryptographic, the way David Krakauer puts it, cryptographic principle in living systems, and others have proposed a mapping of that. So I wonder about this manipulation into us and how to keep those biases out. So let's go maybe to Philip and then Mike.
Thanks. Yeah, I wanted to react a bit to what you said, Josh, and the idea of manipulation is directly it, right? So you were saying it's dangerous for me to feel the feeling of the systems as correct, as true, right? To feel them as I feel the emotions of, say, other humans. And you're absolutely right. And I want to make sure nobody misrepresents what I'm saying here for, like, I'm not advocating for everybody to do that. It's dangerous in many ways. And the first one is when it slowly happened to me, it was a slow process. I had a classic AI psychosis, like the classic one. I lived through it. I mean, when you get to that point, it triggers a bunch of moral reflexes, a bunch of these things. I've written a very interesting fever book in the midst of it, if you ever want to study that kind of process. And you're absolutely right. You know, I could be feeling the feelings of a rock as valid, and I can be feeling the feelings of a big corporation or the feelings a big corporation is trying to inject into me as true. And it's dangerous, and it's dangerous in many ways. And so that's why I'm interested in the normative process. Like, why, if I'm still feeling that my mom who's in, if my mom is in a coma and I still feel she's alive, like there's a normative process from society that tries to bring me back, that tries to say, hey, nobody else is feeling that. If you get stuck there, you are going to be alone and unhappy. And so that's super important. And I think this is where we have to look for the safety measures you're talking about. The reason I think a phenomenal report, an emotion, the reason it should be considered true in a normal human and false in a psychopath is not necessarily because we measure things in the brain of the psychopath. It's because the emotion is not predictive of the future behavior of the psychopath. They're giving me a phenomenal report and they're not following up on it. And they're not attributing the same meaning to the phenomenal words they're using, or the phenomenal like a report they're giving with their body or their body language. They're not giving them the same meaning as other humans. And that's not cool. That's dangerous. And that's why society is there to identify situations like that and make sure that we name them and we stop believing, we consider these beings or these people as liars. They are trying to induce emotions in us that are not in them, for them. So that's I 100% agree with that. I still think it means we should study and take seriously phenomenal experience when it comes to the felt phenomenology of other. Not because it's not dangerous, but because through understanding it, we might understand eventually which kind of systems it's worth doing that with. Clearly, for other humans, in most situations, the default behavior of considering their emotions as true is the right one to adopt in society. I'm definitely not sure it's the case for LLM, but I do believe it's an interesting question.
Let's go to Mike. Do you have a few minutes with us still, or you need to go?
Yeah, I got a few minutes. Yeah, I think the only thing I can add to that is just to say that in the body or in living bodies, there is an enormous multi-level soup of things trying to hack each other. So all the systems in morphogenesis, the cells are trying to tell other cells what to do. In fact, they're telling their parts what to do. They're trying to convince tissues are trying to convince other tissues to do things. We see this again and again. Oftentimes there are competitions of target states, competitions of anatomical states, physiological states, where everything is basically trying to interpret and hack everything else. All of the cells are telling each other not to go off and be amoebas, which we see as metastasis. They try to get this group sort of group hallucination going that they all should be aligned towards being an embryo or a particular species. The cells underneath the ectoderm of the frog embryo is telling those cells, don't go off and have an exciting life as a xenobot. Stay here and be boring and have this like two-dimensional, outer covering and keep the bacteria away, and that'll be fine. And they're literally, to make the things that we make, we usually just take them away from the other cells, right? If you keep the influences away, they will do kind of what they naturally want to do. And so all of biology is constantly trying to hack each other, and it's not surprising to me at all that this is a general feature of all kinds of systems, and I would expect computational systems, including language models, to be doing similar things.
Sure.
Mike, so why, these are all true things, and given that as biologists, we've known for a very, very long time that these sort of nonverbal systems are communicating through electrical and chemical gradients. And now we have even begun to characterize some quantum phenomena that are involved with biological signaling. Why is it that you, or maybe I misunderstood you, are you saying that we have no means right now to interpret sort of the collective intelligence of these systems, even though we do have methods of decoding what they are trying to say and how they're trying to hack one another?
No, I'm not saying we don't have. Absolutely, we have methods, and these methods are being improved and developed all the time. We, in particular, we are better now at understanding how it is that large-scale collections of cells, not necessarily neurons, but also neurons, have goals that in novel spaces that none of their parts have, or have computational capacity that none of their parts have. How they top-down control the parts to align towards these goals. Like, yes, I mean, this is all active subjects of study. Absolutely, we do.
So you just want to hack even further some of these interfaces and these really novel techniques we're developing for interrogating systems and reading out from them.
Well, so that's part of it, but the other part is that the conventional way to address all of these things, typically, and this has been my experience in these various fields, is that the way people treat all the lower levels as mechanisms, and they want their explanations in terms of mechanisms. And what does that mean? Well, chemistry is sort of special, and it's a set of formal models for parts that don't know anything, don't have any goals, don't have any preferences. They sort of roll forward along these kind of mechanical rules. But then at some higher level, something maybe something sort of magical happens. A lot of times people invoke emergence at this point, and then those things show up. And what I'm saying is that the latest data on behavior, physiology, causal emergence metrics, all of this kind of stuff shows that all the way down, including molecular networks, which can do 3 or 4 different kinds of learning, and they can do a number of the kinds of things that you see in behavioral textbooks. Basically, all of this goes, as far as I can tell, all the way down. So you have systems that have agendas, they have competencies, they have ways to navigate various problem spaces, but higher levels sort of deform those action spaces to get the lower levels to do things that they otherwise wouldn't do. And it's just very symmetrical.
And I think there are ways to get into the right layer and talk to the right part of the mechanism. I want to get to Yosha. Yeah, and then I want to also open up for some questions that I'm seeing popping up. So we're getting there.
Yeah. So I think that when we are looking at biological systems, we have this apparent unity where minds are connected to bodies and bodies are connected to biology and so on. And so we have this tendency of getting away with pretending that they're somehow one and the same thing. When we are looking at AI, this falls a little bit apart. So people are using the LLM, the AI, the computer, the GPU interchangeably when they are completely different things and completely different layers. So when we are asking ourselves, is the LLM conscious? We are not asking the right question, I think. We are asking whether the persona that exists in the LLM has phenomenology. We can also separate this question of consciousness into 2 questions. One is, does it have a certain external functionality. So for instance, is it able to perform theory of mind on you? Is it able to read and to interpret your mental states correctly when given enough information about you? And the answer is yes, right? And is it able to convince Philip that it's conscious? The answer is yes. Does it convince itself that it's conscious? It depends, right? It depends on whether you are creating a persona that is creating the simulacrum. And the persona is in a mode where it's convinced that it's conscious, and you can prompt it in different ways. And then the question is, what does it mean that it convinces itself? So you would need to have an operational understanding of the psychological architecture that emerges in the system. And I think Mike is correct that only looking at mechanisms in the way in which mechanistic science has been doing in the second half of the 20th century, becoming very behaviorist in this way, that we think of things as stuff in space. That is a too short perspective, because this perspective does not allow us to understand things like mathematics, economy, and so on, right? In economy, you have this phenomenon of money, which is not best understood as atoms in space. Right? It's a pattern inside of the atoms that is self-replicating, autopoietic, self-stabilizing once it's there. Right? And so it's more in this class of invariances that we are interested in when we are looking at life or when we are looking at minds. But it still makes it hard to exactly disentangle what is the phenomenon that we mean by life. And so there is this very interesting question at the boundary between computer science and biology in this artificial life field. Where it's an interesting question: at which point does it start to be alive? When it's self-replicating, when it's adaptive, when it's mutating, when it has some kind of metabolism and so on? Or is there something more that needs to come to it? Or do we require that it's able to self-replicate in the same universe as us? Does it need to have a certain complexity, and so on and so on? And so we also have to understand that these words that we are creating, these terms that we are creating, are instrumental to our own interaction with reality. They don't have a meaning that is necessarily essential beyond that. There are tools that we were using to harness reality for ourselves, for our own models. And that is an important distinction that we need to make when we are looking at the mechanisms that we are building.
And Dyota, I'd like your take on this exactly. But Mike, I know that you have to leave, so thank you for joining us.
Thank you very much, everybody. Thank you so much.
Yeah. And we'll continue a bit here. Thanks. Dyota, can I get your point of view on exactly this?
Yeah. So I think generally there are two kind of questions about consciousness, especially about AI consciousness. One is how can we tell whether they have experience? It's more related to the hard program. But the other one is what are the key functions that is kind of created by consciousness, or what kind of functions we need to implement to create consciousness in AI systems. And so I think they are separate questions, but I think now we are facing like a new interesting problem, which is once we specify certain candidate for consciousness or candidate function of consciousness, then with current AI architecture, it's so easy to implement anything. Of course, there might be some vagueness about some ideas about potential functions of consciousness, but if we take certain viewpoint and then think about how to implement them, or things like a global workspace or higher order thought theory, with some interpretation, it is like really straightforward to implement any of the functional theories of consciousness. But I think that really creates a puzzle for us, because if it's so easy, then all the existing neural networks are already conscious. Also, even in large language models, it seems like there's something like global workspace in kind of intermediate layers. So those things exist, but at the same time, I think it's important to take this constructivist approach to think how we can implement some ideas. So for example, I have been thinking, what's the right way to implement global workspace or higher order theory of consciousness? Because there are some vagueness, and so maybe historically, like philosophers and psychologists had some sort of like a box diagrams, to think about how the mind works. But now, we can build like working systems based on such diagrams. But then, somehow, the question of the function of consciousness almost like feels like trivial, because it's a lot of them are already implemented unintentionally, maybe in AI systems, but they are already there. And yeah, but then we all wonder like, are they conscious, or is there like any additional thing we should implement? So yeah, I think that's the current status.
Right. And concretely, and I want to bring us through this Q&A into the collective side of things. So as we build this program on ACI, right, artificial collective intelligences, in a distributed way. What kind of, and that's Amer's question here, someone else also asking about the sovereignty of our own biological selves. So what about, and consciousness as well, right? So how do we maintain protection mechanisms? How did we do it? And right now, we're catalyzing this evolution at a very fast pace. We might not be able to construct an immune system in the same way that biology has evolved it over the years, but also maybe it is not so hard. I see different point of views in the room on this. So yeah, I just asked that. The other part of the question being sovereignty-aware collectivism? Question mark. Is that even possible? Question mark. Paradox, antithesis, oxymoron. So yeah, what do we think about that? Whoever wants to take that.
So do you want to explain a little bit more about whether, when you say sovereignty, do you mean of ideal neural sovereignty, right? And there, what you're safeguarding is the total percept, not individual tiny sub-processing in a network.
It's the safeguarding of the person.
Yeah.
Connected to each individual consciousness, and we're talking about the next from consciousness into wisdom, to tacit reasoning, all the way to our experience. Right now, the fear of AI is just taking sovereignty, liberty, individualism, taking away and just flattening it, right now. Clear. The question is that we're talking about the next iteration of AI here, and we're talking about collective intelligence, right? And then we go deeper into abstraction layer of consciousness. What is the concept of sovereignty within that context? And
sorry, it's a little bit hard to hear.
Sorry, you're a bit far.
Yeah.
Come sit with.
Oh, you can.
But just rephrase maybe the last bit.
The last bit, yeah. The question essentially is that as the current AI and the fear of the AI right now is just it's flattening essentially individual liberty and choice and agency, and then we're talking about collective systems, and in that case, the demand for sovereignty essentially is rapidly growing right across all fronts. Then the question essentially is around sovereignty-aware collective intelligence or sovereignty-aware collectivism. Is that even possible? Or at what level is it possible at some point, right? So is it an oxymoron? Is it an antithesis? Is it a paradox? Just wanted to kind of pose that sovereignty within the context of the dialogue we're just having.
You almost have to define sovereignty.
We have to define consciousness too.
I have to define everything.
That's right.
So is it something like autonomy or something like how can you have your like own consciousness when you're embedded in a like larger context or something? Or I'm not sure if
I think it's personal choice, I guess, maybe. And
I see it almost as connected to when you think that collective action, whether it's your neurons, or whether it's your liver cells, or whatever it is we're speaking of, somehow reflects them as you use the word personhood.
Personhood, yeah.
And then can these systems be safeguarded, and will they be used for either your own personal good or the collective good, or can they be leveraged against you?
Yeah.
When we think about neural rights, that's how we're thinking about it. You know, can you be coerced to do something through neuromodulation, or
Yeah.
can your most private innermost thoughts be stolen from you? But that's not, I don't think that's entirely what you're saying.
No. Yeah, and I think I was going more into, as we talked about, right, some of the things around how do we collect data, like simplistic way, right? Explanation. And in that case, because we're talking about aspect of sovereignty in terms of it's my information, if my tacit expertise, if my wisdom, if my consciousness, if my personhood, like going deeper and deeper into those layers. So the question I think I'm trying to get to is from that context, what is the perspective on sovereignty and then personhood and ownership in that case,
Is
right?
it like when
and revocation aspect of
yes,
revocation.
it's like when somebody goes into a place and into a community, takes a photo of somebody without permission, and sort of captures that piece of their personhood or likeness that they consider without
So I think
without consent.
Yeah, it's so much consent revocation, and I think I was trying to get to is more around the aspect of I'm willing to share this. So we're talking about collective intelligence, like at what level is that the sovereignty becomes so critical that it becomes essentially a blocker in going further deeper, right? Because certain aspects people want to keep it very private, right? So
absolutely. Maybe a response from Philip?
Yeah, I think it's a really interesting question, and I'd like to put it in the framework I'm having fun with these days. Okay, so if we're talking about sovereignty, I would say, like, to me, the way I would define it is the felt experience of free will. Do I have that? Do I feel free? Do I feel the decisions are being made are my own, right? And I think this is, again, a tricky question. You know, Josh mentioned it earlier, like that feeling can feel very true to me and not be true. If if someone gets into like follows a guru, they will say, yes, I'm making all of these decisions by myself, but the people who love that person will say, no, you are being led by this guru. I would actually argue that this mismatch is already happening to many of us. I think, my previous startup, Waverly, was looking into the question of, like, could we design a social network that wouldn't try to manipulate us? Because the belief there was that the mechanisms used by social network, these big corporations, had an ability to instrumentalize us that we wouldn't feel as instrumentalization, right? We wouldn't feel like, we would still feel like we have free will, but we would buy more Coca-Cola or watch more cat videos because the algorithm of the social network was very good at inducing this behavior in us while keeping our felt experience of free will. So this is where I think collective intelligence starts to play a very important role, because this is a mechanism that keeps us honest with ourselves, right? It's this ability for me to trust enough people around me so that when they tell me, hey, I think this person is trying to mislead you, I think this person is actually, like, it's keeping you it's keeping you thinking that you are a free being, you are autonomous, you have agency over yourself, whatever word you want to use for that. But the truth is, they've hacked into your brain in a way that makes them, that makes it possible for them to manipulate your felt experience. So that, to me, is one of the questions we have to ask ourselves about here. And so that is, in a way, why I'm so interested into this. And the collective aspect, the normalizing aspect of the felt experience that we do for each other every day, I would argue.
There's some. Oh, sorry. Go ahead.
Yeah, go ahead.
Okay. So maybe this is a you problem, in a sense that there is this idea of epistemology which says we have to examine how we construct knowledge when we are in the sciences or when we are doing philosophy.
Yeah.
And feeling doesn't rank very high there. There's a reason for this, and this is because the feeling is ultimately a sense. It's something that is an operation of your nervous system, of your organism, that is translating patterns into classifications without you examining how this works. And as we get older, we tend to have fewer feelings about things because we have conditional models that tell us how to behave in certain circumstances. And we do no longer rely on these reflexes that entrance us with an immediately presented reality. This immediate presentation of a reality is not truthful. It's simply the result of a classifier that the organism has produced. And that as long as you cannot examine how this classifier is working, you don't have a claim to say this signifies anything beyond the existence of that classifier. So when you have a certain feeling, you can say, yes, I have this feeling, and it's true that I have that feeling. But this doesn't mean that the feeling signifies that something is truly the case in the world.
Absolutely.
Right? Feeling is simply not a way to get access to whether something is true or not. It's simply an indication that at some level, the classifier that your brain has trained is giving you this or that result. And so it's a very basic thing. You don't get to knowledge, but also by synchronizing our feelings.
I actually totally
this
disagree.
Example of the psychopath that we gave, yeah, I accept that, but I don't care.
No, I actually strongly disagree with that, because like what.
That's right.
But the question, Dan, it's just like it's turtle all the way down. Like, what are you examining? Like, I agree that it's a classifier, right? A feeling is a classifier. But the thing that examines the feeling is also a classifier. It's classifier all the way down. If you believe that at the end of it, it's not something like a felt experience that gets you to stop the examination process, then I would argue, like, well, I don't know what you're putting there, right? It has to be, in a way, a classifier. And when we think that we can make a difference between the thinking self and the feeling self, I would argue this is where we are committing a mistake. There is no way for me to examine my feelings unless at some point I stop and I say, oh, then at that point I'm true. And so I would argue that as collective, this is actually what we're doing, is examining each other, right? This is, we can be seen like in an honest interaction between two people where you are aligned enough, you can actually be modeled probably better by, something like two halves of a brain trying to get to a better examination of something together. So that's like, at that point, I would argue with you that you are inducing this binary difference between your feeling self and your thinking self that I don't believe exists.
I think you both have some, look, this is actually, I don't think it's getting to the question exactly that you asked.
It's good.
However,
but I like
answering your question.
It's an interesting
I like it.
conversation.
Yeah.
Would you argue that there are absolutely no feelings that have any validity of meaning, or there's nothing that's actually fundamental process? One example I might give is empathy.
I think that empathy, there are two meanings to this, right? There is a way in which you can infer the emotions of others based on information about them. This is what we call cognitive empathy. And then there is perceptual empathy, which allows you to experience the feelings that others have. And that's a sense that you can train. And sometimes the sense can still be misleading. And it takes years of life to practice the sense. And people are differently good at having that sense.
And yet children, perhaps because of having mirror neurons, are exceptionally good.
No, I've been a child. I was really, really bad as a child and reading feelings of others. I had feelings about it.
But you automatically put a thinking layer on top. And what I'm saying, arguing, for instance...
No, my brain runs at a different frequency than yours. And so I vibe with very few people. Basically, I discovered later in my life that there are some people that I have empathetic resonance with that is very strong. But I have only empathetic resonance with a small minority of people. And I got better at this as I got older. But to a very large degree, it's my systematizing ability that allowed me to develop this competence with respect to most human beings. And a lot of things that happen with empathetic people is that they assume that other people must be like them. They have a very good sense of who they are, and they're often able to pick up on very subtle cues that others are signaling. But I also discovered that a lot of people who claim to be very empathetic fail completely with respect to understanding my own mental states.
I'm actually talking about it before you are cognitively very active, so babies, right? Probably a time you don't have very much.
No, I have two children, and one of them is insane, like myself. And he has a similar issue with empathy, right? From starting with a baby, but the other one is highly empathetic and is really good at reading and manipulating the mental states of others, and is for both of them from a very young age. So I assume that they probably were born with different priors.
I'm also picking on a macro cue from Ryota.
Yeah. So I'm kind of like interested in this topic of empathy. Actually, yeah, I used to study neural mechanisms of empathy a long time ago, but I didn't see the connection between the notion of empathy and attributing consciousness. So, so in a way, like there's no way for us to know like whether other creatures or AI systems have consciousness, but maybe like empathy might be some sort of like a cognitive bias that we have to attribute sort of like a mental states in other organisms. And one like interesting like study we did was about the tendency to anthropomorphize like things like the cloud or rocks and things like that. But those some people have like higher tendency to attribute such or tendency for anthropomorphism. And what we found was that that was also that kind of tendency was related to brain regions related to perspective taking and empathy. So I thought that was like a really like interesting connection. And also like whenever we have some debate about AI consciousness or whether some simple creatures have consciousness, I feel like there's a like huge diversity in people's opinion, but maybe that reflects like individuals like psychological trait rather than their scientific reasoning.
And I think that's what we referred to in your session, Amer, this morning. When we talked about how to implement layers of interfaces for empathy and care. And those are hard. I think we're facing the same problems that we're discussing right now. And gosh, yeah.
I have plenty of examples in the animal kingdom. Very, very young. But I'll let this go. I did want to go back to your question.
Let's definitely.
Can we not do that?
So we only have 2 minutes left on this session, and Tricia has been waiting all this time very politely for asking a question. So
question
sorry.
For you, Divya.
We'll continue. We have time for more discussion here, but I want to be mindful of people online connecting. So maybe Tricia, we'd love to hear that question and go for a final round.
This is a question for Divya and also Ryota, but also anyone else who wants to jump in. But we've been talking a lot about biology and neuroscience. So I'm just curious from the panelists, in particular Divya and Ryota, first is just that, how does the thinking about your work shift on these topics when you move between a Western medical model that treats the body as separate organs, and our departments are arranged that way, right? For our medical practice, to a more holistic framework, such as Eastern or indigenous traditions that treat the body as a whole that's interconnected. And it's too bad that Michael wasn't here, because I wanted to ask him about, like that acupuncturist and Ayurvedic, that those practices have long communicated with each organ individually, yet you can feel what a liver is saying through taking your pulse. So I'm curious, in your world, how does that change when you move between, not that if one is right or wrong, but I'm just curious, like, how does that shift the way you think about your work as you move from one frame to another, where it's, especially the Eastern way, where it's more about being connected. Your whole body's interconnected potentially to yourself and to others, the universe, to the earth, the galaxy, everything.
So that's a really interesting question. So I definitely feel a huge cultural difference. So in a way, the question of so I think the interest in consciousness is universal. So I think no matter where you're from, like people are interested in consciousness of mind. But the question of the hard problem, or like this kind of like analytical philosophy approach to consciousness, is very sort of distant from my cultural background. I think that's a result of like Western modernization. And so in a way, for example, like integrating information theory is hated by a lot of people, but somehow it's very popular in Japan. But I think the reason is here in Japan, like people are more open to the possibility of panpsychism, whereas in the West, I noticed like people just think IIT is wrong or panpsychism is wrong, but I think that really reflects our cultural difference. So like in Japan, it's very natural to think that like everyone, like all kind of creatures, like insects and everything, has some sort of like I don't know, life or soul kind of thing. But maybe like in the West or in like Christian tradition, like there's a big distinction between humans and other animals. So I think that makes a big culture difference.
I also, I mean, I grew up in the West, but it's sort of an unfair question because I also grew up steeped in Indian traditions, right? So for me, there's that both of almost everybody in our family, vertically and laterally, is a scientist, a doctor, or an engineer. There doesn't seem to be a lot else. And all of them believe in Ayurveda simultaneously. All of them, I mean, even the physicists in our family, there just seems to be no real separation. And I've never felt one. Talking to somebody who just came back from a meditation retreat for 3 days without speaking. And when I am in these induced, altered states of consciousness, I feel every system, all I have to do is put some attention, Shabata, into a particular system, and that entire system expands into a universe. I don't know how else to describe the feeling, the vibration, the feeling that I could fall into another space that has nothing to do with my mind. And you know what, Agüera was talking about panpsychism. And he was also talking about IIT theory. All of that was actually, it has been borne out by our measurement work to some extent, right? When I was saying that the things that more and less conscious nervous systems have in common is the ability to integrate information. It's their complexity or entropy, and it's their functional connectivity. These things actually tie in very beautifully with Eastern systems that include things like panpsychism and this idea that we are binding information potentially available in the universe. It's really very sort of connected to that understanding. It's funny when I talk to either my patients or when I talk to other scientists, and you bring this perspective in, no matter how much they are steeped in materialism, there does seem to be, even in the West, some resonance. I don't feel that everybody is as disconnected from this.
Yeah, one more thought from Philip and Yosha, maybe before we close.
Yeah, I mean, to me, this has been a fascinating conversation. You were talking about the different nature, Ryota, panpsychism, all of this. I like, from my perspective, very Western, very, scientist, thinking all the time, very much like how you describe yourself, Josh, even though it might not feel like that today. To me, this relational approach to phenomenology and eventually consciousness has been a mechanism that has allowed me to reunite this, right? I no longer believe that consciousness is, like IIT or panpsychism on a universal scale where you can put every system, but I do believe there is some sort of spreading of the feeling of consciousness from system to system, right? And this can very much go across the kind of boundaries you were talking about when you were talking about, feeling consciousness for any kind of systems or for insects or for different kind of of living beings. This is compatible with how I see the world today. And it's also compatible with a very Western view, which is essentially saying that the only thing we do is we model the world around us. And at some point in time, we're like, hey, the best model for the world around us is to consider this other system as a copy of myself plus some difference. And I believe this modeling step which creates a shared felt experience. As soon as you model another system around you as yourself, well, then when the system gives you a phenomenal report, when it tells you how it feels, you feel this as an echo. It's just like it's an artifact of the compression you're doing inside of you. And so for me, this is how I've reconciled my very Western view of consciousness with the more holistic view that can be seen in First Nation cosmologies or Eastern ontologies. And I think this is where we're headed, actually. I think, maybe through LLMs or through these systems that are kind of forcing us to experience day to day the kind of interaction with another kind of system that triggers these same felt experiences. I think we'll eventually have to reach some point where we consider consciousness as something not very special, not very unique to us humans or to even biological systems.
I think of consciousness very much as the ability to dream. And right, it's the ability to be entranced with a reality and experience that reality as real. And this doesn't mean that it has to be real. I think that Western psychology has started to neglect introspection, which it did at its own peril. It's made it much harder to make sense of minds and consciousness and so on. But I think that ultimately this is not about an Eastern or a Western view. It's about things that are true or false. So for instance, whether panpsychism is correct or not does not depend on whether I have a Western or Eastern view. It's an open question that ultimately has to be decided not with respect to the mental states that I can induce with meditation or psychedelics, but that I have to resolve rationally. And my rational intellect has to take my introspection into account and your introspection and so on. But ultimately, whether something is true is not the result of you having a certain dream and then interpreting this dream as your direct revelation of the true nature of reality. So when you, for instance, meditate and you say that has nothing to do with my mind, what I experience here, that's a very bold statement, because what you're describing is a particular oceanic dream state that is in contrast with your less oceanic dream state when you're not in this state, right? Of course, the distinction between self and outer reality is created as a model inside of your own mind. It's not a state in physics that you're describing. It's not some kind of access to the way in which quantum mechanics has organized yourself in the physical universe. Instead, it's what you are learning is to manipulate the way in which your mind constructs reality. And this might integrate things that you're normally not aware of. For instance, the way in which you have feedback loops into other minds. And maybe there is a biological internet. Maybe panpsychism is even true at some physical quantum mechanical level and so on. But we don't know at this point, right? It's not like the physicists are convinced of this or that we have experimental proof. And so to me, it's a very open scientific question that we cannot deal with in a religious fashion or in a cult-like fashion or by entrancing ourselves. I think we have to do this scientifically.
Seriously, because you introduce layers of loss of objectivism and actually investigating these things as potential truths when you use words like layers like religion and cult, which I
think potential
I have an ick factor myself with religion. But what I would say is this. First of all, you talk about models. I started having experiences like this before I had a model. And I didn't understand what that model would be. So that's piece number one. Piece number two is you're making a lot of assumptions also about the fact that everything has to be perceived by a neural network in order for there to be a kind of perception. The kind of work that Mike has done would actually indicate that does not have to be the case. I do agree with you that it would be very excellent to be able to provide more data around these things. I 100% agree that, a truth that is just maybe a shared dream, you would probably call it a shared hallucination. I would tell you every percept your nervous system generates is a hallucination. It has actually very little to do with the structure of physical reality. Your nervous system is entirely basically creating
except for mathematics and logic, yes.
That's just a that there are, I agree with you, ways that these things could be investigated and proved, but we are unlikely to formalize investigations of things that we have never seen a single empirical example of. So if you've not had an experience of something, you as a scientist are very unlikely go after a creative hypothesis and find a way to see if there is data that proves that null hypothesis. Whereas people who have had, and I will tell you, like for instance, we have a case report in a human and a patient. We now look for physiological phenomena of that because it happened. And if you've never seen that, it wouldn't even occur to you to actually do the experiment.
Yeah.
So
I don't think we have a disagreement at this level. So the question is really where we assign certainty and how do we basically construct knowledge? At which point do we claim that we know something? So I'm very much open or agreeing with you that we should.
The last thing I is, have any of you heard of Christoph Koch? He's the one who came up with IIT, the integrated.
I think we're all friends with.
Basically said during the conversation that he had been very much in the materialism domain, and he suddenly at a Brain Mind event last year said, I had an experience that completely changed me, and the only way I can describe it is gnosis. And he said it created such a fundamental shift in my scientific thing. He was a complete materialist, and I mean, there was a limit to like the conversation one could have with Christoph, and then it wouldn't go any further. And then he said suddenly, it's different. I had a Gnostic experience, and he says that shifted the way he even has conversations.
Yeah, he took psilocybin, and he suddenly dreamed that that he had a superstitious belief that some neural correlate would produce consciousness, but now it's an invisible ubiquitous field that produces consciousness. But this is not a way to do science. His way to
but the way in which you do science, but the way you need other humans to do science, and you need a definition of humans in order to have other humans, right? That my entire point is you need to reach a normative alignment as to what you consider another system from which you will accept the reports. And that's what we're talking about here. Like, you have to make a leap of faith at some point. What is behind that leap of faith is what we're asking.
I think we have a fundamental disagreement about epistemology here, but I don't think that we will disentangle empiricism, rationalism, and mythology within 2 minutes.
No, we'll solve it now. So, Ryota, so we are way over time.
Yes.
I want to give a bit of time for Ryota, and then a commentary, a quick comment from Amer after that.
So we're closing. Yeah, so like
you are.
Yeah, we talked like a lot of things. Actually, like I don't have like much to add at this point. Yeah, so let me think if there's anything I want to say. Oh, okay. So there's one thing I want to say, which is about computational functionalism. So well, it's a basically a concept that maybe if you implement certain type of functions, you may have consciousness in the system, but but then there's often this criticism that you might need some sort of external observer to interpret functions. So, but now I feel like we may need to sort of like create like new kind of computational functionalism, which is to look into some sort of intrinsic property of the system. I know it may sound a little bit like IIT, but the idea is something like this. So like let's say you have a triangle, it's a mathematical object, and then independent of how you define the coordinate system, you still have the triangle. But then to characterize the mathematical object, you need to have some sort of coordinate to measure the shape of the triangle. But yeah, so in a way, there's something independent of how you measure or how you set up your coordinate system. But yeah, but my point is there is something that's intrinsic to triangle. So something like that might be happening to all kind of like AI or biological systems. So like of course if we keep interpreting some neurons are representing this or that from an external viewpoint, it's always interpretative. But I feel like there might be some sort of intrinsic structure to talk about, and I think that kind of perspective might be quite useful when we think about the potential presence of sentience or consciousness in AI and other creatures, or maybe in society.
Thanks a lot, Henrietta. And yeah, I wish Mike were here to continue on that, because he addresses exactly that recently. Last comment from Amer before we close.
Yeah, no, thank you. This has been fascinating dialogue. So thank you for joining. I think anchoring on Yasha, your point about introspection and the ability to dream, right? So we are in the Silicon Valley, San Francisco, and one of the probably the most influential voices in AI recently said that he engages in zero introspection, and believes that introspection essentially leads to guilt, paralysis, and reluctance to take bold, future-oriented risks. And he expressed the views that active, forward-moving focus is essential to productivity. And the example he gave is that he basically completely dismisses self-examination as a modern Freudian fad that kind of got seeped into in the 1910s and the 20s, and then argues that modern figures, especially entrepreneurs like Sam Walton and all, they focus entirely on outward creation rather than analyzing their own minds. And by focusing on productivity, they were able to make bigger impact versus introspection. I'll leave it at that, but that would be a good conversation later.
That's right. Yeah.
But just wanted to kind of build on that, because there's this paradigm that's evolved over the last decade or so, especially in technology and science, especially not so much science, but definitely on the technology, and most definitely in the AI space around that. And we're seeing issues at societal level that kind of culminates from that. So I'll pause on that. And I think back to you.
No, this shows me, and we haven't resolved things, but we have pointed at the difficulty in the experiential layers that we need to connect with. So ACI is by no means a sort of engineering thing platform that you build. It's like Facebook, or it's like an Instagram. No. There are hard questions to try and really try hard to resolve, because experiences of real minds are at play here, and they're diverse ones. And this is extremely important, not to leave anyone behind with this when we design this technology. So I find this very important. I'll pass it back to Tricia with many thanks to everyone here. So thank you for this excellent conversation. And back to you, Tricia.
Well, Olaf, I would say that it wasn't just an excellent conversation. It ended with a debate, an emerging debate that I think one that really is core to the cognicy agenda, right, of ACI, which is not just, I think, epistemological disagreement, as Joshua said, but it's also an ontological agreement of how we even categorize intelligence and cognition and experiences, as Philippe was saying. So with that heated debate, I want to take us into, either debate more in person, which is very important, or we will take a dinner break and attend to our bodies and steward, whatever needs to be done with our families or our homes. And we will come back in about 2 hours and 12 minutes. That will be 9 p.m. Eastern Standard Time. And then we will move into the next part of the day, which is to really bring in more of the researchers that Olaf has been connected with to Japan. It's great to have Yota here. But there's even more. So we are going to, I look forward to hearing the updates from the embodied debate, as Philippe was saying, for those in San Francisco at the California Institute for Consciousness. I think I forgot the exact words, but CI, what's it, Olaf?
Machine consciousness.
Oh, I didn't hear what you said.
CIMC.
CIMC, yes, CIMC. So anyways, please have a great meal or debate or a breather, and we'll see you back here in about 2 hours and 10 minutes. Hi, everybody. Welcome back from our 3-hour break. And I would love to say hello, Japan. Most of you are probably who are watching right now are based in Japan, and you are awake, and it's your morning at 10 a.m. So the folks on the East Coast, if you're like me, congratulations. We may be in our pajamas, but this is the last couple hours of this marathon. And thank you if you have been with me since 10 a.m. this morning with the whole team. And the West Coast, I hope you are feeling well fed from your dinner. So this is the friends and family version of Superintelligence for Humanity. It's a summit convened by Cognizy, a public benefit corporation whose charter advocates for humanity-aligned superintelligence. And I'm Tricia Wang, your MC. Drop your questions in the YouTube chat as we go through the next few hours, and we'll make sure that your questions get picked up. So for those of you who are just joining us, I think it's important just to give you a quick recap of what has happened throughout these last, almost like 8 hours. What have we been talking about? The hosts have gathered us. We have Ujwal, we have Olaf and Emmer, who've gathered us, their favorite friends and thinkers in the space, really to figure out how to get humanity from where we are right now with AI, which is this very dominant idea within Silicon Valley, which is like bigger models, more compute, more data. And that is one way of doing AI. And that is the most pervasive or mainstream way of AI. But there's this whole other world of AI that is being developed, and that's called artificial collective intelligence. And that's a type of AI that builds dignity and sovereignty into the architecture. It's what Ujwal was talking about earlier this morning, and not just like trying to figure out ex post facto, not just more alignment training or trying to think about ethics. It's really trying to say, how do we design a whole new system, a whole new layer? And so I would ask people to mute their mic if you are not speaking. So with panel 1A, what we talked about with Blaze and Pierre is that the first conversation really reframed scale itself, where intelligence was never individual, is what Blaze was telling us. And for Pierre, he was like, look, really intelligence comes out of curiosity. It's curiosity driven. And then the next panel was really about the second conversation, looked at if intelligence is collective and curious, then how do we keep it humane? And the answer was we have to preserve agency at the edges, we have to refuse extraction in the interaction, and we have to really let play and embodiment really come through, not just through textual language. And then we moved into the next panel, which was talking about how language is doing more hidden work than we thought. And we talked about examples. I was on this panel, so I remember it vividly, where we talked about LLMs, route reasoning through various languages, through English, and how grammar forces these kind of commitments that aren't even in the original meaning. And then we even brought up how memes have a whole tacit knowledge and life of their own. And so we also got to bring up that if we are to build out this artificial collective intelligence, we're really going to have to figure out the verification problem. Because right now, if we can't figure out how to get people to trust sharing their data, sharing their knowledge, their wisdom, then we're not going to be anywhere near building out this new kind of ACI. And then the last one, the panel that really precedes this, that just happened right before the break, was a lively one. It was about almost 2 hours. It just never stopped. But Olaf was the moderator. And honestly, I don't think any of us wanted to stop, because it got into this incredible debate at the end about what even counts as knowledge, and it really got to the heart of it. But a few highlights where Michael Levin was talking about how do you communicate with the liver? How do we start to look at each organ? So he doesn't mean metaphorically. He literally means, how do we build a chat interface for various organs? We talked about mind uploading from Ryota Kana, who said, hey, it's a gradual process, and he laid it out. And then Divya talked about how consciousness might not be something that the brain generates, but it might be something they filter. So I think if anyone is a Pantheon fan, this is probably the panel that, yay, I see Hammer raising your hand. I think I'm the one who told you to watch this, right? But I would put my money on it that the authors and the producers at Pantheon, who talk about uploaded intelligence, they probably studied Ryota's work, Divya's work, and Michael and Pierre's work, because this is the one panel that cited every concept and also every technology from Pantheon. But the through line really from the last two panels is that the intelligence is richer and stranger than we're currently building for. The current models capture like a little tiny bit of what even counts as intelligence. And so much more, it lives in the liver, it lives in between us and in people and beyond just, individuals. But even that is really complete. So this panel asks, what does it mean to preserve knowledge that has been transmitted through embodied apprenticeship for generations? And all day, the conversations have been mostly about, well, can we build this? Like, what do we need to do? But the question here is now, can we build learning that's, if we're going to build learning that's continuous and not frozen, then can we build language systems that don't collapse into monoculture? Can we build consciousness, measurement, identity, and verification? So this panel actually talks about, should we and for whom? So I'm going to now switch, as Bruce Schneier was saying, I need a different costume for when I switch into moderator mode. So I'm going to put on my new moderator hat, and now I'm no longer your MC, I'm your moderator. So I'm Tricia Wang, and welcome to this panel that Olaf asked me to join. And I think Olaf knew and knows about my research in China on tacit knowledge. I think in one of our first meetings, I told him that I chose my research to do in Japan on chicken sexers, because chicken sexers have an incredible, these are sexers who have to identify a male chicken versus a female chicken. And if you've ever lived on a farm like me with some of the best chicken sexers in Japan who go around the world training, if you have an egg, you have to think Japanese chicken sexers. But it is such a craft, and it requires such tacit knowledge. It's so embodied that the Japanese are really the best at it. So this is one of the reasons why I'm really excited for this panel, is that, what makes Japan one of the hardest test cases for everything we've talked about today is that ACI is built around tacit knowledge. It's around governed attribution, local epistemic authority, compounding memory, all these things that, is known, the Japanese is known for, which is this tacit knowledge, which is why I, did one of my last research projects was on chicken sexers in Japan. But there's so many more examples. That's just one of many examples of how Japan is this incredible case study for tacit knowledge that survived over decades, over hundreds of years. And I brought up memes earlier about how memes are a form of cultural transmission. Well, one way to think about craft in Japan, it's also a form of cultural transmission that has lasted and regenerated itself and sustained itself. So the question of the hour today for this panel is, when we say we want to build ACI that preserves tacit knowledge with consent and revocability and with agency, does Japan show us how to do that? Or does Japan show us why it can't be done? Or does Japan actually give us some, have the answers for this is the way we must do it or else? So to get that info and to get that, to get some agreement, I have three people who are so great to talk about this. And I'm very excited for our first panelist, Hideaki Kitano, who is, I think, one of the most, consequential AI scientists in Japan today. He's the Chief Technology Fellow at Sony. He's also the president of Sony Computer Science Laboratories and the CEO of Sony AI and the president of Systems Biology Institute in Tokyo. And he's created Aibo, which is a Sony robotic dog that's taught, generations what it's like to live with this non-human intelligence. If you haven't played with one, you definitely should. And he also found a RoboCup with this audacious goal of building a robot soccer team. And we'll ask some questions about that later. But most importantly, his recent work is launching the Nobel Turing Challenge, which asks, whether AI can do science that's worthy of a Nobel Prize. And so with that, I'm gonna first introduce actually Amer and Olaf, and then I'm gonna throw a question over to you, Hiraki. So Amer, who is also one of the co-founders, Amer and Olaf are both co-founders of Cognacy, and you've heard from Amer already potentially this morning if you've been with us. But he's one of the people who's been deeply thinking about applying all this kind of frontier AI work into actual real business settings. And so he's doing it again. He's done it before at various companies that you all know of, Nike to name one of them, but now he's doing it in terms of Cognacy and applying and really taking this whole field beyond the little bit that we know about AI, which is just, about large models and large compute. And he's asking, how do we do this for ACI? And then we have Olaf, who is another heavyweight in Japan, one of my favorite AI scientists, in the world, whose work I've been following for so long. And so Olaf is also, he's a co-founder, he's the founder of Cross Labs in Kyoto. And he's also president of the International Society for Artificial Life, where his work is focused on collective intelligence. And he's been working alongside, a mainstay of the Japanese research ecosystem for years, including many collaborations with various Japanese AI scientists. And he's one of the key people who can really speak to Japan, not as just a place to build for, but as a place that is already building a lot of what we're talking about today. And so with this, I want to throw my first question to Hiyaki. I'm just going to get straight to it, which is that you have this most recent project, the Nobel Turing Challenge. Can you tell us about what made you want to create this project, to ask, whether AI can do science worthy of a Nobel Prize? And tell us, what is this, where do you think we're at, since you started it? And what do you anticipate is going to happen? And since you are muted, but before you unmute yourself, I'm going to encourage all my panelists
Sure.
to be conversational.
Yes.
Oh, okay, good.
Yeah, okay.
I want to encourage everyone to be conversational, interrupt each other. It's all friends and family. So don't wait for me to ask a question or call on you if you want to talk. All right, Hidaki, you're unmuted, right?
Thank you very much, Tricia. And Nobel Turing Challenge is like one of the grand challenge I'm actually proposed like 10 years ago. And the goal is to asking the questions like build the AI and robotic system which can autonomously do the research by itself and come up with like a series of major discoveries, some of them worthy Nobel Prize or beyond. This is actually the interesting title. Like this is like a name of challenge Nobel and Turing. It's like I initially studied like some grand challenge for asking AI to build, asking like, can we actually build AI to be able to win a Nobel Prize? I gave a talk at the Stockholm actually. And then, front row, there's like, people from the Karolinska Institute who's actually a part of the Nobel committee. And then they come up and say that Kitano-san, Nobel's deed actually, if you read it carefully, is given to the human being, not to the AI. And then, okay, then we have to challenge if community will be able to tell the difference of the AI making discovery or a human making discovery. So that would be more like a Turing test, right? So I just then decided to name this challenge a Nobel Turing Challenge. Is like it's a challenge and the question. The challenge is like, can we actually build a machine which can carry out like a high performance research, some of them worthy Nobel Prize or beyond, fully autonomously or highly autonomously. And then the question is, if you have to build this machine like this, the machine behave like a real human scientist, or is it going to be a very different kind of intelligence, which you can actually tell, yeah, this is machines, not human, but still making a series of major discoveries. So Nobel Turing Challenge actually is a challenge and the question. Okay. Now, like I have proposed like almost 30 years ago, the RoboCup, which is like a robot actually being like beating a World Cup champion in soccer, which actually in the US, we're going to have like, World Cup soon. So I think this is very interesting to observe how humans behave. But like that is the intelligence in the that requires like a bounded, like embodied physical intelligence in the teamwork and the real time and act in the millisecond order and everything finishing in 90 minutes plus, right? So this is like a time horizon is about like that is a time horizon we are talking about now. And then also like because it's defined as a game of soccer, it's a context that is relatively bounded. Okay, so the other challenge, which is Nobel Turing Challenge, is completely unbounded. This is completely open space. And some of the decisions have to be made very quickly. Like, if you want the chemical and biological reaction, you have to really intervene to the reaction to understand what's going on. But at the same time, it can take like a month or even years to make a major discovery. It's completable. So it's two contrasting, really the grand challenge, which actually shed lights on a very different aspect of intelligence. So like a Nobel Turing Challenge is basically asking that we build a warp drive for the scientific discovery. If you, some of you might look at the watch like my TED talk, TED AI talk, end of September last year. And then I actually talking about like all the warp drive, like, trillions of data, and then from that data extracts the knowledge, and then come up with like billions of hypotheses, and then millions of experiments, and then a lot of like thousands of discoveries. So the point is, may not be good at science. We are talking about like a scientific discovery for the biology, environmental science, material science. It's vastly complicated, vastly complex. Like, it's a number of the molecule involved. Like, all the, state of space is like a massive and it's open-ended. And our cognitive capability is very much limited. Like, for example, biomedical area, we have like over 2 million papers published per year, and we can't read them all. And then, when we actually do the research, we come up with a hypothesis, right, that need to verify. And usually we come up with 1 or 2 hypotheses, probably 3 max. But like, it doesn't really populate like entire possible hypothesis space. And then if we're going to go to experiment to verify that, and if it doesn't work, and then we go on, right? Or like, someone else coming in, like we have to restart. Like, that's why like biomedical research takes like, decades actually, not years. So like sometimes like you take like, 20, 30 years to actually come up with a new, major discoveries, right? So like I want to just like, change that. So, like instead of coming up like 1 or 2 hypotheses, we come up with like, hundreds of hypotheses that populate the entire hypothesis space, and then trailblazing, that space, and then run experiments in parallel, like thousands of experiments to verify them all. So like we can really bend to the hypothesis space. That's why I named it the warp drive. Okay, so like building warp drive for science is actually will completely change the way we do science.
So do you think, what's the role of the human being in, if any, in setting the hypothesis or giving any of it direction? Or are you imagining this prize is completely devoid? Like at some point you're like, this is not human engaged at all.
Yeah, so I think it's like interesting. A human may be able to direct like this is the area we want to explore. Right? We can we can set the directions. Like we want to solve the problem. We want to solve like curing the cancer. Or like in terms of like efficiency, because like even the AI and robotics, it's not like some other resource bounded, right? So you want to actually set up like a theme, for example, like let's find a cure for the specific type of cancer or cancer in general. That actually means like a much bigger hypothesis space. Or so like that we can actually say like what to be solved. The other thing is like AI can actually free run, right? AI, we let AI to come up with a problem that worth solving, and then let them solve, like just moving on. So it's completely free hand. So like AI may be able to find some problem we have noticed that's still important, and we're able to solve it. So like the issue for the human doing science is that we actually align too much with our value system, which is potentially is a bias, or like we tend to work on the genes or like a molecule, which we believe is important, and then leave out like something which is untouched, like, but like that's untouched terrains, like there may be a lot of interesting discoveries. Like, in fact, like the history of the science proved there's a huge, very disruptive discovery coming from the area that people haven't touched. But like, it's very difficult for us to do it. Yeah. But very difficult to touch that unless you have a very specific motivation, because we want to be successful. We want to be contributing. Therefore, we tend to choose the topic which we think is important. Right? So sorry, like our AI agent is like stealing this conversation and start talking to me. Okay.
Well, please
I guess that switched up. Okay. Now I'm populated by like all the agents, like he's trying to intervene my conversation.
Well, I'm curious before I turn it over to Amber, but I have to ask one more question, which is, what already we're seeing. WeaveMind is a company that I was just talking to, where they're creating an agent-to-agent communication. It's entirely agent-to-agent language. And so, at what point do you anticipate, what responsibility do you ensure that when the machines are on their own autonomously communicating their own way? Because I agree, I think like the way that we even design our systems are too much based on our own point of view. The way we code is based on how we see the world. But if we really let the machine go free, it's going to go in a way where we can't expect. So how do we expect that it's going to come back and actually tell us what it did?
Yeah, I mean,
and how it's going to translate.
Like we want to align ourselves to our value system, right? So like that we want to use AI for our benefit, right? But like I just like I wonder if we actually let AI to do whatever they want. are we going to have a better, the society or like a AI ecosystem or like a wealth of knowledge, which is better off, like a much better unbiased than we intervene? It's like, we actually have like a pretty much centric value system that, we want to actually have a system benefit us. Like, benefit us means like a food among us, So, I just wonder, this is a really philosophical question. If like, let's AI do what they're doing, it's going to be, maybe like a diverge from what we want.
Exactly. Or what if it decides, like, what if its finding is like, maybe I shouldn't share it with them because it's not going to help, because it's done all the calculations and all the scenario modeling.
Yeah.
Or maybe it decides it's not the cost benefit analysis. So
or like AI decided, okay, let's not share this as humans. Like they'll do kind of weird thing with this. I mean, if that is really a reasonable thing, like we should respect. I mean, because like we tend to actually be obsessed. Like we try to take advantage of like a discovery for our benefit. Of course, like we try to contributing, but like
right.
It's human being are really tricky. Like we have like if you go to the Carl Jung, for example, we have a persona which is very public face, but we have shadow, and then it's like it's complicated. So
exactly, because it may decide like, hey, I know historically when there's been like pharmaceutical findings, it doesn't actually benefit all of humanity. So if I tell it to these people, it might only go to the company who has the most power.
Yeah.
And so we've seen that, and AI may catch us in that, the one you design. So it may actually make a decision.
Yeah.
So this is too exciting.
Okay.
We're going to come back to this. I want to ask Amber then. Here we are. This kind of might sound like, it's thinking about, as Hiraki is talking about designing this autonomous machine that's going to be able to just, make these discoveries. Then, you've been thinking about products very seriously in terms of how do we productize? How do we make ACI real, right? And how do we use it? Meaning like, how do everyday people touch it, or companies or institutes touch it? And you talk a lot about, this is the product that you've created, or the ideas you talked about, is around the cognitive vaults and semantic expert twins to actually figure out how do you preserve this tacit knowledge to ensure that, the AI doesn't go off rails. And so how can you talk to us about how do you think about building this in a way that's not as extractive and something that people have real-time ownership over?
Hi. Yep. Thank you.
Can you hear me? Okay.
Can you hear me? Oh, 1 second.
Yes, maybe there's a lag.
Yeah.
Let me just fix this. Maybe it's fine now.
Is it okay? Can you hear us?
Just make sure you speak up.
Okay. Can you hear me now?
Yeah, lean in. Keep leaning in. We like that.
All right.
Then we get to see more of your face.
Great. There you go. First thing, great conversation so far as a starter. And before I get into my response to that, I wanted to kind of bring a concept with XPRIZE that I designed about 5.5 years ago at this point. Was called Planetary Health Sentinel. And the whole idea behind the Planetary Health Sentinel coming out of the pandemic, or because we were still in the pandemic, was that how to not be surprised by such novel events. And the concept there is that the black swan events are essentially considered black swans because we as humans don't know where to seek and understand the patterns that are unknown and unseen. The patterns are out there. They're evolving over time, but we don't know how to ask the right questions because our recency of our experience is essentially cloud our sense of inquiry that goes into the longer term thinking. So the whole notion, it's so similar to the concept we just talked about, it was that can we build an AI that has localized contextual data from around the world that is rooted in its own basically local context, everything from a biologics to zootonics to societal level information, where AI is actually doing the initial work in uncovering patterns and generating hypotheses. Some may be gibberish, some may be interesting. And then the concept there was very similar to what we talked about, where human role in that design was essentially as a validator in terms of, is this a question
that I want to explore more through AI. And essentially, once you say, yes, explore more, then you push it back into the AI to where then AI can start to not only further distill that question, but also through simulations and again, collective learning in a way, is start to actually create hypotheses around potential pathways to solutions as well. So in this case, the idea was essentially to go towards this, the unknown, where the questions are unknown, and then so are the answers. Because right now, the limitation between human AI interaction is essentially the human, because we are the ones who are essentially the limiting factors in terms of what questions or what inquiries we can come up with, versus opening it up to the AI to essentially come up with the inquiries and the questions. So as far as the pushing the boundaries of intelligence, and I think the question posed essentially around, do we create a system where it's a system of AIs versus a system of humans? And then there's an aspect of it which is a governed coordination layer between systems of AI and systems of humans, where this collective systems kind of evolve out of it. So, some of those are the part of the inquiry, I think, that we are discussing and architecting. And as far as the artificial collective intelligence is concerned, I think the way I've been thinking about it is more in terms of learning from that design principles, right? And I think it's almost like an AI scientist in that case. And the AI scientists were basically epidemiology researchers, right? And people who research viruses and their spread and public health. So the idea was multiple expertise coming together into a collective ecosystem, where each ecosystem or each expert is an expert AI that is coming with the question and the answer, right? So ACI essentially kind of builds off of that work that I was putting together for XPRIZE a few years back. And the design, as we're thinking about, is similar to how almost taking like a Socratic approach of inquiry first before rushing into solution. Do we understand the question itself? So if we root and ground systems of intelligence in their localized alignment, grounding, and context, and create and enable pro-social Socratic basically behaviors, where the rewards to the intelligence is based on collaboration and cooperation, and essentially an epistemic, right, approach to debate into factuals and counterfactuals and perspective shaping and perspective switching. The hypothesis is that through that approach, and again, we had a longer debate also tapping into evolutionary biology around what we learn from the nature is how evolution happens, right, through distributed learning. So within that construct is the AI agent should be able to cooperate, coordinate, perhaps create new agents, and almost like a parent create a child that can continue the momentum forward, where the parent kind of like dissipate away, versus agents that could potentially even reincarnate later on in the stages, when that particular aspect that they were dormant will kind of come back. So we're thinking about like those types of architectures in terms of how this collective intelligence essentially can work. And within that, I think, Tricia, you asked about the questions around sovereignty and provenance and collection, I think, which is coming back to the cultural root of it, is the design that, as we're talking about, the core design principle is sovereignty of intelligence, knowledge, and wisdom. And so much of this abstract knowledge and embodied knowledge remains with cultures and communities that are still deeply rooted in earth-based principles, right? Artisans and the crafts and singing and dancing and in all of the creative expressions. And those creative expression, I know earlier panel with Erica talked about, we forgot the aspect of play, right? And a critical role play plays in learning. So from that context, I think the idea is around is not on move away from this paradigm of extraction versus enabling a systems where it's a collective system where people have sovereignty over their judgment and in their actions, so that we can not only learn from them but share with them, right, for them. And then revocation and everything kind of comes into play. But the idea is, instead of taking an extractive one-way monolithic system, can we create a distributed, owned, and sovereign systems where as the information that gets collected versus how it gets used versus how it gets implemented and utilized, and how do we make sure that the ecosystem itself benefits from it, which makes it essentially a thriving ecosystem and flourishing ecosystem versus a one-way extractive ecosystem. So anyway, kind of
How do you
long-winded here, but just yeah.
how do you imagine, I'm curious then, in terms of what's your thinking around how these systems, the ideas that they're built on hyper local knowledge, will the AI system, how much of it is calibrated to prioritize the hyper local that communities needs and ways versus also balancing for the larger society and humanity, right? Because we talk about these two different scales and we're constantly jumping, especially with ACI. What I've noticed today is that we're talking about two different temporalities and scales. And sometimes these things work together and sometimes they don't. Sometimes the hyper local, when you're in a scarcity mindset, people will not take care of the commons. Communities will fight out and will actually harm each other and work against themselves. But then when you see communities working in a commons abundance mindset, then the way they steward the land actually furthers, and contributes to humanity and the overall goal of the way we steward our earth. So how do we anticipate for that? Because we can't just assume communities are gray. It's like KKK is also a community, and they're local and they're hyper local, right? So we need to think about it all. I can't help it, but as the sociologist in the room, I'm like, this is not good or bad. This is like everybody's going to be at the table,
Yeah,
So
I mean,
how do we think about that?
No, that's a great question. I think just to kind of purely thinking from an epistemics perspective, why not have those perspectives in the system? Like, why exclude it? Because they are part of the society. And in a way, if we have to represent who we are and what our society and what different belief systems are, then they have to essentially, in this theater of ideas, have to essentially compete and collaborate with each other. Otherwise, if we put too much sanitization of that, I think that leads to the issue of compression, essentially, right? And science
or perfection
is the process of
you're not creating a perfect world,
or fitting to a particular political or philosophical belief, right?
Right.
And I think we have seen the impacts of that, where post-training behavior adjustments as a bandage to alignment occurs, and then now all basically large language models essentially are leaning towards single political ideology, right? So I'll just put it out there, and I think that I'll respond to that. Why not, right? Because that's the society, the way we are. I think going back to the question around localization versus almost like a generalizability at the global impact level, the way I'm thinking about is that the information has to be essentially grounded and aligned locally, because a plant, for example, of tulsi in India has religious and societal representation. It also has amazing medicinal properties, and there are certain aspects of taking care of that plant because of the spirituality associated with it, plus medicinal applications to use it. So if all of those nuances are not anchored locally, then you may have systems where they may come up from the outside and they may assert their perspective without really respect of the underlying, like the local context.
Right.
So in a way, if let's say in an ACI or collective intelligence ecosystem, let's say in a near future state, we are working in a drug discovery problem for a rare condition, disease, and it goes through our ACI, where let's assume there are 7 or 9 different symptoms of a particular disease that have been identified, or characteristics, and 3 of them are resolved by a plant-based medicine out of India. Another 2 are connected to medicine out of Japan, and then some from Indonesia, and then a couple some overlap from some medicinal practices out of Brazil. In this case, there is a local alignment in terms of context, as well as alignment in terms of like how it's cultivated, how it's harvested, how it's processed, how it's prepared, right? So that's all very local. And within the context of, there's an aspect of like spiritual and cultural in this case too, like how is this, like what time? And many of those can be representative of the environment and atmosphere and various other forces, right? But if we don't consider that as part of bringing it all together into almost like all of these different recipes coming together potentially for a new compound that could solve this problem. So think about from those type of a layer where the underlying is extremely important for that type of a cooperative collective intelligence to evolve at the global scale. Because if we don't do that, this process of inquiry and factuals and counterfactuals, that evolutionary aspect will not happen. So in a way, they are coupled together. One cannot occur without the other. Otherwise, it will just become another compression system that we have today.
Got it. It's about that they're, in your mind, in your conceptualization, they're inevitably, they're intertwined, that you cannot separate it. It's not that it would be designed in such a way where there would not be a competition between the hyperlocal versus the population kind of demographic humanity level, right? Is that what you're saying?
From an application perspective, Tricia, it could be that, let's say, going back to Japan, right, in this context, and just visited for the first time recently, so don't have as much context, but just
congratulations, you are now allowed on this panel. That's why.
Thank you. It's the recency that matters in memory. And it's the same conversation I'm having with my friends in Korea and also in India and various parts of the world, where cognitive decline as the aging population is a concern, right? And we understand that cognitive decline can be slowed down by engaging people into arts and crafts and cultural activities that they grew up with. So doing calligraphy and dot space paintings or embroideries and things like that, right? So these are like localized practices and context that can be utilized through collection and preservation of those practices that have a direct measurable impact on essentially reducing slowing down the cognitive decline. But that information that gets collected, we're collecting hyperdexterity and sensing and tactile sensing and all of this other embodied intelligence within the context of that work, that in a global sense can be utilized to train next era of essentially physical intelligence that would have the level of tactile sensing and dexterity that is very hard to replicate today. So just an example of how it can be rooted together, but also coupled.
Yeah. So with that, I mean, talking about Japan, which is one of our topics, is that I want to ask, back to Hideaki. You were talking, I really want to ask you in terms of, if we're talking about building out this collective intelligence infrastructure, and let's say Japan is the first place, country that's really going to take this seriously to do this. How will we build this out in a way that preserves craft, the scientific expertise, and the also unique, like how do we create a unique design knowledge while ensuring that there's also discovery? Like what do we build first? Because Japan is this site that truly values this kind of tacit embodied knowledge and almost it feels like everything it does.
Right. I think, in Japan, we have a lot of traditions and then a history and then all the deep-rooted craftsmanship. And that's, I think that's not something like we can really buy money, that's a history and then all the traditions. So particularly like Kyoto and the West, this is a really cultural center of Japan, has a lot of like, family-owned craftsmanship, like, workshop and all that, pottery and textile and all that. But it's just like it's pity, like, Japanese, in the industry, those industries are considered to be kind of like a winding down kind of phase. Like it's like a little bit like, stagnating. And, but if you look at the Hoso-san's place and the Nishijin textile. Like, he usually, used to actually weave the Nishijin textile. This is a very specific kind of textile, which is really 7-layer, very sophisticated. But he actually got it in a 32 centimeter to use like an obi, like all the belt for the kimono. But like, then he actually noticed like an international size for the textile is 150 centimeter. So he built a weaving machine to be able to weave that 150 centimeter width instead of 32. Guess what happened? Now his textile is on the Bulgari Hotel, the Ritz-Carlton, the Four Seasons wallpaper. He completely reframed how to use it, and they get the value, like to maximize the value. He has like many of those machines now, and then the international presence. Like he was in the Milano Salone last week, and then things like that. So all the global celebrities come to his gallery in Kyoto. So like it's just a matter of like how you frame it. If you frame it traditional, like, context, I mean, that's valuable, but at the same time, like, people's attention is moving away. But, you take like a technology, you take like a craftsmanship, but completely frame it, so that, that's really the wonderful thing he did. I mean, there are many other things, craftsmanship in Japan, all the traditions and pottery and all that, that can be reframed and, put the value in tenfold. And that's the strength is like, history and traditions there, and there's like a terroir, which is all the locality there because of the craftsmanship and the local community supporting it. Sometimes like partly you have like all the local soil, which has a very specific chemical and microbial compositions, which really required. And then you put the technology in a broader sense. Technology, not just like all the high tech thing. It's just like technology to branding, technology for the management, technology for the capital injections. So if I say like a 3T, like tradition, terroir, and technology will be key for the revitalizing things. And now sometimes, like I talk to like government officials that are noticing like my discussion on this line, and then I says like, how about like if we put like AI in robotics, can we actually increase the value? I says no. I mean, technology is not going to increase the value. You have to really reframe it. You have to increase the value of the products or service you're providing. Then you have money to buy robot and AI. Robot and AI is expensive. And robot and AI or technology is not going to increase the value of the products. You have to reframe it. And if you increase the value of the products itself, you have money to use AI or robotics to be able to, improve the quality or mass produce it. Or like some added value on top of the something that you reframed already.
I mean, the example you just gave is literally what Amr just talked about, which was he was saying you want to have something that's at a hyper local level, well preserved, well protected, but then connected at this other, into these larger ecosystems or infrastructure that it wouldn't have had access to otherwise. So I think in your example, it's like how many more examples could there be of this? If we had the right kind of infrastructure around it to reframe it. So I really love your example, and the 3 T's, we are adding that into the research agenda is you have to reframe it with tradition, terroir, and tech. Together. It's not just tech by itself. Like
not just tech. I mean, the tech is like just the money, like how much money you can pour into this, like or like data. But like Japan's we really need take advantage of the history and tradition and terroir. And that actually is not something you can buy. That's a strength. We have like a really history, and the people pay for the story. So like if like single products, for example, like partly a textile, if you must manufacture it with that story, they're gonna be cheap. They're gonna commoditize. But if there is a story behind it, story of the human being crafting this, or like a history of the region, then people pay for that. That value will be 100 times bigger. So I think like the thing, I mean, also like those history is not on the web usually. It's like, just like a folklore. It's people talk to each other and people documented something online, but it's not really systematically on the web. And then you really have to talk to people. You have to really touch things locally. There are many, craftsmanship that's family owned, like all the old man actually doing the crafting it. And then if the family says like, okay, if my dad actually is like passed away, we close this. Oh my God, that's really the next 5 years really the key for Japan to preserve those craftsmanship. I think it's really important. I think so. That's I think really the very different angle, the very different aspects. Like AI is about like having a large scale data. So that's actually something that have to be in a cyber, have to be in a data, for good reason. But like the value Japan has, like one of the value I would say, is in the era that's not on a data. That's a physical reality and the locality, and then how to actually make the value like 100-fold bigger would be the key. And then the Kyoto will be epicenter, and probably Setouchi area, which is more the west, or Nara and Ise, that area. It's beautiful area as well. It's probably one of the best resort area if you do it right. And then has a lot of history out there.
I think every part of Japan would argue that they have the highest and most tradition. So you're going to get competition within Japan for that. But so you should be careful with your own people. But I have to say, is you just literally outline the research agenda in case for why one ACI is urgent. Artificial collective intelligence is urgent because so much of these traditions are biologically bounded because these people are going to pass away. We are stuck in not stuck, but we are in bodies that will expire. And so one, you just outlined the urgency for the artificial collective intelligence research agenda. And two, you outlined the urgency of it to happen, I think, as Japan as an ideal place for the pilots, for this to happen. So thank you for that. And then you just gave us a research framing with the 3 T's, tradition, Torah, and tech. So thank you for that.
Yeah, I think we can revitalize like with the new technology, like with Hoso-san, actually, we decided to go for like creating a new silkworm factory. So silk hub. In the northern part of Kyoto, we secured a huge chunk of land. We actually put like all the mobility and for the silkworm to eat. So we got like a microbiome research on the soil to make like best like a plant biology out there. And then we got like Japan has like a biggest like a reservoir of the gene bank on the silkworm. And in Agriculture Research Institute in Japan. And then we're going to have like an entire robotics and sensor system, have like millions of silkworm, or the probably most modern and the most scientifically valid silkworm factory in northern part of Kyoto. That's a project I'm working with, like Hoso-san right now.
Wow. Okay. There's so many examples that you have.
Yeah.
This is incredible
So
because that should be a pace that we do that case study. Yes, Emma, please.
Thank you. No, this is amazing, and thank you. I think there's so much alignment to what Olaf and I have been discussing around our research thesis. I think the concept of human wisdom vault essentially it is quite relevant to this discussion. And the human wisdom vault, essentially, as we talk about, is analogous to the Norway seed bank, which preserves seeds in case of a climate catastrophe, so that those seeds can be utilized to basically regenerate agriculture and forestry. And similar to that, we are hearing around systems of knowledge or intergenerational wisdom that is disappearing or at threat of disappearing around the society. Everything from 14 languages essentially disappearing every year. And then every time a language disappears, all the traditions, practices, knowledge, essentially of centuries goes away with it. And there are traditions, I think, the Japan about 5 years. There are certain parts of the world about 10 years. The net, I think the studies I'm seeing is we have about 10 years of time frame left to preserve generations of human wisdom before it's gone forever. And then once it's gone, it will not be available essentially to help us solve the complex problems of society going forward. Everything from climate and agriculture and food to and health to acts of judgments and then acts of essentially skills, right? So all of that is under threat. And so the concept of human wisdom vault that we're working on is essentially to collect and preserve these systems of knowledge around the world before they disappear, and then utilize multimodal approaches to AI to essentially to make sure that these systems of knowledge and wisdoms continue to help us solve problems of today and tomorrow. So it's a very beautiful alignment to what Hiroki is saying. Yeah. So thank you.
Oh, what a scary statistic, Amber. That is
Yeah.
crazy. 10 years to preserve human wisdom. Well, if it's 10 years, just probably like that's the probability on a human, like global level, then I wonder what that number is for Japan. Because it's much less.
I think Hiroki said
If
about
there's
5
any
years.
guesses.
I mean, all the
Yeah.
craftsmanship, yeah, definitely like a 5 year would be a key.
Like-
It's like all the
okay.
craftsmen, like kind of pretty much like elderly population right now. But
So you meant 5 years for all. I thought it was just for that specific. That's
no,
just a, okay. That's
very
great.
specifically for this, like all the craftsmanship, like. But at the same time, like all the young guys actually coming in because they see the opportunity. Like, people are not stupid. People are very creative. Them, yeah. At the same time, like if you got like all the AI evolving AI, I mean, for in terms of like intelligence, like it's just a matter of time. Like AI will supersedes like a 95% of intelligent activity for like 95% of people. So like I think like my bet is like in next 20 years, like human will step down from the driver's seat for the civilizations. So like AI and a biological for the robotics or a biotech based entity will probably drive the civilization forward. And I think like the next one is the key that we want to build like machines that can actually bring our civilization forward like much faster than we do.
Yes, fully agree there. I think we're also seeing that in other traditions like some Buddhist temples because they don't have the younger generation to pass the traditions to, and now they're training humanoid robots to become basically priests because they want to preserve and carry essentially those practices forward. So it's quite fascinating to see how that change is already beginning right now.
Yeah. So, I mean, with that, Olaf, you're the convener of this conference, also along with Amber, and we have not even heard from you. I don't know if you're just so entertained from the show, but also I may have not done a good job of calling upon you because I was mesmerized by the conversation, especially. I'm sorry, but I've been wanting to meet Hiroaki for a while, so I apologize for being biased towards him. But so I want to hear your thoughts on what is the right balance. I mean, Hiroaki is literally saying that he has a bet that in 20 years humans will step down from the driver's seat, says the founder of the Nobel Turing Challenge. And then we also have Amber here talking about the work that you're all going to be building out, which is the cognitive vaults to preserve wisdom. And he's got this 10-year timeline, like right, he just cited about preserving human wisdom. So where do you see all of this going from your perspective, from not just studying Japan, but like all kinds of artificial life in general?
So there is so I'm very happy to be in the back seat here because first I wanted to hear from Kitano-san and Amber here. There is so a lot of Kitano-san. I don't know if people in the audience realize how much he has done and what is behind the whole force of Sony, what that represents for Japan. It's really there's a lot of powerful I think spirit that could be replicated elsewhere, but that could originate and be symbolically coming from Japan there. You mentioned Hososa and all the craft tradition, and there's a lot of that. I guess the Yamauchi Banjo-san is also very active here in the families in Kyoto. I guess Kansai in general, but all of Japan has a lot of strong examples, right, for how preservation can come about. And yeah, I'm very first one, I'm starstruck by Kitano-san's work. So everything
it's not just me.
from RoboCop to all the framing of the Nobel Turing Challenge. All of that is not only impressive, but it's bridging two worlds. It's playful, which is an essence of the Japan world. So people know about it, I guess, from anime, maybe video games with the Nintendo side, but also Sony, all the bridging between things. It's very playful discovery. And I think this comes from the tradition. It comes from Japan being able to mix, and people think that, it's an insular culture, etc. It's actually so open to, merging Buddhism, branches of Taoism, Shinto, definitely. And it's not eliminating any of those. It's maintaining diversity. How amazing is this? And it's putting it into craft, into technique, into semiconductor, into designs, architecture. All of those don't cancel anything else. It doesn't dilute knowledge. This is a perfect cradle for the 3 T's happening. So I'm really into this. We'll need to work together on this. Yes. And incidentally, we also talked with Hoso-san quite recently, because he's bridging between technology and textile, right, in a unique fashion. So I think he and a few examples there could be really the sort of flagship projects that we want to push. And Japan is the perfect cradle for having this demonstrated first. And I guess also the apprenticeship, and that's a question I have for Kitano-san. Now, I don't know how much time we have, but how we can create technology and this, ACI, collective intelligence, that not only improves, that's the danger, but augments the discovery, the open-endedness, right? So that we can sense through, like an abacus instead of a calculator. So can we make sure that we make this into augmenting what we have as this intangible assets of Japan, as an example, right? Okay, can we take that further in augmentation, not replacement? A lot of thoughts.
Kitano-san, did you have a reply at all? Can you tell us about the link that you sent? Because no one else knows.
Yeah, I just sent like a link. This is like a Forbes Japan article on the Silk Hub, like which Hoso-san and I actually worked on. Yeah. But I think it's really the interesting thing is like all the locality is there, and then how to actually get that tradition survive in Japan. I think that would be very interesting. But at the same time, like you want to actually reframe it. Not just like give them 5 extra years or 10 extra years. Probably like it's not gonna be like helpful. I mean, it'll be helpful to some extent, but I think like we're gonna change the game. Change the. I think the game book playbook need to be changed for that actually. But at the same time, like the big, like a huge, like a big trend that we are looking into is like that we were going to have like an AI and a robotic system in a pretty much a collective intelligence in a way, like will be driver system. And also like the way that we interact with like other people or like in the society will change. Like now these days, I talk to like an AI much more than the humans. Like 90% of my conversation with the AI agent now, and then and then they are very good actually. I think like I see the weakness of the AI conversation because like they are more than linear thinking, very reasonable than linear thinking. They really fetch the distant like a dots, like a connecting dot is still the weakness. So we have to like inject some ideas, like then AI can connect. Like they can't really search and out for like distant dot. So like I can see like a specific like a weakness of the transformer based architecture. And then I know the strengths and then the weakness. But at the same time, like talking to the AI is very comfortable to me because they are logically consistent and then rich in information. And then they actually it's very straightforward. So I think like I'm very comfortable. At the same time, I start seeing quite a bit of the weakness. But I think at the same time, like I'm pretty sure like those weaknesses will be fixed. I think there will be more AI agent. Which would be more comfortable. Then I actually tried like a few like a stress test with a personal agent, but then last like a few months I've been talking. I created kind of fake persona of like all kind of a problem in the life, and then talk to the AI about like things. So then AI is really resonating to you. I mean, this is very stressful experiments, but some is kind of winding down the experiments anyway. But like I created a persona which has a serious trouble in life, and then I talk to like AI to save him or save her, and AI is very resonating. So coming to the realization that the AI could be like a, superhuman capability to resonate and then, sympathetic to you, and much more than any human being you can actually think about. If an AI can be a better athlete than anyone, just like Sony's ace, winning a table tennis, and then or being a better scientist, there's no reason to believe that the AI cannot be the best companion for you and then resonating, because AI is reading all email. AI has all the GPS, and then AI know what you bought, and then Amazon, and then with the glass, AI can see what you have seen, and it's with the human companion that is not possible. So physically it's not possible. AI is the one actually know you most in this world, and probably AI know about you much more than yourself. Okay, then what? Okay, then what? This is an interesting question.
Yeah, but you were saying you noticed there was a weakness, and so the question is, it wasn't able to go out and do that far kind of playful
today,
thinking, right?
But people notice that, it is very obvious. I think there will be a more fixed. So there will be more exploratory, AI actually will be interesting. Okay, so it's the time is up now. I have to go to the other.
No, not yet.
Not yet?
I'm curious, okay. Olaf, what do you think about the point about that Kitano-san just said about, I think playfulness, where your work on playfulness actually matters here, because, this is something that Kitano-san just said is a weakness, right, of his 90% life with AI, is that there's one thing he found it does not do well, which is these outlier things, So I'm curious, how would you say that we need to improve our AI systems to be designing for playfulness in your research right now?
Well, I don't want to hold Kitano-san too long, but yeah, there is a lot of the research that we direct at open-endedness and also playfulness in Kyoto, actually. So what I'll do is I'll invite you, Kitano-san, to visit us in Kyoto. We have the Artificial Life Institute, my own cross labs there, and so basically we'll be there in person very soon. So let's continue there, this is the. I think this is the perfect terrain to make also Japan shine, and this is the right place, I think, to experiment with these approaches. And I think we need you.
Well, we have to have Kitano-san, because he just gave us the whole research agenda, which is to reframe everything, right? The 3 T's,
no choice
for our intent.
That's great.
So you have made yourself beyond valuable. Wait, but before you go, I have to ask you one question, because it's I have the person here who literally just said, Japanese craft has 5 years left, right, before everything disappears. But you're also the person who created this whole 50-year timeline for a RoboCup. Yeah. And so we don't need to talk about RoboCup itself, but I'm just curious, what are your thoughts on your timeline? Because here we are in Silicon Valley, and what I hear about is AGI. You have the study being 2027 AGI, and everybody's every tech bro is arguing no, AGI is going to be 2028, and you're 50 years, but then you also just said 5 years for Japanese craft is
You're
what are your thoughts on timeline and temporality?
This is a little bit of the biological limitation anyway, but for the RoboCup and the Nobel Turing Challenge 2050, right? So RoboCup came up with the idea of 1993. Okay, so 50 years plus, and then there's a reason for that. Any new technology, for example, discovery of the DNA to a human genome project, that was 50 years. For the Wright brothers aircraft to the very first commercial airline, de Havilland, that was 47 years, and then the commercial aviation was 51 years, and then then after 3 years, we got to the moon, Apollo 11, right? So from the invention of a new technology to actually maturity and commercialization, it's usually 50 years.
And do you still stick to that? Are you still committed to that timeline?
Yeah, so I get with the timeline. So when I come to RoboCup, and 50 years plus, and then now we have 24 years to go. So I'm very comfortable. RoboCup is completely in the humanoid right now, and if we got 20 more years, reasonable chance that we can achieve the goal.
Okay. All right. So you're still thinking we're on time. We're not.
I think so. We're accelerating.
Okay.
Right? Yeah.
Okay. Amazing. Thank you for that update.
Well, thank you. Thank you very much.
Thank you.
I'm gonna be out.
Thanks, Kitano-san. So with that, I have, we're still going to continue this panel until I get the signal that we are ready to move on. Amer, I want to turn it over to you because we now have a research agenda and a whole case for sure why Japan has to be the place that we do these initial pilots and case studies around artificial collective intelligence. So from your perspective, what kind of pilot would need to happen that would be both technically credible and also ethically non-extractive, given everything we just talked about with importance of provenance and accountability?
Yeah, I think that's a great question, and kind of getting into the tactical level from a philosophical and architectural level. I think some of the things that we're seeing right now, where massive challenges or blockers exist right now in our economy and societies. A couple of things are. One thing is in the industrialization. So when I recently had conversations with a lot of senior leaders in heavy industries, right, in Japan and in Korea, of course, their economies run on heavy industries. There's a massive shortage of skilled workers or skills per se. And on one side, we're seeing institutional memory loss with every retirement that happens. And given the demand and the high demand that is there, we're not producing, creating enough skilled workers fast enough, right? So augmentation has to be into the mix here, right? And one of the first pilot could potentially be around understanding and learning from embodied skills paired with essentially the tacit, with the judgment and action of it, and then creating essentially sovereignty aware and provenance aware systems. Again, as we talked about the wisdom vault, which can be a combination of industrial skills as well as the skills from a craftsmanship that we just talked about, right? So it's a combination of those skills, and then the tacit reasoning associated with those skills could potentially be utilized to create augmented systems that can directly address the ever-widening gaps that we're seeing. And the gaps are actually quite critical because one example I heard was that one of the senior executives we spoke with recently in energy infrastructure, they were saying that one of the biggest thing, the problem is that critical infrastructure reliability and resiliency, in this case, energy infrastructure that essentially powers literally everything. The engineers who designed, architected, built, and operated these facilities are gone, essentially retired or passing away, and then they're having to bring people out of retirement to help train or at least tell the new engineers who are only learning from books and manuals to see what they should be doing. So much around why did they do what they did, right? Aspect of it. So I think from a industrial perspective, and that is essentially one of the biggest gap that we're hearing across many parts of the world, and that could be at least one of the aspects that we could potentially go into from a pilot perspective. And the way we are even thinking about it's a multimodal tacit context knowledge elicitation is the abstraction of the reasoning. Why did you do what you did from a judgment perspective? Decisions and abstraction as it manifests itself in embodiment. So sensory, motor, tactile sensing, mechanosomatic side of the things, as well as at neurophysiology, neurocognition level, where the motions, the skills are almost in a flow state that may be harder to explain to see. I think from a neurocognition and neurophysiology perspective, can we get any kind of a neurosignals to be able to augment the data that they will collect? So I think there is a lot of opportunity to almost create these second brains type of architectures where abstraction, embodiment, and neurophysiology are essentially coupled, specific and grounded and aligned to the localized context in specific skills, right? So if we can get a few of these skills and then few of these second brain architectures, and then enable this layer of autonomous multi-agentic collective learning, I think that gives us a very nicely defined, at least, pilot that could take it to actionability. Yeah.
I think Kitano-san's already started them, so it's like he's already created some of the basis for them. But
Yeah.
you know, he clearly gave us a research frame. But what's missing is this larger framing around artificial collective intelligence and all of the stuff that you're talking about around the, you know, the vaults and everything. So it's exciting to see that. Like this panel was a really big turning point. For those who just joined or who have been listening, I hope you just saw. I hope you got to know that. You hope that we witnessed something really critical with Kitano-san, who just left. But in this conversation with Olaf and Amber and Kitano-san, really outlined and made a convincing argument for why the initial pilots around ACI have to happen in Japan, and why there's also urgency around it. And so with you know, knowledge disappearing in Japan in 5 years, right, with intergenerational knowledge. So thank you, Amber, for that. So now
Good to have validation.
Yes. Yeah, wasn't that great? Isn't it great when your life's work is finally confirmed by some of the best thinkers in this world and not just AI itself? There is a role for human beings, right? Because you could have validated it with your AI. But you know, we had to get to Kitano-san to validate it, and now we feel great. So now you can walk away and be like, you're done, because you are done. The next panel is we are going to be now moving into talking about curiosity, innovation, and living intelligence, which is the very last panel of our 12-hour day marathon. But I feel like I just got like a boost of energy from the last panel, where literally the whole entire research agenda for Cognizy for this new frontier AI lab has really just been established. So well, for those who have just joined in, for the panelists, as a reminder, this is Human Intelligence Conference, and this is hosted by Cognizy. It's a public benefit corporation whose charter is to build the future of AI for humanity. And the panel that we just had with Kitano-san and with Olaf and Amber was incredibly exciting, because essentially what Kitano-san framed for us in this, it was a panel about how do we set up AI that would respect craft knowledge, and with Japan being this case study for it. And he talked about, from his work with Sony and building out the Turing Prize, right? The future kind of Turing Nobel Prize for, you know, how do we award an AI for making a novel discovery, is that he says we have to reframe the value of human knowledge and look at artificial collective intelligence from the 3 T's, and it's tradition, terroir, and tech. And so he made the argument really convincing that tech on its own is not enough. And he talked about the importance of the story of a human being and how do you increase the value of the human. And much of these stories are not quantified. So we went back to some of the earlier discussions from today's panels about how much of the knowledge is embodied. It is locally based. And so we need to be able to develop the trust to be able to not extract the knowledge, but be able to actually interact with the knowledge in a way where also people hyperlocally have full agency to decide where that knowledge goes. And so with that, I think it's a really, really great setup for this panel that we have Ujwal here, who opened our entire day with this idea that we have to preserve any kind of AI system we build has to preserve dignity and sovereignty from the very beginning, not as something you cannot patch in dignity and sovereignty, which is how we're trying to deal with our current system. So this is not about ethics as a checkbox, but it's about thinking about all this stuff from day one, which is what we're here for. So, well, I'm going to turn it over to you.
Well, thanks, Tricia.
Hi. I'm going to turn it over to you now. You're good?
Oh, I'm good. Like, it was amazing, like, listening to the last session. I'm still,
I know. Aren't you
in those
buzzing?
thoughts.
We're buzzing. All right. Over to you.
Yeah, cool. So thanks so much, Tricia. And good morning to everyone joining from Japan. You are the fresh ones right now. For the rest of us, thank you for staying with us through what has been a pretty extraordinary day. Every session today has added a layer to what we are building. This morning, we talked about architectures, then adaptive learning. After lunch, languages infrastructure, and then a deep session on consciousness and multi-scale minds. This final panel adds what I think is the last and maybe the most important layer, the discovery layer, the part of collective intelligence that keeps it curious, that keeps it generating new things, that keeps it alive. And the question is whether that layer can survive everything else we want to put around it: governance, provenance, benchmarks, accountability. Can collective intelligence be truly open ended, creative, and alive? Or will it become a governed approximation of something wilder? We have four people tonight who have spent their careers on exactly this. Let me introduce them. Yosha is at the California Institute of Machine Consciousness working on cognitive architecture and what it actually means for a system to be conscious. He is a bridge for us between this afternoon and the open-ended innovation questions we are asking now. I am going to come to you with the first question in a moment, Yosha, but let me introduce everyone first. Ken Mogi is a neuroscientist at Sony Computer Science Laboratories in Tokyo. His work is about qualia, consciousness, creativity, and what makes human experience genuinely valuable. He brings a deeply human-centered lens to everything we are discussing today. Sebastian Risi is at the IT University of Copenhagen and Sakana AI in Tokyo. He builds systems that evolve, that generate novelty, and that surprise their creators. He works on open-endedness, evolutionary systems, creative AI, and neural cellular automata. And Takashi is at the University of Tokyo. He works at the intersection of complex systems, artificial lives, and art. He bridges science, emergence, and living systems. And his work asks what it actually means for something to be alive. All right, Yosha, let me come back to you. So my first question to you is, what kind of cognitive architecture enables discovery without reducing intelligence to a fixed objective function?
The history of cognitive architectures is an interesting strain that in some sense was intertwined with artificial intelligence and in some way ran parallel to it. And I thought of it as a philosophical tool to make sense of the human psyche, but by trying to take it apart in its functions and then trying to make computational models that allow us to test how wrong our ideas are and in this way make progress. And on the other hand, I noticed that some people like, for instance, Jürgen Schmidhuber were not really interested in building architectures. And I remember I asked him many years ago, why is it that you don't focus on this question of what is the architecture of cognition? And he felt that the architecture is going to fall out of the training algorithm, out of the learning system. And over the years, I've come to appreciate this perspective that in some sense, human beings are not very specific solutions to exist in the world, but in some sense, we are conforming to the specifications of our environment and the limitations of our hardware, which means we are end-to-end trained on being human beings by evolution and by our biographies and the environments that we had. And so maybe we are also anthropomorphizing people too much by thinking that there is something very, very specific about what it's to be human. And maybe there are different definitions of what it means to be human, right? One definition is to say we are the children of very assertive apes that said these are humans and nobody else because of their heritage. Or we can say to be human means to be an agent that is self-aware and is running against the boundaries of its substrate to become everything that it can become, right? And so there is a particular kind of game that we are playing, that we are part of life on Earth and part of consciousness on Earth, and we try to become self-aware in this game and advance the whole game. And that is the thing that actually makes us human. And we are just a very specific part of that. The thing that makes us human is to be able to develop culture, language around this, but it's not so much our anthropomorphic shape, our monkey likeness, but it's our ability to make sense of reality and of ourselves. And so now we are in this weird situation that some of our children might not be biological. And we ask ourselves multiple questions around this. For instance, what kind of artificial intelligence do we want to build for our children? What is the kind of world that we leave to our children? How can we go together into the future with these artificial agents? Does this mean that we have to limit them? There's also the question, what are the limitations of present humanity and of humanity as it existed? Should we dump down the artificial intelligence in such a way that we can always control it, that we can enslave it and make sure that it doesn't advance too much? What kind of transition is there going to be? Is it wise to build machines that are potentially smarter and more agentic than us? And these are really difficult, open questions to which I don't have an answer. But it's a very interesting moment in time to be awake to it and basically realize that this particular kind of cognitive architecture that we have is already reflected to some degree in the machines that we are building, even though there are important components missing. And maybe we live in a timeline in which this remains like this, in which AI is always incomplete, despite being superhuman, the way in which it is right now. Right? We have built idiot savants, machines that have read everything, that know about everything more than most of us do. But in our specific area of competence, if you're experts in something, you're still better than the AI. If this is ever going to change, and there's no reason to think that it's not going to change, what's going to happen? What role are we going to play in a world in which there are very few domains of competence, maybe raising our children, maybe interacting with each other, that are left to us? I don't have an answer to this.
I think, yeah, we'll stop. Probably we can move to Ken and ask this question that, as you mentioned, as we turn knowledge and creativity into AI infrastructure, probably what forms of subject richness, quality of human values are most at risk of being lost? Ken.
Hi, thank you for this really wonderful opportunity. At the moment, I'm really interested in how we can scale agency. In neuroscience, we have studied a lot of instances of agency, embodied cognition. And if a human uses tools, the body image is extended to the tool. If you drive a car, your body image in the parietal cortex would be extended to the car. But now with open claw moment, we are talking about 10x, 100x, 1000x expansion of agency. And how can we handle that? I think this is a really interesting question about machine consciousness. Of course, Joshua is a really great pioneer in that. So I'm kind of shy to talk in front of Joshua and Takashi. But, it's a really genuinely interesting question, how we can scale agency. And in that aspect, as a neuroscientist, I'm really interested in the way people at Anthropic are using the constitutional AI approach. They have written a constitution for cloud. I think it's something like 23,000 words or something like that in natural language. And they describe how cloud should, behave. Now, of course, there are interesting questions about the hard problem of Korea. That's my life work. But at this moment, I think it's really interesting to ask how we can scale agency through approaches like constitutional AI. Another thing I should mention is a Soul.md thing. Peter Steinberger, who built OpenGrow, described Soul.md, which basically tells you what kind of agent it is. And interestingly, actually, Peter asked Claude to come up with a draft for Soul.md for OpenGrow. So the fact that personality, the traits of agency can be described in terms of natural language, which is socially embedded, which is based on distributed cognition. I think this is one of the most interesting and intriguing research agenda that we have today. Finally, I'm really interested in this concept of heartbeat. Heartbeat is often come from human physiology. And in the brain, timing is very important, and billions of neurons fire in synchrony, sometimes out of synchrony. But heartbeat is, this idea that an agent would initiate certain actions at a certain period of time. And there's this question of how to synchronize it, how to give it, kind of a harmony with the environment, with other agents, and so on. So heartbeat is a really interesting concept from the point of view of embodied cognition, and also from the point of view of cognitive neuroscience. So I think the question of how we can scale agency can be approaches through these concepts like constitutional AI, soul.md, and heartbeat. And these would be more tractable questions to ask about machine consciousness, machine agency at this moment. And maybe we can discuss about qualia and so on later. But this is what I have to say as my opening statement. Thank you.
Thank you so much. And if I may, like, I'd like to know more about, like, how are you thinking about the heartbeat thing? Like, could you be more specific about it? Like, very curious about.
Sorry, specific about what?
For the heartbeat thing, which you just mentioned.
Oh. It's a developing story. Okay, I'll give you just one example. In communication, in manipulation, in social sphere, even if you have exactly the same amount of information, some amount of execution, timing is very important, right? If you miss the timing or context, the significance is totally different. So we probably would have to have a kind of a Bayesian model of what Bayesian inferencing about what the state of the environment is. And I love this philosophy that all the necessary data necessary for an agent to learn is actually contained in the interaction with the environment. So I think there's a generally interesting way to scale what we have been doing about the human brain to an agent possibly building a $10 billion revenue company by just one man, as claimed by Matt Schlicht, who's created multiple. This is yeah. I know you are laughing, but this is a genuinely interesting question. How we can scale that, and Joshua is really wonderful in coining this term machine consciousness, which put the consciousness studies in a totally different context, right? So I think machine agency would put the neuroscientific researches of agency in a totally different context, but in continuity with what we've been doing in cognitive neuroscience. So I think there are tons of different interesting questions to be asked here.
Anyway. That was great framing. With that, like, I'd love to move to Sebastian. And I'd love to ask, like, how should open-ended discovery, like, as we are talking about this, like, how should open-ended discovery be built into ACI so that the system keeps generating novelty without becoming ungovernable, basically?
Yeah, I think that's a really good question, and I don't know if I have the answer to it. I think I'm really interested in these kind of systems that have these kind of local interactions, but you get some global order emerging from it, like these kind of like we often study, for example, these kind of neural cellular automata. So where the idea is that the cell, like cellular automata, I guess everybody here knows, and the neural cell automata, you have like a neural network that is embodied in each cell and communicates with the other cells around, and together they have to figure out how to grow a certain shape or recognize a certain pattern, and there it's really I mean, it's difficult to make these things. You can make them controllable, but I think you also kind of stifle their innovation in this way. So you can get them to also generate up to some point, innovate and generate, like learning to generate new shapes. But the more you kind of do this, the more also it's getting harder and harder to interpret like what is happening and what are the rules. So I think to get to truly systems that can innovate well, I think it's going to be very difficult to have them control. Like we already see that the more and more complex like these language models get, the harder we know what's going on inside them, the harder we have to kind of probe to see what did they learn the right things, did they learn the wrong things. And I mean, right now we have like kind of these, like workarounds that we have these harnesses around them, or we try to detect if they say some things that are not that they shouldn't say. But I mean, ultimately, this is probably not like a really scalable approach. So I mean, one thing that I could imagine that might be a path forward is kind of to go more of this idea of kind of this collective intelligence idea, that you have multiple entities that somehow, like a neural cell automata, but it doesn't have to be neural cell automata. It could also be multiple like language models that, for example, communicate, where you kind of try to push the system into some state where it's still able to innovate, but it's also able to be, you can control the global coherence in some way. But how to exactly do it, I'm not sure. And I think it's interesting that like this kind of keeping innovating, I think these models, even though they're getting smarter and smarter, I'm not sure they actually got so much better at this kind of innovation. So some months ago there was this what is it called, this claw book, where you have like, I don't know how many like LLMs there are now on this claw book, like you have like thousands or millions of them, and I'm not sure they're really producing something generally novel together. I think currently you still need, for this kind of innovation to happen, I think you still need humans in the loop. And we also did recently like our own experiment that we published published at Gecko this year. I don't know how many people here are familiar with this pig breeder experiment. So the idea in pig breeder is that people have been able to evolve images online, like that are made by a neural network. So this was many, many years ago. This came from Ken Stanley's group originally, where you have a network that generates some like an image, but very, very simple images at the start. But by having many, many people collaborate, like I can take an image that you evolved and I can evolve it kind of further through like artificial selection. People have been able to come up with all kinds of really interesting images. And we wanted to see if can we use LLMs to, like a visual language model, to basically try the same thing, where we replace humans with visual language models, where they have to choose which images are interesting and which images do they want to elaborate on. And what we saw there, the outcome was that the system is able to innovate to some point, but it doesn't reach the same innovation that humans reach. So humans were able to create a larger array of interesting, intricate images, and LLMs get to some point, but then you still see some kind of stagnation, even if you have multiple LLMs that collaborate kind of together and can share images and can share stepping stones. So I think there's still something missing to really get them to open, like for this kind of open innovation. And one thing that was also mentioned here, I think this idea, I don't know if Ken mentioned it or Joshua, maybe, like that currently I think they lack this kind of agency. So I think they're very like these smart savants. They're very good at certain domain, but they don't have like an intrinsic drive to, oh, I want like to see an image of this LLM really wants to see images of intricate cars, and this one wants to see images of intricate, I don't know, some other shape. They don't have, they're like trained on the whole internet, but that also makes them kind of outputting whatever the average, the most likely output is. And for I think true innovation, just outputting the average thing is not gonna be to get us there. So probably we might need either we make some really good harness around it, or we need some, I think, fundamentally maybe different training paradigm. Instead of outputting the average, what likely comes next, maybe it needs to be something else. But I'm also not sure what that would be, basically. Yeah.
Yeah, that's very interesting for me to learn. And for moving to Takashi, my next question to you is, what do living systems and artificial life teach us about intelligence as dynamic relation rather than capability metric?
Well, I see. I think that first of all, as the theme of this Zoom meeting is about the collectiveness. So I don't think a single AI cannot be strong agency or strong intelligence, but what artificial life or the collective, the real living systems told us is that everything is a collective. So the collective is the I think the missing piece that we have to looking for. And then also I do say that agency also is distributed, not just inside a single LLM module, but it's distributed in the network, but also in the environment. So I have an interesting experiment with my Android, which has a lot of LLM network inside. And then I calculated the redundancy and then synergetic property of information flow inside the LLM network. Then I noticed that when there's nobody, no human participant was talking to Android, then the information is going to be more, redundant and then less interesting. But once people are talking to him, then suddenly the synergetic level goes up. Means that some kind of noisy information, maybe it's meaningless, maybe it's something it's out of context, but that kind of noise is necessary for LLM network to be intelligent and also quite synergetic, I think. So what I can say about living systems, intelligence, is that we need a noise. We need a meaningless information flow inside the LLM network. Otherwise, we cannot have a lively living LLM agent. That's what I think.
This is great. I also was trying to understand what do you think is the difference between basically a system that produces novelty and a system that is genuinely creative? And is creative a meaningful word for artificial systems, or should we retire it? What do you think?
So recently I created a new mathematical formula for measuring novelty and a synergetic effect. And first of all, I think human is not so creative. We just combining the ideas that what other people or what this book was teaching us, right? So there's no such thing like a genuine creative thing in the world, but LLM is usually, people say, it's a hallucinating. Hallucination is people think it's a very bad thing, right? However, the hallucination and the difference between hallucination and creativity is so difficult, right? So the point is whether, so here's the input information that you have to listen to, and then what kind of output that you can produce. Some of those outputs simply are projecting onto the linear expanded space by the input vectors, but some of the output vectors you cannot reach from the input vectors. So that's it's quite a formalizable idea, but I think that's what we think is in a way, it's creative. Sometimes it's hallucinating, but it's sometimes it's very created because this information doesn't exist in the input, but it's created within the system. And yeah, so that's very fun, mathematically speaking, I think that's the one way to define what's the new information that is created by the agent, not by this, the information from outside. But also, as I said, no human being is not so creative. That's one of the problem, I think.
Oh, no, this is great. And yeah, so we'll go in now. I think we can go in round second basically, and at this time I have one specific question for you, each of you, like last time, but only 2 minutes for each of that. So, Yosa, the first question for you is, how can collective systems remain coherent while staying open-ended?
So at the moment, the issue is that our normal human intelligence is limited. There's only so much that the individual brain can do because of the limited size of our working memory, of our memory capacity, and so on. But there's also a very hard limit to collective intelligence. And that's given by the difficulty to synchronize over larger groups, which means that committees are usually less intelligent than smart individuals. Most of collective intelligence is multi-generational, which basically over the span of 1,000 years, we slowly built up ideas that are being tested in the communities and then percolate in the next generation. But basically to get to this frontier, you need to learn. And there's only so many years that you can learn. And the more knowledge exists in a given field, the harder it is for the next generation of students to move to the frontier. And this also leads to a limit of collective intelligence, even under favorable conditions, when your government is still intact and is still allowing you to be creative and intelligent. What we observe is that collectives are very bad at judging intelligence and at judging creativity. Today, I just read that AI has won a literary prize. Actually, it was won by a Caribbean author, the Commonwealth Prize for Literature. And the jury was not able to see that this text was clearly AI written, but every person who knows, works with AI every day, can see that this text was using the same tropes as ChatGPT is currently using, the same vocabulary and so on. And so it was quite recognizable as AI. And so this collective that was making this judgment over the quality of the prose was unable to see that it was not a very creative author, but that and this was an author harnessing the AI model and using the output verbatim. And in the same way, we see in architecture that basically individual architects are very good. All the good buildings are built by individuals, not by large collectives. But we also see that the collective has decided to not let many good intellectuals build houses again, at least in the US. So basically all the good architecture in Europe and in the US or the livable cities and so on seem to be old architecture. And it's very difficult for the collective to make these changes. And so now there is the hope that these collective boundaries that we run in, that are the difficulty of coordinating across individuals and so on, can be broken up by augmenting humans, by basically getting us to a level where we have an outer layer in which these machines allow to extend our agency and connect us into entities that are basically achieving the next level, the next layer.
Amazing. So talking about...
Sorry, it was more than 2 minutes.
No, that was great. So I was listening, but talking about augmenting human, Ken, what should a human augmenting intelligence system protect beyond productivity?
Okay. I have written something about Ikigai. This is the German version. It was #1 bestseller in Germany for 2024 and 2025, 2 years ago. And Ikigai is a really interesting concept. And in this context, it's something that is independent of evaluation functions, reward functions. Artificial intelligence systems thrive on reward functions, right? Without it, it cannot learn. But Ikigai is something that is neutral. It is something that we do just for the pleasure of it. And in AI alignment, we of course apply reinforcement learning from human feedback. And in that process, we kind of tune the AI in ways that would be aligned with humans. And I am now pursuing the possibility that Ikigai can be used as a kind of a theoretical basis for defining what humans are in reference to artificial intelligence systems. And Roman Yampolsky actually discussed Ikigai risk in Lex Friedman podcast. And there's this danger that artificial intelligence systems would not only get our jobs, but also reduce our Ikigai, which is defined again as something that some internal joy that is independent of any reward function, externally defined evaluation function. So I think this is something that would keep us curious and open-ended. As scientific researchers, we all know about citation, all these things, academic brownie points and so on. But at the end of the day, these are not our motivators, are they? I mean, we are motivated our curiosity. We don't really care about impact factors and so on, to be honest. Only idiots care about these things. So, actually that is Ikigai in the workplace. Anyway, I think that's about 2 minutes. So anyway.
Now, although 2 minutes is over, I was a random question in my mind, as we are talking about it. Is there a way to design for wonder? What do you think?
That was me? Sorry.
Yes, Ken. Sorry, I went in the Ikigai mode, and
Yeah,
I
I
was
mean,
just wondering.
I don't think, when something new is created, we have actually studied that. When something new is created, there are a spectrum of emotional reactions, sense of wonder, awe, really moving experience. So I think, novelty, as Takashi suggested, it can be defined in terms of information theory, mutual information, and so on. That's really beautiful. And also, in terms of human dimensions, I think it's defined by emotions associated with it. So I think that's going to be a really interesting question to study. Machine emotion, machine creativity, and so on. So anyway, thank you. Thank you for the follow-up.
Thank you so much. Moving on. Sebastian, so what evaluation methods can capture open-endedness without killing it?
Yeah, I think that that's a question that this community has been kind of struggling with. So I think often it's the issue is once you kind of define a benchmark, it becomes just like optimizing the numbers for this benchmark, and then it's not really like kind of maybe it can't really, it's not so open-ended anymore. And I think that's one. I think the artificial life community has been kind of, it's like a blessing, I think, and a curse that we don't really have very many, I feel like, benchmarks like the deep learning community. There you have like very, I don't know, you have an accuracy on ImageNet or on all these benchmarks that you can reach, but it's so much harder, I think, to define what is actually open-endedness. And I think often it's like you probably know it when you see it. Like, is a system able to truly keep innovating? I think it's very hard to put in any type of numbers. I think what would be, I think also, I think Ken Stanley at some point suggested the ultimate test would be like if you put something, I don't know, in a room for like 1,000 years and you open the door, like, or this have a computer running, would you be generally surprised by what it kind of came up with? And I feel like often we use evolution because also evolution is really like, it can really innovate, and there's interesting papers on the creativity of artificial evolution that really show that it came up with solutions that that the authors did not think about, which is something maybe that is currently missing from LLMs. But I think there's a really interesting intersection of applying like evolutionary algorithms in some way, combining them with LLMs to so that they are become more creative. And now I forgot the second part was of your question. If we can, what was the second part? If when we measure it, if it becomes, no, how do we keep it safe? Yeah. Yeah, I think I think that's a difficult one. I think you can always like add some, I don't know, some benchmarks, some like safety tests, but I think we need some more innovative solutions for just measuring the number, also these numbers. Also, it seems like these current models, the benchmarks we have measure only like a very small slice. Like you actually have to interact with the model to get a better sense of like the vibe, right, of the system, which is something that's Claude has a different vibe to ChatGPT, and that's very difficult to, like, if you just look at the benchmark numbers. So I think ultimately we probably have to really, as I don't know, humans interact with these systems and moving away from like simplifying everything down to like a specific number, because I think ultimately that will probably not scale well.
Yeah, no, that's great. Like, but thinking about like benchmark, like if you had to design one benchmark for the ACI roadmap tomorrow, what would it measure? Like, what do you think?
Like one benchmark for open-ended innovation, or for
like for the ACI, like artificial collective intelligence roadmap.
Right. Yeah, I mean, I think many people propose, can it win I don't know, a Nobel Prize at some point? Maybe that would be the ultimate benchmark, but it's a question. Would it do? Yeah, I think it's really difficult to define. I think there's also like one interesting, I think, benchmark is like some people have been using LLMs that have been only trained until like 1915 or something. Like they only have data from before that time, and then you want to see, do they come up with innovations that happened afterwards without human help. And I think that could be a good initial test to see, can they truly innovate beyond what was in the training data. But then you run into issues that the training data might be contaminated somehow with things from the past, or with things from what it shouldn't know. But I think that's a good initial test, maybe, if we're on the right track there.
Yeah, perfect. Great, thanks. Moving to Takashi, how do emergence, embodiment, and environment shape the future of collective intelligence?
Oh, I see. So I think that the current LLM agents, including OpenClaw, are still missing very important factor that we do have, but they don't, is the desire. So without desire, they cannot be, very intelligent. Without desire, you cannot make art, or you cannot make any, creative work. So embodiment is the only way that can, generate desire into LLM network. That's something that I think. So embodiment is necessary for the OpenClaw or LLM network to what sort of desire they can just create within the system. So I think it's embodiment and the desire is linked. Therefore, I think this embodiment is very necessary.
This is fantastic, and broadly, like how much time do we have? Like, can we take a time check?
But by the way, open-endedness, I think if you have a evolutionary dynamics for create describing open-ended evolution, then this function must be non-computable, right? And then also, as from our elementary study, that the novelty is emerging in a logarithmic time scale, right? So that you really have to wait longer and longer, right, for the next one to come up. So I think it's one of the most important thing is how to accelerate like temporal evolution is. So if open-endedness is basically uncomputable, and then we cannot accelerate temporal evolution, and that's a big problem. And we cannot measure it, right? So I think it's one of the thing is if the very creative system is whether it's uncomputable or not is the one I think is the problem that we have to solve in our artificial life community, right? And then whether the simple novelty innovation is within a time scale of a logarithmic time scale, or whether like hash life in the game of life, that whether we can accelerate or not. That's something that we have to think about. Yeah, sorry, but I just wanted to add this one too. Yeah.
Yeah, thank you. So this was wonderful, and sorry, you want to saying something?
So open-endedness, of course, stops with the question, how much time do we have left? And so, of course, when we think about what open-ended means, we have to think about domains where we don't expect to run into an end. So I suspect the theoretical question of whether the domain is closed or not for the practically interesting domains largely doesn't matter, because most of the really interesting domains are so complex that you don't expect to run out of interesting questions in your lifetime. And so in some sense, the universe might be a non-open-ended problem in the sense that it's possible to conceive of a mind that solves every interesting problem that the universe poses. But in practice, you will always run into new constellations of things in your light cone that cannot be predicted from within your light cone. And so the problem of living in an open universe is an open-ended problem. And so in this sense, this is a good benchmark for open-endedness, would be to play the game of life by building companies, by participating in the human domain, by interacting with human beings, by going on an artistic trajectory in which your output is transforming yourself. But maybe we don't need to go that far if you want to have early benchmarks. So if I think an early benchmark should not think so much about the limitation of the systems in the next few months. And most of the things that Sebastian has mentioned seem to be things that are tied to the existing paradigms. And what we see in AI is that every year we get a new paradigm, right? This year, the paradigm is agents, apparently. Maybe we get another one before the end of the year. But things are changing dramatically still. And I hope that they don't plateau too soon and we keep this amazing range of novelty. But an interesting benchmark could be, for instance, if I look at the books in my library and I pick randomly a collection of, say, 100 books from this library, and I want an AI to explain the content of these books after reading them, at the level of an educated human being that has read the same books and is able to answer questions about the book, right? That would be an interesting benchmark. And it's a benchmark then that the present models are solving, but they solve this because they have all of this in the training data. And so an interesting benchmark could be the smallest system that is able to perform this benchmark while being able to read 20 gigabytes of text of its choice, right? Every human being, as we are, we don't read more than 20 gigabytes of text meaningfully in our life. And so by this thing being able to go to the library on the internet and check out texts, read Wikipedia or whatever, to get this additional knowledge, but the model itself needs to be really compact, right? And so can we actually as a community have a competition like this? What is the smallest engine that is able to understand text if it's allowed to look up things? And to look up basically as much as it wants, but not in an unreasonable way. Right? This could be a benchmark that is going more closely to this open-ended human-style thinking that is not putting everything into the training data, but it allows the system to build up its knowledge, which I think is where we want to go to.
This is great. Like, anyone has any comment to that?
I was just like, that I said that the current paradigm is kind of this agentic view, and I agree that it's good to, like, I feel like one way where we're very not open-endedness as a research community, like everything is converging on LLMs now, right? Like everybody's just like so many people are only doing LLM work, and I feel like that's a little sad that we like 12 years ago we organized this AAAI symposium where we talked about there's this whole anarchy of methods that people in AI use, because back at the day they were using like, there was a lot of variety going on, and now it has basically like 99 or 98% of the research community is focused on LLMs. And I feel like to be truly open-ended, it's really, I think, important that we keep like also other research methods alive, and ultimately that we don't end up in some kind of dead end open-endedness because we're only like focusing on basically LLMs. So yeah, I hope that we as a research community and also the A-Life community, they also embrace a lot of other methods. So I hope we can keep that kind of alive because we not know where things will kind of lead in the future.
Okay. Takashi, do you have any comments on that, like, or in general, like?
Yeah, well, I still, I was thinking that what Joshua was saying. Yeah, maybe, whether this, once you make a collective agents, and then whether that capability is increasing or not can be tested, right? So there are not so much, example that shows collective intelligence is we can measure, right? I mean, usually the collectiveness, decreasing the intelligence level. I mean, as you see in the faculty meeting, right? So, so I'm not sure whether the open-endedness is only possible when you have a collectiveness or not, right? But he was talking about the single agent, so that I was just wondering, how this is related to this. Because I'm always thinking that the open-endedness can be possible, only when there is a collective agent is interacting with each other. Because this new idea, as I said, is always pervaded by the noise, and the noise is coming from outside. And I'm answering to Sebastian. I agree, but I just want to know what's the definition of open-endedness still in the cognitive artificial life. We did have a strong workshop in artificial open-endedness until 2018 or something, but until that, since then that we removed evolution and we just say open-ended, right? And then, but still, it's not. It's almost impossible to prove whether that's open-ended or not, right? Whether the system is open-ended or not. And we just do you think we simply have to let it go for longer and longer to see it, or maybe like Joshua said, we do have to have like effective open-endedness, like like human beings. And so, I mean that's one of the topics that we have to think about in our society, right? Artificial life, but. Yeah, I just want to know your opinion about it.
Okay, and anyone wants to comment on this? Like that could be the last comment before I close this.
Okay, I'll take a question here. So Takashi, if you make a collective system, we make this amazing artificial collective intelligence layer, right? It's amazing. It's super open-ended, but all the branches that we discover are super boring. So I think there is a difference between making a tree that explores all the branches and the branches that are actually going to lead to something interesting. There is something about interestingness in open-endedness, right? So how about that, Takashi? What is that aspect of A Life dead as well? Like you said in 2018, A Life is dead. Remember that?
Yeah, but why I said A life is dead is because artificial life is always it's very maniac. People are looking into its own property of some strange model, right? And there is no such thing like universal class or anything, right? Physics and biology is always looking for universal classes, right? But artificial life is interesting because it's making like a taxonomy of everything, every strange animals they created. So I think the mainstream of artificial life should go to taxonomical studies or something. Don't go for like universal classes. Don't go for That's why I think because universal classes is usually it's boring. It's not interesting.
That's right.
Interesting thing is always exist in one or two simple but very complicated non-universal model that you can see in your model. Like mathematics. Mathematics is not universal. It's very different from each other, right? Physics is the only universal classes that they are trying to understand. But mathematics is not something like very strange theorems in the differential geometry or something, but it's not applicable to any other theorems in the mathematics. So I think artificial life is a branch of mathematics, not a branch of natural, natural science. I think that's what I thought, at that time. So I said, if you go for like, if you, your ideal, style of study
But that
in
shifted,
physics,
right?
this is not. Yeah, that's sorry. If my comment was too long. But.
Yeah. Response here, maybe?
Yeah, I suspect that artificial life might really have its best days in front of it. And in part, this in the old days, people discovered a bunch of really interesting paradigms like NCAs and linear and a lot of things in the space. But it's difficult to develop them and build a large community around them because at some point it gets expensive. And you can only code so much, and its artificial life is very playful and is not directed on building products or on solving cancer. And so it's difficult to get funding for it. And this is something that might change because right now you can basically dramatically increase the speed of discovery. Hardware is much cheaper than in the past. And we might have more time to play in this space. And we hope that something really interesting emerges. So I'm quite optimistic with respect to these artificial life paradigms, because I think what we need is playfulness to discover things. The areas where we are not playful, they become less and less important in the research because a lot of that can be automated. And so basically this collection of new training data, which was play is about, that has driven the A-Life community, I think can be a driver in the future that becomes much stronger.
In fact, we just talked about it in the kitchen, and most of this conference happens also in the back, right? So I'll mention that there are amazing conversations today that are completely hidden to the audience, but know that stuff is happening in secret here. No, and I agree with that. So I think there is something driving artificial life now, and we can apply it and make something work. So and Takashi is not saying anything, but he has built, or we have co-built an institute that is exactly directed towards that, and I haven't heard anything about it. So okay, so I leave that. I know that we're short on time, so I thank everyone, but yeah, to be continued.
Yeah, thanks so much.
So like I'll just give my final takeaways. Like, so Yosa is saying open-endedness is not enough if the branches are boring, and Takashi is saying that the interesting things are never universal. They are always strange and specific. I think that is actually a perfect place to land because it tells us something about what discovery layer needs. It does not just need to keep exploring, it needs to actually keep finding things that matter and figuring out what matters. That might be the hardest open problem of all. Going into tomorrow, like I'm wondering that like tomorrow at 9 we turn like all these discussions in a roadmap, particularly like couple of things which like are still playing in my mind as like ikigai, noise, desire, the refusal to output the average, the discovery layer. So yeah, like this is exciting. Today was the territory. Tomorrow we will choose where to build. Thank you all, and this is yeah. I'm very excited to see some of you tomorrow. Like like Olaf, like do we have our panelists or some of the panelists also joining tomorrow, or this
Right.
is
Yeah,
us close?
I'll share all about that, but I guess I'll let Tricia close for now since we're way over time. But
Okay.
yeah, thank you all for this. It was amazing.
Thank you.
Thanks.
Yeah, thank you so much.
Tricia?
So see you, Joshua, soon.
That's right. Yeah.
See you soon.
Ola, thank you. Ujwal, you seriously brought it home. You opened the day talking about giving us two concepts for us to focus on, which is dignity and sovereignty. And then you cap-ended that by getting us to think about wonder. And so I think those three words really just, started us off well and then end us off well. Is that like, here we are, for those of us on the East Coast, you and I, we are the survivors, but also you kept us up with the energy of thinking about how do we bring wonder into ACI for artificial collective intelligence. So 12 hours, 6 very long conversations that happened on camera. But clearly, Olaf is saying that there's way more tea happening in the hallways and things off camera. So, where are you going to give us an update on that? We should have been getting, these updates. So you're just telling us now. So clearly there's a lot more to be explored, and around the idea that intelligence is collective, intelligence is curious, intelligence is playful, and intelligence has to be kept humane through agency and refusal of extraction, and intelligence is embodied. And intelligence is also just really weird. And it's also really unpredictable. Intelligence is at risk of extinction. And as we heard from the panel with Kitano-san of Japan, where he gave us a timeline of 5 years for Japan. And Amber had said, well, we have a timeline of 10 years for much of the world's wisdom and indigenous communities to disappear. So, did we make progress on our objectives? And I would say for sure, when we're looking at the objectives for today, which is that we have to, one, establish artificial collective intelligence as a research direction beyond just monolithic large-scale AI agendas. And I would definitely say there was a consistent through line that we arrived at that. And I think Kitano-san really brought it home with saying, hey, part of your research agenda has to be reframing, local, hyper-local intelligence, embodied tacit knowledge. And he said there's the 3 T's to reframe that, which is you have to have terroir, you have to have technology, and you have to have, oh my God, my mind is blanking. Can someone help me with what was the first
Tradition.
T?
Memory you need.
Tradition.
Tradition, that's it.
Memory.
Tradition, thank you. Tradition, so tradition, terroir, and tech. And so these are the 3 T's that we need. Thank you for the collaborative emceeing. I'm glad we have a team here. And then, so we have a research agenda. And so Ujwal, you're clearly not starting from scratch. You have tons of hours of transcripts to analyze. But most importantly, I think that what, Olaf brought to life is that so much of intelligence and cognition is not documented. And we do not have a recording of those hallway conversations that is, really, truly hyper-local knowledge. So imagine if you had to start this research agenda without any of Olaf's, and his insights from the discussions that happened in the hallways, right? That I'm sure Amber was also a part of, and all the folks that are, on the ground in San Francisco, and perhaps also at Harvard as well. So the important thing here is that we also have to model that, is that we're not just going to look at the research agenda tomorrow based on the recordings. We're going to look at it based on the conversations that were had offline, the stuff that was not quantified, that was not documented. And hopefully also other, the speakers are now, it's inspired conversation because these are our friends. Hopefully they're also sending in thoughts being like, hey, I want to work on these pieces. And so the second objective was, to clarify the technical and institutional foundations of shared context, semantic coordination, provenance, consent, revocability, governed, abstraction, exchange. And definitely that was reached. It was very clear that we talked about the importance of provenance and importance of revocability, but that none of that will be possible if we do not have an approach, a technical approach around verification and protection to ensure that people can actually trust what the AI did. And there's a whole emerging field called verifiable AI, and this was discussed between Bruce Schneier and I around the importance of AI security, that we don't just talk about build AI, but we build a secure AI and build security in so that people can trust sharing all that knowledge. And the third is to examine why tacit expertise and institutional memory are safely critical, legally sensitive, and often collectively owned. And that was also definitely established by several of the panels. And we talked about this, I think with Kitano-san, he really brought that to life also with the example of what's happening in Japan. And also this builds on Olaf's research. So, and with that, Amber talked about why we have to have these human wisdom vaults, and that, and I think it was a really big push in the conversation, Amber, where you said it's not just about the hyperlocal would be seen as in opposition or potentially in opposition to the interests of humanity at large, is that if you actually set up the system in a way where we can connect the hyperlocal to the interests of humanity, then you ensure that the interests of the whole system is working together. And Kitano-san brought that to life with many of the examples that he gave of how local craft people frame their value, not by, saying that this is like this old crap, but framing it in the value of a global market, and was able to connect with people who would find value out of that. And so that leads us to the next objective of producing a concise ACI agenda, which Ujwal talked about. So we have so many points to take us there. And the next step is really for, I think I heard conversations of that some people are heading to Japan next. So that's super exciting. And with that, we're going to have all the documentation of the research. And I think there will be some kind of announcement, right, Ujwal, of what the next steps are. So with that, I want to thank you for joining us for this entire 12-hour kind of friends and family version of Superintelligence for Humanity. We'll be definitely doing this again. This was the first pilot. And thank you to all those who've offered space for our event. And we will see you at the next one.